Hello, everyone. How are we all today? Hopefully, we're doing well. And yes, as Naveria said, we've been posting a few joint solves between Tristan and I, and those have been a lot of fun to make. So hopefully, you have been enjoying those. If you want more Zeta content, that is a great place. We solved a Tall Cat Four Corners puzzle, and then we solved a Scott Strassal puzzle. So that has been going well, and actually, I think the next puzzle we're going to solve is an Naverio puzzle, so we can you can look forward to that, especially if you are named Naverio. Last stream we started with a few games of Wordle, but as you'd expect, there's been a good deal of sort of development in the Wordle sphere, so to speak, of games of this sort. So I thought we could start today with a game of La Turtle before we go on to do some Sudoku. So this is just like Wordle, but instead of being with words, it's with letters. So you can guess, for example, the letter is H. And so it'll show up in one of three colors here, and the colors will tell you whether the letter is right and whether it's in the right place or not. So if there is an H anywhere in this letter, it would have shown up as an H in yellow. If it were actually an H that were supposed to be here, it would show up as H in green. But otherwise, then we do this. So our goal is to, in as few guesses as possible, get to the letter by using this information that is provided from this. Does anyone know any letters that don't have H in them? I think that is the thing we are looking for here. So let's see. The stream suggests I think we should try Z. But it is not Z for Zeta. T for Tristan? No. M. Not M for Glum Hippo with the M capitalized. Let's see. Do we know any other letters? Or are we out of letters? We're almost spelling out like hazmat, almost. Yeah, darn, that one did not quite work out. Let's see, Q. It was not Q. Let's see. J. Hey, J. Sadly, not J either. So far, I've played this a few times, and my best score is 23. So I was hoping with chat's help I could do a little bit better. Let's see. Which vowel? Okay, so let's see. The most used vowel would be E. But if it doesn't have an E, then it probably has an A. Oh yes, that was a great double feature that unfortunately stole two puzzles out of my queue, but was a really cool pair of puzzles. Let's see. Well, it's got to be an O then, right? Hey, Zion, welcome. We won't tell anyone about your peeking in. We're currently trying to figure out what vowel is in this letter. It's not going well, though, because I feel like we've tried all of it. Oh, that's right. Y is sometimes a vowel. Oh, no. This is one of those vowel-free letters, apparently. Let's see. Do we have any other guesses? Let's see. Let's try an L. We'll get there eventually, possibly. I don't think I'm very good at the strategy of this game. That is that is my conclusion. G. Let's see, not a G. Let's see. What feedback do you get? So it shows up in gray if the letter does not appear in your letter. It shows up in yellow if the letter does appear in your letter, but it's in the wrong place. And it shows up in green if the letter does appear in your letter and is in the right place. Let's see. Let's try R. R is a good choice. Still not R. We're somehow really not going to break my top score of 23 on this somehow, I feel like. Let's see. Oh, S. How have we not tried S yet? Nope, not S. Let's see. How about D? N? How about F?
Hello, everyone.
Hello. This is impressive. This is okay. We're genuinely yeah. So far we've somehow managed to guess 24 different letters that do not appear in this letter at all. Uh, let's see. How about X? Okay. Apparently it was V. We got the letter correct in 26 guesses. Go us. Okay, so that is La Turtle. So I recommend you can practice and try and beat my score. You are actually trying to go for the lowest possible score, despite my efforts to the contrary. So I recommend you try that out. Oh, I didn't actually put the link in the chat. Here's the link so that you can play La Turtle. Okay. We left last stream on a bit of a cliffhanger because we had mostly but not quite finished this clover puzzle. So I thought to start the stream today, we could get to the gripping end of this clover Renban puzzle. So let's look at some Sudoku in this column. So there is no 3 here. There's no 2 here. Let's see. There's a 2-4 pair here. So that makes that a 3. And that a 4 and a 2 and a 4 and a 2 and a 3 and a 4. So for those of you who are waiting eagerly for the finish of this puzzle, you got Z in 13 guesses. 13 is way better than my top score. So there we go. Okay, so success. I seem to not have my... Do I not have my plugin enabled? One moment. Yeah, I do not have my plugin enabled. Sorry, 1 second while I fix that. Okay, there we go. Try to. Alrighty, so I had a birthday stream a week ago, but Playmaker just did not quite barely make it in time with this puzzle. So we're going to start today after the Clover puzzle finale with this Playmaker puzzle. Okay, so let's read the rules. So we have normal Sudoku rules. Oh, by the way, I should plug things before I get started. Speaking of normal Sudoku rules, so my most recent puzzle on Logic Masters Germany is a Schrodinger puzzle based on the Schrodinger puzzle that we did last time, plus the Renban puzzle. So it's like a combination of the Clover puzzle that we just did with the Schrodinger puzzle from last time that Simon also had a look at. So I recommend go having a look at that. It's called Arsha. It is my most recent Logic Masters Germany puzzle. Let's see. I would also like to say we have a Patreon, so thank you for those of you who've joined our Patreon. We've been very happy with the uptake on that. But if you want to join the Patreon, you can go to patreon.com/zetamath, and you can become a patron for as little as $1 a month. We appreciate you. We also appreciate if you would like the stream. That is a free way to do this. You can also get your friends to like the stream. And a fun life hack is that in order to like the stream, they don't even actually have to like the stream. They just have to show up and press the button. So if you could convince them to do that, that would also be appreciated. I think that is all the things I should be plugging at the moment. As I already mentioned that Tristan and I posted a solve a Scott Strassal puzzle. Yeah, I'll plug additional things as I remember. So let's continue reading the rules for Playmaker's puzzle. Hey, Playmaker. Hey, Alex, not named Simon. Let's see. So a black dot with an N implies that there's a 1 to N relationship between the cells. So these are in a 1 to 3 relationship. And then a white dot does something else. A white dot implies a difference between the two cells. So the difference between these two is 8. The digits along the lines have the same parity. So they're either all odd or all even. And then they're also consecutive with respect to their parity. I'm very interested by this 30-something cage in 2 cells. We'll get there. Digits within a cage don't repeat. So these 2 digits are different, we have learned. And sum to the small number written in the top left corner of the cage. Okay, so x is, so this is not meant to be read as 30x. This is meant to be read as 3 times x. So there is a value of x that works for all of these. So these sum to 8 times x, these sum to 3 times x, these sum to 38. Got it. Okay. And then the clue outside the grid shows the sum of all the digits along the indicated diagonal, and digits can repeat. So we've got multiple little killer clues ping-ponging around the grid. So I think the place I want to start is to note that the only digits that I could have that are 8 apart are 1 and 9. Now, interestingly, no matter what digit this is, if it wants to be in a ratio of 3 to 1, this digit is a 3. That's very adorable, the way that this sort of worked out. Now, this is an equiparity line. I don't think... Yeah, Playmaker does not give a name to these, so I'm just going to call them equiparity lines. I think maybe in a previous puzzle they were called parity party lines or something like that. I'm not sure. But there are no longer enough odds in this row for these to be odd. So these are even and are 2, 4, 6. I was going to say 2, 4, 6, 8, but they're not 8 because there's an 8 in the box. By the way, this is a given. If you've not seen how this constraint works before, these 2 digits here are digits which tell you what digit goes in that cell. So parity confetti. Parity confetti. Got it. Okay, so 3 over here. Oh, that's right. I want to change the setting so that the large digits are off. This is a trick that Sven taught me, which is that if you have these corner pencil marks, they normally overlap with the totals of killer cages. But if you turn large digits off, it does not, in my eye, make the digits significantly smaller, but it does make them not overlap with the totals of cages, which is a helpful life hack. And hey, Jessica, welcome. Okay, so let's think about what the possible values of x are. So I can make 3x in 2 cells twice. So really this is saying I can make 6x in 4 cells. So x can't be 1 because I can't make 3 twice. Let's see, but x looks like it could be 2, right? If this were 2, 4, and 1, 5. Let's see, I'm going to consider this in a second, but I'm going to write the candidates up here. So I'm going to just color this cell up here. Yes, there's one value of x that applies through all instances of x in the puzzle, is my understanding. I think that's what this phrase, where x needs to be deduced in the rules, is telling us. I was about to say, well, x can't be 3 because there's a 3 in the row, but then I understood that, in fact, actually, this is not a real cell. This is just my taking notes myself. So I think x can be 3, 4, 5. Okay, now what's the biggest x can be? Well, I can't make these 2 cells sum to 18. That would be too many. So actually, yeah, sorry, I could do 5, in which case these would be 7, 8, 9 for these exactly. Okay, so so x is one of 2, 3, 4, 5. Hey, Grockles, welcome. Hey, Jessica, if I didn't say that, I meant to say hey, Jessica, but then I'm not 100% sure. By the way, I'm going to go ahead and make this cell where I'm recording the x the bet cell if you want to bet. So now we have to look at the 8 cages, and we have to ask ourselves, okay, what values of x could this be? Okay. So if x is 2, this would sum to 16. I can definitely do 16. If x is 3, this would be 24. I think I can do 24 and 5. Did I do something wrong, Playmaker? Hey, Shoots, welcome. Let's see. In 4, this would be 32. I'm pretty sure I can do 32 and 5. But as Alex points out, I definitely can't do 5, because then that would be saying that these sum to 40. And so 40 is not something I could do in 5 cells. So no 40s go here. Okay, now I want to look at what impact this parity confetti issue is. Because these digits actually have to sum to more than normal. So the minimum of these 3 is not 6 like it normally would be. It's actually 9. And so does that... So these 3 sum to at least 9. So these sum to at least 11, which gets us down to, no, this could still be like 34 in that instance. So that's not going to work. Okay. Now, probably a smart Zeta would have filled in row 2 like an hour ago, because row 2 actually only has a tiny number of digits left, which are 2, 3, 4, 5, 6, 7, 8. Okay, so how many ways are there to make these digits sum to a multiple of 3? That's probably a good question. So 8 is 2 mod 3, 5 is 2 mod 3, and 7 is 1 mod 3. And so I definitely need to have the 7 in here, because in order to get to a multiple of 3 with numbers that are 1 more than a multiple of 3 and numbers that are 2 more than a multiple of 3, I need one number that's 1 more than a multiple of 3 and one number that's 2 more than a multiple of 3. And so I only have one option of numbers that are 1 more than a multiple of 3, and so that's not a 7. Okay, but that means that this is either 5, 7, in which case x is 4, or it is 7, 8, in which case x is 5, except x can't be 5. We ruled out x is 5 thanks to Alex's observation about box 5. So in fact, x is 3. So that means that in fact x is 3. I'm going to leave this up here just for a second, just so we can remember that x is 3. And so that means, sorry, 4. I can divide 12 by 3. Who says that I can't divide 12 by 3? 12 divided by 3 is 4. Take 2. In any event, these aren't 8, so this is an 8. Okay, and so these sum to 24. This sums to 32. Okay, so if this sums to 32, then that means these cells sum to a total of 13. Okay, I bet we can figure out what's going on here. So what are the options? If I need all 4 of these to sum to 13, if this is an odd line, then it could be 1, 3, 5, in which case this would be a 4. But 3, 5, 7 is already too big, because 3, 5, 7 sounds like 15, and 15 is more than 13. If this is even, it would have to be 2, 4, 6. 2, 4, 6 is 12, and this would need to be a 2. Oh, wait, but that doesn't work. If this is 2, 4, 6... I did not add to 13 correctly. Let's try that again. 2, 4, 6 is 12. This would need to be a 1. Okay. So this cell is actually always a 1 or a 4, based on whether this is 1, 3, 5 or 2, 4, 6. I'm going to let chat yell at me if my math was wrong there, because my odds are not great based on how the stream is going so far, but we'll see. Okay, but these sum to 12, these sum to 12, etc. Let's see. Okay, so the 8 is in here somewhere, just by our old friend Sudoku. Let's see. Okay, so these two sum to 7. Don't know if that is immediately helpful. Okay. Our ways to make 12, by the way, are probably... Isn't that what they say about engineering grad school or something virtual? Let's see. So, I'm not allowed to use 137 for the odds because the odds have to be quote-unquote consecutive odds, Xeon. Which is the thing about these lines that always trips me up when they show up. But I can't. I have to use adjacent odd numbers. Let's see. So these also need to sum to 13. Let's see. And there's lots of ways to make 12, right? There's 5, 7. And so those of you who've watched the latest Tristan and I Solve video will see me being slightly cautious because I claimed I had exhausted all the ways to make 11 and missed one, and it led to disaster. So these are either 5, 7 or 4, 8 or 3, 9. I think those are really the only options. Let's see. Yeah, so a 10-minute detour is a very lovely way to describe it. Oops. 3, 9, 4, 8, 5, 7. Okay, that's not 3, that's not 9, that's not 8, so that's not 4. Let's see. Well, don't worry. I'll only be streaming for most of the day, so you'll have plenty of time to transcribe later. Let's see. Am I supposed to make, like, there's got to be a 6 in here somewhere. I don't think that's immediately helpful. There's lots of ways to make 7. I was super happy with this, like, this collection of givens to start with, but now I'm not quite sure. Okay, so maybe this is an interesting question. Okay, so if this is 1, 3, 5, the 3 has to go here. Is that interesting? I don't know. In box 4, 7, and 8. You have to maximize those. I don't think I see why yet, but I will record for posterity that these 4 digits also sum to 13. A little, like, make your own killer cage. Oh, for the diagonal, there's a diagonal. Oh, who knew about that? There is a diagonal. Okay, good point. Okay, so look closely at the puzzle. And look at all the clues, not just the clues that are inside the grid. Sometimes there are clues outside the grid. Okay, so the maximum this could sum to, as Alex points out, is 9 plus 7 plus 5. 9 plus 7 plus 5 is 21, which would mean these two would have to sum to at least 17, which is just possible. The other option, if I try and make these even, would be if I try and maximize them at 8, 6, 4, which would sum to 18, which would mean these would have to add to 20, which will not work. So, okay, I agree with the chat assessment that these are 5, 7, 9. And ergo, these two cells, in order to make that work, have to be an 8-9 pair. And I'm going to go ahead. Okay, I think I know now that x is 4. we'll see if I remember that. But I'm going to color these because this 8 and 9 I know are different. And the fact that this 8 and 9 are different might be useful. So, for example, this cell that I have pencil marked as a 1 or a 4 is not an 8 or a 9, which is not immediately helpful, I will grant you, but could be helpful someday. This cell's also not an 8 or a 9. I would have actually preferred these be the same because it would have pinched it out of this 8x cage. Now, this is a 32 cage. Does a 32 cage in 5 require a 9? What's 8 plus 7 plus 6 plus 5 plus 4? Should be 6 times 5 is 30. Yeah, that's not enough. So I do need a 9 in this cage somewhere. So that's not a 9. I think I did that right. Hey, Friar, welcome. If this did not have a 9 in it, it would be max 8, 7, 6, 5, 4, which would be the same as 5 times 6, which is 30, and 30 is not 32. So this is not a 9. Now what that means is actually in both of these boxes, one of these two cells is a 9, because I need to have a 9 on this confetti line, and I need to have a 9 in one of these two. And ergo, this can't be 9 anymore. So that's something. Can I make 13 and 4 with a 9? I cannot make 13 and 4 with a 9. Ah, yeah, that's the... Okay, yeah, I agree, Cable B. That's a much easier question that requires less finding the middle of a sequence and multiplying it by 5. Let's see. Row 9, column 1 can't be a 9. Ah, yes, this can't be a 9 because it sees the 8-9 pair. Okay, so what about an 8? Can I get rid of 8? So let's do the Cable B trick of instead asking, is it possible I put an 8 out here? Oh. That's huge. I did not... So I unhighlighted my imaginary 13 cage, which I realized I should have drawn in like this. But this 13 cage has a 5 in it. So there's definitely no 8 here. Well, sorry, it has a 5 or a 7 in it. It definitely can't also have an 8. So there's also an 8 in here. Okay, now, why did I find that at all useful? Oh, I don't think that was actually useful at all. I think it was only useful... this is not an 8, by the way, because there's an 8 in the column. I think it was useful for 9 because I knew about the 9s on this. I don't think knowing that there's an 8 in here is super useful. See, if this was a 7, these would have to be 1, 2, 3 exactly. If this was a 5, then these would need to add to 8. That's not super exciting. Hey, John, welcome. Let's see. Trying to decide if these do anything interesting with this line, but I don't think so. Now, we did say there's definitely a 9 in this cage somewhere. For the same reason, that there has to be a 9 in a 5 cage. But unfortunately, I'm not sure that immediately there having to be a 9 in here is useful. What are these? Oh, I don't know what these two cells sum to. I know that these cells sum to 24, but maybe that's interesting. Maybe I should ask about 1s and 2s in this row. Can I put a 1? Well, I can't put a 1 in a 32 cage. So the 1 in this row is in one of these two cells. That is... again, minimal. Let's see. Christoph says there's a virtual 8-9 pair in column 1. Yes, agree. So at the very least, that's not an 8, so that's not a 4. Because there's an 8 or a 9 here and an 8 or a 9 here. And then in row 9, we get the same deal. Let's see. We can again fill in that this is a 5-7 or a 4-8. Because this can't be a 3-9 because there's definitely a 9 in the box. And this can't be an 8, so that can't be a 4 either. Now, I think we know that these two cages have to be different. Because if these two cages are the same, what are they? Well, if these two cages are the same, then they're either 5-7 or 4-8, which would push 5-7 and 4-8, 5-7 or 4-8 into this area where they cannot go. Because remember, this line is either 1-3-5 with a 4 here, or it is 2-4-6 with a 1 here. Neither way works. So actually, these, I'm going to make them orange and purple. These are different. Someday I will make it to the mute button before I sneeze. Someday. Today is apparently not that day. Okay. Thank you. Okay, so this digit here is not any of those digits. It is not 4, 5, 7, or 8. So mark 8s in box 5. Yeah, where can 8s go in box 5? Oh, 8s are never in... I just went over all the combinations for this. 8s are never there. So 8s are always in this cage as well. Now, it's not there because 8 is one of the digits that's definitely between orange and purple. So 8 plus 9 is 17. Yeah, as far as I can tell, Ambrose, so I would like to be able to say something like this, but I think this cage is allowed to be 3-9, I think. Does something break if this cage is 3-9? If so, please let me know. Our operators are standing by. Let's see, if this cage... Okay, actually, yeah, this cage... Yeah, actually, sorry, this is completely right. You're right. For exactly the same reason, this cage can't be the same as orange because it would, again, exclude that from here, and then I would be placing 3 and 9 in here. Sorry, I would be placing 5 and 7 in here or whatever. So yeah, that's not going to work. And so this is the third flavor of 12 cage, which is going to be green. But I'm not going to need to pencil mark it for very long because, again, if green and orange were the same, that would put those digits down here, and I just can't put 5, 7, or 4, 8 down here. So therefore, green, by the way, more simply, green is not purple because they're in the same row. So this must be 3-9. That is really nice setting. So these aren't 9. And so one of these is a 9, which means that's a 1 and that's a 9, which means blue is 8 and yellow is 9, which means this cell is not a 9 and this cell's not an 8. Let's see. So now 9 only goes here in this box. Yeah, that was a super clever setup. Okay, so What are the values that the cell can have? Not sure yet. Okay, so this is, so this is a 9. I know that's a 9 now because I need a 9 in the box there. That's not a 9. So these are a 5-7 pair. Let's see. I hear tell of a 38 cage that's missing a 3 and a 4 from Andrew. I'm not sure I see why. Let's see. Oh, 5-7 pair in column 2. Excellent, excellent. Great catch, Vidar and Ambrose. So that makes this cell a naked 8 because of the 5-7 pair, which makes that a 4, which now makes this a 5-7 pair to make life work out. So that places the 8 over here. So yeah, so these add to 15. And so by the secret, these add to 15, 27, 39. So these two cells need to add to 6, if I did that right. And they can't be 2, 4. So these two cells are 1, 5. Now this is not a 5 because, and I love every time this comes up, this cell looks at the 5-7 pair. It sees both of those cells. So this is the 1 and this is the 5. I may have done that in a more circuitous way than it strictly speaking needed to be, but I'm happy about it. That is a 1. Okay, so these 3 cells, I know what they are. They are 2, no, not 2, not 3, 4, 5, 6, 7. Which means that these can't be even, so they must be the 1, 3, 5 flavor, which means that this is the 4 flavor over here. That's not an 8. That's not an 8, so that is an 8. Just cleaning up pencil marks over here. So interesting, this cage can't have a 3. I'm trying to decide why. So 3 is certainly ruled out of those places. But why can't 3 go over here somewhere? Let's see. 3 in box 5. Ah, yes, we made this note earlier and then forgot about it. It's a good catch, Nicholas. This is the 3 here. From that, who's a what's it? So there's a 3 over here somewhere. Let's see. Many good things are happening. Let's see. 3 down here in box 8 is placed by Sudoku. So let's see. So that places that 3. Okay, so okay, so if this is, so I think Andrew's point is sophisticated, but good. If this is a 7, then this must be 1, 2, 3 exactly. If this is a 5, then these need to sum to 8 without using a 5. And so 8 without using a 5 would be 1, 3, 4. So actually, by a sort of complicated case analysis, there is a 3 inside this cage. And it has to go in one of these 2 cells, which does indeed place a 3 here and a 4 here. Let's see. So that is a 4 here. That's not a 7. What are the cells left in this column? We need a 2, 3, 4, 5, 6, 7, 8, 9. Okay. I think 2, 4, and 6 is the answer. Let's see. The X-Wing on 3s. Ah, yes. The X-Wing on 3s, because there's a 3 here or here and a 3 here or here. They look into here. Those aren't 3. That is 3. Good point. these need to add to 13 in total. So there's another sort of imaginary 13 cage here, if you will. So these 3 cells add to 10. They definitely include a 1 because I can't put a 1 in a 32 cage in 5 cells. So there's 2 more digits that add to 9. Those digits are not 3, 6, or 8, 1. So they're either 2, 7, or they are 4, 5. Yeah, that's not super helpful immediately. Let's see. Oh, 4 in box 8. Let's see, 4 in box 8 is definitely in... it's definitely in one of these 2 places, and it's not in this one because there's already a 4 in the row. Good catch. So all cells in the 32 cage in box 7 see if... Ooh, beautiful, beautiful. Okay. That is an excellent catch, Andrew, and a beautiful setting, by the way. 4 pinches 4 out of this, which means there is a 4 here, which means this is not a 7. It's a 5. The way I know that is if this was a 7, then I would need these to be 1, 2, 3, and then I would have locked 4 out of the entire box. So that's a 5, that's a 7, that's a 5, and that's a 7, and these are 1, 3, 4. That one's not a 3 or a 4, so it's a 1. So these aren't 1. Let's see. I don't think this 3, 4 is resolved yet, but we can go ahead and write in what's in this cage. It has a 2, 6, 7, 8, 9. These aren't 8. These aren't 9. That's not 9 either. These aren't 7. So that's a 2, 6, 8 triple. So these aren't 2 or 6. These are a 7, 9 pair, and it's resolved 7, which resolves the 5 and the 7. Let's see. Don't see that yet. But these 2 cells I can go ahead and write in. So there's a 1 and a 5. That is a 5 for the fancy reason that there is a 1 in the box. So the bet cell was a 1. So congratulations to anyone who guessed 1. Okay, 2, 3, 6 to finish this box. This is not a 3, so it is a 2 or a 6. Don't see anything going on there quite yet. Let's see. What goes in the rest of this box? We still need a 2, a 4, a 6, and a 9. Let's see. These are not 9. Don't see that quite yet. Okay, what is left in this box? We still need a 1, a 5, a 7, and a 9. That one's not a 1. That one's not a 9. Let's see. I can make a 2, 6 pair in row 9. That sounds fun. Let's see. So I think that's going to amount to... writing this out. These are a 1, a 2, a 6. This is not a 1 owing to the 1, 5 pair looking down at it. That's not a 1 owing to the 1 looking at it. So that is a 1. So that 2, 6 pair also has this 2, 6 pair, which is going to make this a write-in. It is a 1. So that's not a 1. Let's see, I heard something about a digit glaring at something. Where did the glaring come? 5 glaring at the 1, 5 in column 4. It's a very angry 5 that is glaring. So that makes that a 1 and a 5. Let's see. 1 is placed in box 3. Oh, so it is. I've removed 1 from almost all the places. I've clearly not removed 1 from a place I was supposed to remove 1. Let's see, column 7. Oh, these are not 5s. I can do that. Is that progress? It's kind of progress. That's not a 4. I did that. Let's see, which sees the 5s in row 1, column 5. Hey, let's... Five in box 2. Okay, where is 5 in box 2? Okay, there's lots of 5s. So the 5 in box 2 is in one of these 2 cells. But the 5 in box 3 is in one of these 2 cells. So that's not a 5. So there go, that's a 5. There go? Is there go a word? I'm pretty sure there go is not a word. But we're going with it. There go. This cell has to be a 2, a 6 or a 7, or a 9. It's not a 9. Sorry, there's a 9 in the column. Okay. Pencil marks in box 3. Oh, I think that was answering how I knew that the 5 went over here. And someone points out that I should actually at some point look at the little killer clues. If I must. So these total to 8, 12, 13, 18. So I need these 5 cells to sum to 20. Let's see. If I minimize them, they sum to way less than that. And if I maximize them, they sum to way more than that. I think I can maybe put this off longer. Let's see. These 3 cells, I need to sum to 23. 23 is an awful lot. In fact, I can't get to 23 without a 9. So the 9 has to go here. And now these 2 need to sum to 14 without using a 9. So it's not 5, 9. So it's got to be that these are a 6, 8 pair in order to make that work. And that's resolved by this 8 looking at it. So that is a 6, and that's an 8. That being a 6 means that's a 6. So, wait, what? Did I do that wrong? I thought I mathed that right. I did not. 8 plus 8 plus 7 is... Oh, no. Oh, yeah. Hey, how about that? So, sorry, let's try that again. So, I do need these to add to 23. No, I don't even need them to add to 23. No, I do need to add, do need these to add to 23. But it's true that if these were all in a box and I wanted them to add to 23, they would need a 9. But because they span boxes, I could actually do double 8 and 7, and then it would work. If I could actually do that. Except... Oh, sorry, this one can't be 8 twice, which is not helpful. But that does mean that at a minimum, these cells have to be at least... Because the maximum these 2 can sum to is 15, so this cell needs to be at least an 8 or a 9. Always. And then the least this cell sums to is 8, so that would be 16 plus 7 is 23. So I need these to sum to at least 15 without using a 9. So they are... Wait. If I need these to sum to at least 15 without using a 9... I must have done that math wrong. 15 plus 8 is 23. Oh, sorry, no, 15 plus 9. There we go. That's what I did wrong. At least 14. Because I minimized this instead of maximizing it to minimize these. If this is a... So let me say that again, just because I think I said this as incoherently as possible. At maximum, these 3 cells sum to 24, which means at minimum, these 2 cells sum to 14 without using a 9. So these are from 6, 7, 8. That one's not a 7. That one's not an 8, just by Sudoku so far. So I'm encouraged to look at the parity of the long diagonal, which is a very clever idea. Okay, so even, odd, even, 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 even. So the sum of these 2 cells in black, the sum of the 2 black cells has to be even. So either... Oh, and this one's always odd. I don't know how I didn't notice that. So the sum of these 2 cells has to be odd, and sorry, has to be even, and this one's odd, so this one has to be odd. So that's a 3 and that's a 4. That is very clever setting as well. The 1, hey Christian, welcome. The 1 in row 5. Yes, the 1 in row 5 is here. Excellent. You can be deblackened. Let's see. That looks up there. So that gives us a 7-9 pair in this box. So that's a 5. This is a 1. That's pretty cool. So... yeah, so these needed to sum to 10, right? I think these needed to sum to 10. Because I needed total for all of these to sum to 13. And so, yes, so this is a 4, just to make the killer math work in the row. So that is not a 4. These aren't 4. Let's see, 5's looking into box 9. Oh yeah, there's 5's all over the place. 5 looking there. Good point. Okay, is that all the 5's? That is all the 5's. Okay. 4 in box 2 now. Yes. We've got lots of 4's too. We've got almost all the 4's. This 4 is placed here. And then we've got one more. Yeah, this 4 is placed here. Okay, so we've got all our 4's. Let's see, how about 3's? Do we have all those? We're missing 1 3, but it goes there. So good, good cleanup on those. Let's see, what about 7's? We've got a lot more latitude on 7's, unfortunately. We have a lot of 8's and 9's. So the 8 is placed here by Sudoku. So that is something. Where about the rest of the 8's? Yeah, one of those 2's an 8, one of those 2's an 8. So we've got a little X-wing on 8's left. 9's. Yeah, I've got just a little bit of cleanup to do on the 9's. Row 7, column 7 is 8 by the 7-9 pair. Yes, excellent. The 7-9 pair here sees that this is an 8. Thank you, Carl. That is an 8. So that's not an 8. So that is an 8. And so that's all the 8's now, I believe. Let's see. I'm being encouraged to look at this little killer clue again. Sorry. Let's look at this little killer clue again. So 8, 8, 8 is 24, 31. So that's a 7. Okay. I don't think they really wanted me to look at this little killer clue. I think they just wanted me to look at that one. Okay, what are these two digits? These are going to be a 2 and a 6, aren't they? Because everything is a 2 and a 6. Let's see. Now look at 9s in box 9 again. Let's look closelier at 9s in box 9. Yes, because of the 7-9 pair here. That's what I was supposed to see. So that's the 9. This cell's going to be a write-in. It's a 7. These cells are probably going to be a 2-6 pair. Let's see. So 9s again. Yeah, we've got our 9s here. What about... This is not a 4. Yeah, okay. And then this cell is not a 1, but could be a 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a 2, 6, or 7. I don't think I can do anything about that. Okay, so now I think I have done everything I can do without looking at this diagonal. So let's look at this diagonal. So that is 12, 16, 17, 22, 25. So these cells need to sum to 13. So 9, 2, 2 would be fine. Let's see, if I minimize these two at 7 and 2, that would make them 9. And this still couldn't be 6. Eight X in row 3. Wait, how is there any... Oh yeah, this cage has to work out. But this can't be a 6 anymore. Because, sorry, someone in chat was talking about this cage, and then I was confused. But this can't be a 6, because if this is a 6, this is too big. So this is a 2. And so now I don't need 13, now I need 11. So I need these two cells to sum to 11, and the only way to do that, although don't trust me about things that sum to 11, in fact, actually, this is the sum to 11 that got me in the video the other day, so I like to think this was a deliberate sabotage. But anyway, that finishes this diagonal. So this is not a 9, so that makes, because of this 2-6 pair, that's a 7. That's not a 7. Let's see. So that's a 7. Okay. Okay, how is there more digit? Oh, okay, that's a 6. That's a 7. That's a 2. There we go. That's where everything sort of starts to fall apart. So that's a 6. Look up this. That's a 2. That's a 6. That's a 9. That's a 2. That's a 6. That's a 2. That's a 6. That's a 2. That's a 6. If only I was turning 26. Was I not intended to end up with 2 6s everywhere? Hey, Jason, welcome. Let's see. That 6 looks down. See, so that's a 2, and that's a 6, and that's a 2, and that's a 6. Beautiful puzzle. I really liked that. And these 3 killer cages was very nice. Hey, Afraid Not. You might be a little bit behind on the VOD if you're getting back to where I was talking about at least 14. Although I realize if I say you're a bit behind in the VOD and then you hear me say that 10 minutes later, it's not necessarily helpful. I'm 26 in base 16. I can go with that. Yes, very nice. Good way to start. Let's see. Okay, so... can I restart the timer? There we go. Okay. So... next up today, we have something special from Qodec. And so in this puzzle, we have normal Sudoku rules. And then we have these clues outside the grid, and the clues outside the grid are one of 2 flavors of thing. So the 2 flavors of thing they could be or they could be an X sum, in which case we have something like this. So that's a 2 and that's a 5. Let's see. I bet I could get you a link. Maybe, possibly. Usually Tristan does that, but I think he's not presently around. Sorry, one moment. I have to pull up my list and see if I can find it. Oh, there he is. Tristan will pull up the link while I explain what an X sum is. So an X sum says, okay, I'm going to sum this many digits. So if this was a 2, this could be a 5, and it would say the sum of these two is 7. You'll be very familiar with X sums if you watched Mark and Simon Solves yesterday, where they both did fascinating X sums puzzles by Christoph Seeliger. Who is also in chat. And the other flavor is sandwich clues. And so a sandwich clue gives the value of the sum of the digits between 1 and 9. So if, for example, I had a 1 here, a 9 here, and a 2, 3, 5 here in the middle, that would make this 10 clue correct. Because between the 1 and the 9, the sum of these 3 digits is 10. Now, every clue in the puzzle is either an X sums puzzle, is either an X sums clue or a sandwich clue, and it is up to us to deduce which they are. Except, here's a fun fact: you cannot ever have a 38 as a sandwich sum, because the sandwich sums the digits between 1 and 9, which means it excludes the 1 and the 9. Which means the maximum, that a sandwich sum can sum to is 35. Oh, could be both. Sorry. Or both. Okay. I assume not that many of them will be both, but who knows? So, in other words, this can't be a sandwich clue. It's too big. So, this is an X sums clue. And so, how many digits do I need to get a 38? Well, I need at least 6 digits to get to 38. I can't get to 38 with fewer than 6 digits. And so, that means that this is a 6, 7, 8. Okay, and I also, spoiler, cannot get there in 9. Because if I add 9 digits, I'm always going to get 45. Okay. Now, the funny thing about this, and Andrew's pointing this out in chat, is that means this is also an X sum. I don't know if I want to color these, but I'm going to. Purple. Oh, I can't color them because I think I want to do crust coloring. So we're just going to have to remember this is an X sum. This also has to be an X sum. And the reason why this also has to be an X sum, is that if it weren't an X sum, a sandwich of 35, the only way that works is if you have the 1 and the 9 on the outside. And I can't make this a 1 or a 9, so this won't work. So likewise, this is also an X sum. So while we're figuring out how this works, in order to get to 35, I need at least 6. And I can't do 35 and 8. 35 and 8 would be too many. Okay. But this is not a sandwich for the same reason. It could only be a sandwich if these two were a 1-9 pair. But then that would break this 20 clue, whatever it was. It couldn't be an X sum anymore or anything like that. Okay, so this is a 6 or a 7. Now, an interesting question to ask is if I added this entire column, what would happen? And so if I added this entire column, well, I would get 45 plus the overlap. Okay, so 35 plus 38 is some number. 35 plus 38 is something. Oops. Can't put an equals on my keypad, apparently. 35 plus 38 is 73. I'm putting that in chat so I can keep track of it. So 73 minus 45 is some number. That number is 5 plus 23 is 28, I want to say. If I did that right. I think I did. Which means the overlap, that is the things that are in both of these x sums, is 28. Now, I think that should be useful, but I'm not quite seeing it yet. Okay, so but it is interesting. Okay, so, by the way, I am going to start marking things that are definitely not 1 or 9. These are all definitely not 1 or 9. Oh, by the way, 34 is not a valid sandwich total either. This one's slightly more complicated, but because all the possible sandwich digits, 2 through 8 sum to 35, you can't get 34 because you can only take out a minimum of 2, which would drop you to 33. So this is also at least 6. Oh, sorry. People were saying before these could be 5s, and they were completely right about these being able to be 5s. Apologies. This is the same deal, though. It is 5, 6, or 7, and is an x sum. Yeah, I somehow, I don't know why, I was thinking there's 4 outies, so therefore it has to be at least 6, which is not how subtraction from 9 works, but there you go. So, that is an interesting combination of things to start with. Now this 20, I don't actually know. Row 1, column 4. Oh, can't this not be a 5 because of the 38 below? That's possible. Yeah, so the interaction of these two is interesting. Okay, so if this is an 8, that would have to be a 7. Okay, so let's see. How would this work out? If this is an 8, this would have to be a 7 in order to make the outies work. But now this 7 would be looking for outies of 10, and so that would have to be a 2. I think that's fine. If this is a 7, I'm now looking for outies of 7. So if this were a 7, this would have to be a 1 or a 2. It's more complicated than I am immediately inclined to think about. Right. Okay, so that's a good point. Okay, so Calzone summarizes this concisely. If this was a 5, it would have to be 5, 6, 7, 8, 9, and then I've ruled out all the candidates for that. Thank you, Calzone. That is nicely done. Okay. And then Carl has another nice point, which is a tricksy x sum point, which is that if you try and make a 34 x sum in 5, then what you're really trying to do is you're trying to make the outies sum to 11. Well, what are the outies? The outies are, in that case, 1, 2, 3, 5. But that's a problem because you put a 5 here. So this actually can't be 5 by tricksy x sum stuff. So this is the inverse of the fact that you can't make an 11 x sum in 4, which is, I think, the one that shows up most in my x sum experience, at least. Okay. So what if this was a 6-7 pair? If this was a 6-7 pair, then one of these would be looking in the 6 direction, or 5, 6. One of these would look like that. 2, 3, 4, 5, 6, 7. One of these would look like that. So if these were a 6-7 pair, the overlap would be 4 cells long and would need to sum to 28. Is that possible? Because if the overlap is going to sum to 28, then it would be at maximum 9, 8, 5, 4. And 9, 8, 5, 4, 18 plus 8 is 26, which is not. Right, okay. So here's the math I just did, just to explain this, and this worked out nicely, and it's going to get us our first digit dance. These can't be a 6-7 pair, because if these are a 6-7 pair, then, and I don't care what order it is, there's an overlap in the middle of 4 cells total, and those 4 cells have to sum to what? They have to sum to, we calculated this before, they have to sum to 28. You can scroll up a little in the chat, and I typed the math for it in chat. But they can't get to 28 because the absolute maximum they can be is 8 plus 9 plus 4 plus 5, which is only 26. And so what that means is that this can't be a 6 or a 7, it has to be an 8. And so we get to do digit dance. And now, even better, because that's an 8, we know that this is a 7. And because that's a 7, we know that this is a 2. And so we spew digits all over the place. So that all works out rather nicely. And we get our official digit dance. I'm going to take a very short break. I will be right back, though, so you can have fun looking at the puzzle. And also, if you want, you can play the turtle to entertain yourself and post your scores in the chat. See who can beat my score of 26. I'll be right back. I have returned. Thank you, by the way, to all of our patrons. We really appreciate the support that we've been getting. Great appreciation to all of you. Okay, so here the outies need to sum to 11. Oh, thank you, David. I'm glad you're enjoying the math videos. We are still in the process of making them. Fear not. We are currently working on our complex integration video. In fact, actually, my producer is, I believe, working on that as I solve these puzzles. But hopefully you also enjoy some Sudoku. Let's see. Okay. So this I know is an X sum. But I don't think I know a whole lot more than that. Okay, at some point, I think we're going to have to find some additional information to finish the puzzle. Uh, that is my conjecture. We got off to a very nice start there. But the continuation is not going as well. Let's see. Am I supposed to note something about a 9? Not sure. Let's see. Everything else looks very plausible. Now, here's a point that I think is going to be very relevant in these rows and columns, which is that a sandwich clue doesn't care what side you start from. Can I make the rules larger? I don't think so, but if anyone can make the rules larger or tell me how to make the rules larger, it's Kilroy, who I see is here. So... Hey, Ranksk. Work pays you, but solving Sudoku... Or, sorry, watching Sudoku streams doesn't... That is really a great injustice, I feel like. Yeah, that's what I was just saying, was that in these columns where the opposite clues don't match, one of them has to be an X sum. And that's because a sandwich clue doesn't care what side you start from. And so if you start from one side or the other, it's still giving you the stuff between 1 and 9. And so these can't both be sandwich goodness. One of them is an X sum. Now, what on earth good that does me, I have yet to decide. Is it somehow impossible that both of these are X sums? No, these could both be X sums, because this could be 2, 5, this could be 3, 1, 4. Likewise, these could both be X sums. Hey, Directionary. I started stream today with a game of Le Turtle, which I believe I learned about from your Twitter, if I recall correctly. Amusingly, I came across your Twitter in a context completely unrelated to Sudoku, because you got retweeted by God, who's the guy who does all the algebra fact stuff? I can't think of his name anymore. But anyway, we played a game of Le Turtle, and we got the worst possible score. It was a V, and it took us literally 26 guesses to get to the V, which was very unfortunate, even with all the information that we got along the way. Okay, what about a 10 and a 7? So this would be great if I could find a pair where one of them has to be a sandwich. That's my hope now. Is it for some reason not possible to make both a 10x sum and a 7x sum? So like this could be like a 2, 5, and this could be like a 3, 1, 6. No, that's very possible. It's very possible. Okay, what about this 3? If the 3 is an X sum, the only way it works is if it goes 2, 1. But that doesn't seem problematic either. Okay, Qodec, what do you want from me here? And unfortunately, the digits that I know basically anything about are completely isolated from the rest of the grid. Let's see. So it was pointed out this could be a 5 if it's 5, 6, 7, 8, 9 in some order. Which still I don't think would break the 20 clue. I think that would be fine. In fact, I think the 20 could still even be either an X sum or a sandwich. Okay, so people are suggesting looking at the two clues in boxes. So the 3 and 8, it is claimed, cannot both be X sums. So if the 3 is an X sum, it would go 2 and 1. And now this 8 has to be in at least 3, but it can't be because it needs a 1. So I agree. So one of these, at least, is a sandwich clue. And Andrew is saying, sorry, and Dictionary is saying, I think the same thing applies over here. I think these can't both be, like, could I do that? That looks fine, except for the putting the 2 4s in the box part. But yeah, I think I cannot make these, because these digits will sum to at least 15. They'd need to have a 1 here. Yeah, so here's the way to prove it. These 5 digits sum to at least 15 because it's 5 different digits. But ergo, it can't be that if I sum these and sum these, I get 15. So yeah, exactly as Dictionary says, these sum to a minimum of 15, which looks great until I realize that this cell is double counted. So that's not going to work. So at least one of these is a sandwich. Let's see. And I think I came up with an example before to say that this is very possible. I think I can do that. So these could both be X sums if they wanted. Oh yeah, both being length 3 might also be a problem if you wanted to do that. The solver will probably yell at you. Okay, so here's an interesting thing. What digit can a 7 X sum start with? It can only start with a 2. The only 7x sum that is valid is a 2 followed by a 5. Because a 3 doesn't work. Because you can't make a sum of 7 and 3 that includes a 3. Nor can you make a sum of 7 and 1 that includes a 1. So one of these two 7s is definitely a sandwich, which feels like the most minor possible deduction, but there we go. And so if this 7, and the same goes for this 7, if this 7 is an X sum, it has to go to 5, otherwise it is a, wow, words today, otherwise it is a sandwich. Sadly, the only 2 I have in the grid is this one. So it's not like this is magically ruling anything out that I did not have before. So the column 2, 7 and the row 2, 7 also exclude each other. Because the 5... yes, okay, that's a good point. Okay, so this is a good point from Christian. These also can't both be X sums, because if I try to make them both X sums, it seems like, I could make both of those 2s and that's fine, but then I make both of those 5s and suddenly things are not so fine. So those don't work. Okay, so if this 7 is an X sum, it makes both of these sandwich sums. And if this is a sandwich sum, it makes this an X sum. Sorry, no. If this is an X sum, it makes this a sandwich sum. Okay. But I don't think there's any huge problem with them all being sandwiches. Because 7 has 3 different sandwich options. It can be a lone 7 flanked by a 1 and a 9. Or it can be Or it can be a 2-5, or it can be a 3-4. Oh, but that's an interesting point. Okay, so let's look at this this row. I want to imagine what happens if this 7 is a sandwich. If this 7 is a sandwich, as I said, hey, Qodec. If this 7 is a sandwich, it's very restricted. Because if this 7 is a sandwich, then if it's 2-5, note that also means that this 7 now is a sandwich. Which is not going to work. I mean, sorry, it could work. It could be fine. But it at least puts pressure on this. The only way I can make this a sandwich while still letting this column be an X sum is if I make it as a 3-4, or if I smuggle a single 7 in really early. Like, I could do something like that. And that seems to be okay. So there is an interesting interaction with the 7s because of the fact that one of the ways to make a 7 is with 2-5. And so now I'm kind of curious about this row. It doesn't work because the 8 needs a 1. Okay, so that's also a good point. So we should think about this as well. So how are we making 8? So I think this is the row we're supposed to be looking at. Despite the fact that we had all of this that looked interesting originally, I don't think any of that is the point. I think this is the point. So this 8, how are we doing it? Well, if it's a sandwich, it's either a 2-6 or it's a 3-1-4. So if this 8 wants to be an X sum, it's one of those. Yes, Ambrose, it's good to see that you are able to once again chat. But yeah, what exactly is the combination here that's the point? So is it this being an X sum that's broken? Or is it this being a sandwich that's broken? What are we proving? So if the 7 is a sandwich, then the 8 obviously isn't a sandwich. And so the 8 would have to be an X sum, but it could not be the 3-4-1 kind if this is wanting to be a sandwich. Because I'd need to somehow put a way of making 7 here in the sandwich, and none of them work. Wait, maybe that's not true. Maybe 2-5 is fine. Yeah, why couldn't I do... Oops. Why couldn't I do that? That actually looks fine. Darn it, Qodec. Yeah, I think that's fine. We're almost sort of trying to make the digits of pi here, it looks like. Like, a lot of these digits show up in pi. I'm still suspicious about that I'm supposed to make some observation out of these two. This 7, I think, would just end up being a sandwich going down. But I don't see any problem with that. Oh, does that break the 3 clue at the bottom? Ah, okay, so that's an interesting point. Okay, so let's imagine that we make this 8 in X sum. So this is a 3 with a 1, 4 here. This 3 is now suddenly broken if I make this a 1. So the only way that this gets to be an X, and the reason for that, by the way, is that if this is a 1 and this is a 4, now this 1 needs to be a sandwich clue. The only way I can make 3 out of sandwich digits is like that, and that's not going to work. Okay, so if this 8 is an X sum starting with a 3, then it has to look like this. And now this is assuredly okay, so now and now I think this column is broken. I think this row is fine, because this could still be a 2-5 flavor X sum. But this column now has a 1 here, which means that this 7 can't be an X sum. So the 7 is a sandwich. And so we get a 2-5, or, well, we can't get a 2-5 because now this 8 has to be an X sum because the 7 is a sandwich. So the 8 having to be an X sum can't be 3-1-4, so it would have to be 2-6. And so this would have to go 7-9. That would be the only option. Okay, so this 7 is a 2-5. Have we dodged every possible thing that sort of immediately breaks here? I think this 35 is fine. I don't think it cares. Let's see. So, yeah, So just to reiterate, if we hypothesize that this 8 is an X sum with a 3, then we get a whole bunch of stuff forced. Okay, so Christoph is suggesting that maybe it's easier to ask if this top 7 is an X sum. So if this were an X sum, it would look like that, which would force the 8 to be a sandwich, which would force the 7 to be an X sum. That's the point. Okay. This is much easier, much, much, much easier than what we were doing before. Okay. So can this 7 be an X sum? If it is an X sum, it only works as 2-5. Now what's this 8? Well, now this 8 cannot possibly be an X sum because it could only be 2, 6, or 3, 1, 4, neither of which works. So now this 8 is a sandwich. And so now this 7 cannot be a sandwich or an X sum. Because if it was an X sum, it would want to be 2, 5. And if it was a sandwich, it would want to be equal to 8. Okay. So this 7 is not an X sum. It is a sandwich. Okay, so I'm going to try and figure out some way to denote that. Okay, so I'm going to put a circle here to say that this is a sandwich, and an X here to say that this is an X sum. You know, it's kind of funny. I originally just said X for X sum because it wasn't a circle, but there's actually a certain amount of sense in using X for X sums that I had not contemplated. Okay. So that is a 2 or a 3. It doesn't show up super well, but we're just going to have to deal with it, I think. Okay, so this is a sandwich. I'm going to put the X's as marks there just because that will obfuscate what my pencil marks are a little bit less horribly. Okay. So now this X is just saying this is an X sum. Okay, and so this is either a 6... Oops, sorry. This is either a 6, a 1, or a 4, by virtue of the fact that this is an X sum. Okay, so now I have to think about, okay, what happens if this is 3, 1, 4? So if this were 3, 1, 4, then we're broke. Because if I make this 3, 1, 4, I have to make this 7 sandwich work out, and that's not going to work because I would need a 3 here, but I already have used the 3. So that tells me this isn't actually a 1. So the other way here is that this goes 3, 4, 1, and then this could be either 2, 5, or a 7, and I think it's fine either way. So the 3, does this now have to be a sandwich? It does, right. Not because of the 2, but because of the 1. Because if this 3 were an X sum, it would go 2, 1, which looks fine until you try and put that 1 in the grid. Good spot, Carl. So now this 3 is also a sandwich. Okay. Oh, and now Nicholas asks about this 10 clue at the left. Okay, so could this be a 4 anymore? Sorry, could this be a 4 X sum anymore? Maybe that's the question. Okay. So if this wants to be a 4 X sum, these would have to be 3, 2, 1. Well, this obviously wouldn't be a 2. So this would be a 1, 2, 3 triple. Let's see. This could go 3, 4. Oh, sorry. It cannot go 3, so this would have to be a 2 and a 6. And I could not put a 2 anywhere. Okay, so... Sorry, this is much easier than I'm making it out to be. This can't be a 4 X sum anymore, because if it's a 4, then this can't be a 3 anymore, because it needs a 4 in it in order to be a 3. So this is a 2, 6, but now I can't put a 2 in it. So this is not a 4 X sum, the 10. Could the 10 be a 3 X sum? Well, then that would make this a 2 and this a 6, and I need these two to add to 7. But amusingly, just by the sheer beautiful setting that is Qodec, it can't be, because I've exactly ruled out every possible way of making 7. This can't be 3-4, it can't be 2-5, and it can't be 1-6. Hey, 11 Tickles, welcome. So this can't be a 3x sum, and it can't be a 2x sum, because if it was a 2x sum, it would put an 8 here. And then that's certainly going to break this. So this 10 is also a sandwich, miraculously enough, just out of seemingly nowhere. Okay, so the 10 is a sandwich, so the 7 is an x sum. And is done, because there's only one way to 7x sum. And now, because of this 7 being an x sum, this 7 is a sandwich. Because it can't be the same thing. And so now, because this 7 is a sandwich, this 8 is an x sum. So this is a 2 or a 3. Over here. Boy, this is just a romp. So the 10 must be in 2, because the only way to make a 10 in 3 with a sandwich is with a 2, 3, 5, and if 2 and 5 are gone, I can't use a 2, 3, 5. So this 10, I also can't make 10 in 1. So this is a 10 in 2. So it's either a 3-7 or a 4-6 somewhere in here as a sandwich. Okay, so this 7 clue in column 2. Okay, this is a 7 sandwich. So if this went 3-4-1... So one thing I'm noticing is that these are different. Whatever, I don't yet know, although I think I'm probably about to know, but I don't yet know which of these is which. But I do know that these can't both be the same, because if they were both the same, I would break this column, because this whole x sum looks at this digit of this x sum. So this is a 2-3 pair, so I'm going to do what I did last time to remind myself of that and just give these colors just to say, this is a 2-3 pair. So interestingly, in this column, this is crazy. In this column, the 3 is sandwiched between the 1 and the 9. Oh, never mind. Sorry, I was noting these digits can't be 3, because these digits see both 2 and 3. So these digits are a 1, and then a 4, 5, 6, 7, 8, 9, which is, I know, lots of pencil marking to do. But this one can't be a 4 or a 5. Sorry, it could be a 4, can't be a 5, and it can't be a 7, 8, or 9. So this one's a 1, 4, or 6. Yeah, this is a 1, 4, or 6. One of these is definitely a 6, so these aren't 6. Let's see. Okay, I'm trying to just sort of like identify if anything else is obviously kicked out. If this wanted to be a 9, it would need to... If this wanted to be a 1 or a 9, it would have to start the 7 sandwich, which would have to mean this was a 4, and then this was a 3, except that doesn't work. So this is not a 1 or a 9. This is a 4, a 5, a 7, or an 8. Let's see. What about this? Can this be a 1? If this is a 1, it now has to start the 7 sandwich. But that looks fine, because I think this could go 179 without any problems. Oh, it can't be a 7 for the fancy reason that there's a 7 in the row. This can't be a 4 because one of these is a 3-4-1, and it sees the entirety of it, so that's not a 4. Ditto, this is not a 1 or a 4 for those same reasons, that it sees the entirety of these x sums, one of which is a 3-4-1. Okay. So that's actually some... I feel justified in my choice to use ridiculous pencil marks. Okay, now if this is a 1, this now has to start the 7 sandwich in both directions. Oh, which is going to be a problem, isn't it? Because I need a 7 sandwich in this direction and this direction. And so if this is a 1, it's both. So if this is a 1... Oh yeah, this just doesn't work at all. If this is a 1, then this is a 3-1-4, and then it's broken. So I don't even have to look at the fact that it's double. This is just not a 1. Oh, hey, Knitting by Franco. Been happy to see you on the Discord. Hopefully you're making some progress on the puzzle that you were working on. I saw Tristan was helping you out a bit there. Okay, so I now have a 4-6 pair in this column, out of nowhere. And I have a weird... Like, one of these two cells is a 1. Okay, so could this be a 1? Because if this is a 1, that's a 2 and a 6. Yeah, so this would have to go 1. Yeah, if this is 3-4-1, now what is this? 3-4-1. Obviously, it's not a 7. It's not 3-4, so it'd have to be 2-5 exactly. Of course, 5-2 in that order. I think that's fine. 3-4-1 breaks the 3 clue. Oh, yep. Sorry. We went over this before, but then we went on a whole giant detour around lots of things. But yeah, if this is a 3-4-1, this 3 clue now becomes impossible. So this is not that. It is a 2-6. And so this is a 3-4-1. And so I can get rid of these colors. I can make you bread, make you not bread. I'm just greening cells that are not parts of a sandwich. So the sandwich could go 1 cell or 2 cells. So that could be bread or that's bread, but none of this is bread. I guess I knew that in lots of other ways as well. So this is a 2-5 or a 7. Those are the only options. This is not a 9 anymore, because that would be too big. These are also not 1 or 9. Now I'm trying to make a 10, and I'm making a 10 and 2 here. So it's always 10 and 2, so it's always this. And so this is always a 9, because I know this 10 sandwich is 2 digits long. And so this 10 sandwich, it's not 1-9, because that's not an allowable sandwich. It's not a 2-8. So it is either a 3-7 or a 4-6. And this isn't a 7, and that's not a 3, for interestingly separate but also conjoined reasons. Okay. 2 by Sudoku goes here. So that's amusing. So this is a 2, which is what it would have to be for this to be an X sum, but it's not an X sum. Just by Sudoku. Chat pointed that one out. Let's see. How can row 6, column 2 be a 5 or a 7? Well, it can be a 7 if it just goes 7, 9, which I think is fine. Okay. Well, I can definitely green this cell at least, as I'm looking at this. Row 8, column 3. Got it. I got it that time. Okay. You can definitely green. Hey, Nathan, welcome. Welcome back. Sorry, you can green row 8, column 3. Yes, there's no way this is because this column needs a 3 sandwich, and so this is not the start of a 3 sandwich. Okay. Do I know anything about these digits? Or this digit? I don't think so. Well, okay, what can this digit be? It's not 1, 2, 3, 4. It's not 5. So this digit is 6, 7, or 8, just by virtue of the fact that it sees all of the other digits. Oh, does this 9 have to be a sandwich now? Laszlo is saying. Is that this 9 wants to be a not sandwich? It would have to be, well, it can't be a 2, can't be a 1, can't be a 4, so it'd have to go 3, and this would be 4. Beautiful, beautiful. Okay, yeah, so because there's a 4 in the row, this can't be a sandwich. Okay, perfect. So that is now identified as a sandwich as well. Okay. Oh, this is not a 4, so that's not a 6, just by the box. So this is a 6 or a 7. Let's see. Can row 6, column 2 be a 7? Then row 6, column 9 is a 6. And then these have to be a 1, 3 pair. Okay, let's work through that. Okay. So if this is a 6, then the sum of these digits is 11. Okay, so we're speculating, what if this is a 7? Well, then I need these two to sum to 4, so they'd be 1, 3 exactly. And so Carl asks if that breaks the 3 clue. And it does. So that's beautiful. Okay, so let's walk through that. So this is what Carl is pointing out. If this is a 7, this is a 6. And so this is now a 1, 3. Well, this can't be a 3 because the 3 in this column is part of a sandwich. So it's 1, 3. But now the 3 in this column is part of a sandwich, so that's a 3, and we break. That is a beautiful spot. That is very spottable, but very difficult to spot. So that's green, that's purple. This is a 2, 5. This is a 9. This is not 5. In fact, that's an 8. That's a 7. This is not a 7. Yeah, that was a great spot. So got that. So lots of good stuff. Oh, this 6 here has for however long been telling us that that's a 5. Okay, and so this only works if this is 6, 8, 9. I want to say. So that's not a 6. That's not a 9. If I understand how numbers work. So that means this is a 1, 2, 3, 4. So this now has to be a sandwich. Because if this is the maximum it can be, it's a 4, which now makes this an exsum of 10. So this is a sandwich. Yeah, that was a huge breakthrough. Let's see. This is not an 8. Oh, it's not an 8 because there's an 8 in the box. How about that? So that's a 9. So it gets all crusty. So this is meaty. Hey, Alima. How are you? There's an 8 already in column 4. So that's a 6, and that's an 8. Okay. This 20 means the sandwich is not done yet. And the sandwich can't be done yet here either. But on the other hand, the sandwich can't have outies of 12. So in fact, the sandwich ends exactly there to make this work. Okay, and so I need the outies here to sum to 25. Wait, I did that wrong. No, sorry, I need the outies here not to sum to 25. I need them to sum to 15. So that's 12 plus 3. So this is a 2-3 pair. Sorry, a 2-4 pair. Much like that. Okay. So now one of these is a 3. One of these is a 1. These aren't 1. That's not 1. Just because of the sandwich in the column. Oh, wait, are we not doing Schrodinger cell puzzles today? Let's see. So Andrew says the 3 sandwich is entirely in box 1, or this cell. Right, because if I go 9, 3, 1, then I force both 1 and 3 into this cell. So that does not work. Good catch, Andrew. So 3, 1. I can probably even figure out what this digit is if I stretch myself. I think it's a 4. So you get to be purple. You get to be green. You get to be green. Row 4, column 8. Yes, that is green because it sees both a 1 and a 9. My favorite sandwich deduction. Was actually via the Sandwich app that I indirectly found Cracking the Cryptic, because the App Store recommended I try the Sandwich Sudoku app, and I was like, I've never heard of this Sandwich Sudoku thing, and then I enjoyed it, and then the rest is, as they say, history. Okay, so now if this 18 wants to be an exsum, then it would have to be a 4 or a 5 now, which seems plausible, but getting pushed. Okay, this 7 is a sandwich, and it's not 2, 5, or 3, 4. So the 7 is a sandwich, which is a lone 7. That's the only way to make this 7 sandwich clue. And there's already a 7 in this box. So none of these are the sandwich filling. So the sandwich starts at least as far over as there, if I did that right. Because the only ways to make 7 and 2 are 2, 5, and 3, 4, both of which are excluded by the row already. So that looks more akin to that. So now we've got either 1, 7, 9. Oh, I can't do 1, 7, 9 here, so we actually know exactly what it does. It does that. Verbatim. So papow. 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 Papow, papow. So lots of papow all of a sudden. So these cells are 2, 3, 4, 5, 8. These aren't 8, so that's an 8. So these cells are 2, 4, 5, 6. Oh, they're not 4. So in fact, that's a 4 and that's a 2. Let's see. As pointed out, this cell sees both 1 and 9, so it's green, which means this is the last purple of the box. So that's the 9. This cell should be a write-in multiple dimensions. I believe it's a 3. Let's see. That 2 looks up there. This 5 looks up here. Nine in box 2. Oh, we got the 9 in box 2. Let's see. Are there sandwich clues we don't yet know about? Yeah, this sandwich clue. Yeah, this sandwich clue. Yeah, if it starts here, it's too long. Because I need to get to 9. So I can't start there. But if I don't start here, I'm never finishing. And so, in fact, the only way this column sandwich clue for the 9 works is like this exactly. Oops. Is like that exactly. Now, this 7 is the first digit of an X sum. And so it's telling me the sum of these 2 digits is 11. So they're either 2 and 9 or 5 and 6. I don't think I know which it is yet. Oh, I do know which it is yet because there's a 9 there. Beautiful. So that's a 6, that's a 5, that's a 2. That's Gren. Okay. You cannot have 1, 2, 6 inside a sandwich because the 1 does not count as a digit in the sandwich, and this is a sandwich clue. Although I make that mistake all the time. Okay, so these digits are a 1 and a 9. Oh, no need to apologize. Like I said, I do it all the time. Schrödinger sandwich is definitely very high on my to-do list as far as setting goes. Let's see. Where is 6 in box 7? Oh, it's not there anymore. So it's in one of these 2 cells. Let's see. I can place 5 and 6. Yeah, so the 5 has to go. Okay, perfect. So this is the 5, and so now this is the 6. And so that being the 6 makes that a 4, which makes that a 5, which makes that a 4. So these 2 cells are now, these 3 cells, I should say, are a 9, an 8, and a 7. So these cells are a 4, a 6, 7, 8. That's too many. What did I miss? Oh, they're not 6. They're a 4, 7, 8. And so these 2 are a 1 and a 3. Okay. This one's not a 7, just because of ye old Sudoku. Let's see. We're running out of clues that we have not yet finished. All of these are finished. That's finished. That's finished. This is 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 finished. So is the 18 the only clue that's not finished yet? I think the 18 is the only clue that's not finished yet. Okay, let's pencil mark column 4 per Nicholas's suggestion. We still need a 1, a 3. No, not a 6. And a 9. That one's not a 9. So that gives us a 1-3 pair out of nowhere, which means that these are green. because the 1 is in one of those two cells. These are green because of the column. These are green because of the column. These are green because there's a 1 in there. So one of these is a 1. I don't know which one yet. Let's see. Do I have any more magic that I can do? Let's see. Yes. So now because one of these is a 1, I cannot make the 18 work out to be a sandwich. Because either the either the 1 is here, in which case 0 is not 18, or the 1 is here, in which case neither 4 nor 7 nor 8 is 18. In fact, you don't even get 18 if you add all of 4, 7, and 8. So ergo, this is an X sum. And so it's not in 1, because there's already a 1 going in the column. It's not a 2 or 3. So this is either 4 or 5. 6 would be too many. I kind of suspect 5 is too many, actually, because if I try and do 5 without a 2... Oh, thank you. I used my fancy notation, and then I indicated it incorrectly. If I try and do 5 without a 2, that's going to be a problem, isn't it? Oh, and I put it in the wrong place. Just disasters all over the place. This is a 4 or 5. Oh, but now there's not a 2 anymore. Oh, but there's not a 1 in this sum. So there's no way this can be a 5, because it would be at least 20 if I'd used a 5. So yeah, not a 5. It's a 4. So these 3 cells need to sum to 14 without using a 1 or a 4 or a 3. Okay, what is the minimum I can make them sum if I'm not allowed to use a 1, a 4, or a 3? That would be 2, 5, 6 is 13, which is 1 off. So these are 2, 5, 7. Whenever the minimum is 1 off, there's a unique way to make it work. So these are 2, 5, 7, I believe. Chat will yell at me if it doesn't work. Okay, so let's see. 4 plus 2 is 6, plus 12 is 18. I think that does work, actually. So that's not a 7. That's not a 2. That's not a 7. That's not a 5. Oh, this is not a 4 either, so it's an 8. That's a 4. That's a 7. Let's see. What digit is this? It's a 6, I want to say. So that gave us lots of associated joy. The 4 now is placed here by Sudoku. We have almost all the 4s. Can we place the last 4? Yeah, the last 4's here. So that's good. What about 2s? How are we doing on 2s? This is a 2. Yeah, so one of these is a 2, and one of these is a 2, and I don't know which way it goes yet. How about 3s? Don't know much about 3s. 4s? 4s are done. That's right, we finished 4s. 5s, how about 5s? Nope, not quite. 6s? Nope. 7s? Yes, 7 is here by Sudoku. Because there was a 7 in the box, and I didn't think to check that. That would have been smart. So that's a 6, that's a 5, that's a 2. Whatever. If we don't talk about it, it never happened. That's the way it works. So what are these? 3, 4, 5, 6, 7, 8, 9. These aren't 7 because there's a 7 in the box. See, I saw the 7 in the box that time, so that's a 7. So that's not a 7. Okay. Let's see. What else is left in this box? Oh, sorry, these aren't 9. I don't know where the 9 came from, but there's no 9 there. That was just me pencil marking something in a column with a 9. So these are 3, 8. Still not resolved, but better. What are these? Let's see. 3, 4. These are a 5 and an 8. And I know the order. That's the 5. That's the 8. So that's the 3. That's the 8. This 3 looks over here and says that's not a 3. And so it is crust. We're narrowing in on where the crust is. We have a 1, 3, 9 triple in the row. So this is the remaining thing, which is, I think, a 6. And is Glen. So this is the last purple. I might as well write 1 and 9 in the purples. Just for style. Let's see. Where else is life happening? What are these 3 cells? These 3 cells are 3, 5, 6. Well, that one's a 3. So that one's a 6 and a 5. Things going in all over the map. This is a 7 or an 8, and it's not a 7, so it's an 8, and that's a 7. So what's left in this box? What's left in this column, I should say. We need a 1 and a 9. And a 3, it looks like. The 3 has to go here. So that's not a 3. And we can go crust, uncrust. Let's see. Oh, sorry. I did not uncrust that correctly. There we go. That's crust. Alrighty. Okay, what's left in this box? We need a 1 and something else. 2, 3, 4, 5, 6. We need a 1 and a 7. Well, that's not a 7, so that's a 1. That's a 7. Not that. That's the 7. Crust, not crust. And so that's going to ping-pong around these and fill in. That's a 9, that's a 1, that's a 9, that's a 1. That's a 1, that's a 3, that's a 1, that's a 3, that's a 9. So, sandwich. Not sandwich. And that's an 8. And I need to go ahead and color that that's green and that's purple. And yeah, that's good enough. We can stop there and move on to the next. We can finish it. We'll put the finale of this puzzle on the Patreon for those of you who are interested in seeing it. Bye, Jessica. Good luck with the work. Let's see. Am I actually going to leave the last digit? Well, I did that joke last time, so maybe not, although I will say that I do not get sick of jokes very quickly, so it is possible that this will be a recurring joke. So I'll just fill in that last digit's a 7 and leave it there. So next up, we have a puzzle, called Killocator by Starwarigami. So if Tristan can post the link, or if Tristan doesn't post the link, I'll dig it up. So this puzzle has an absolutely fascinating rule set to me. So in this puzzle, we have killer cages. Bye, Alex. Nice to see you. Let's see. I bet I can dig up the link because I think Tristan is away. Oh, nope. There we go. So in this puzzle, we have killer cages. And I don't think it's ever possible for digits to repeat within killer cages. You will notice, however, that there is no total on any of the killer cages. So how does that work? There's no total and none of any of that sort of nonsense. And so the way it works is for each killer cage, you count the total number of digits in the killer cage. So in this cage that I have in yellow, it is 4. Then you calculate the total. And so if the digits in this cage were, say, a 7, a 2, a 3, and a 9, I'd calculate the total. So that would be 10, 21. This cage totals to 21, so I would write 21 up there, except I can't. But then I would go to the row. I would go to row 2, column 1. So that's this cell. So these are really like fancy 159 clues. So because the total of this cage is 21, it's indexing row 2, column 1. And then the size of the cage is a 4, and so that would mean this digit is a 4. Okay. So you all know how good I am at counting. Well, we'll just stop there. You all know how good I am at counting, so if I miscount something, let me know. But that's all the rules. And I have a huge love of killer cages that don't have totals written in them. Because I think killer cages with totals look a little bit weird. Okay, so we're actually going to start with this cage. So now, Simon would tell us that this is a cage which totals to 45. Because if you think about it, these are a 1, 2, 3, 4, 5, 6, 7, 8, 9 nanuple. And so if you add up all the digits in this nanuple, you get 45. And so that indexes row 4, column 5. And so this cell is a 9. Now, one thing that I think is actually going to be helpful, possibly, is to note a couple things. So first, I can never index anything below this line because the word is, oops, sorry. I was going to type it in chat. It's nanuple. Is a tuple with 9 things in it. So we actually have to worry quite a bit about having sort of coincidences because we actually can't index into anything lower. Because my cages can sum to at most 45, and well, none of the others are going to sum to 45. Okay. Now, I want to also color all of the cages of size 2. Let's make size 2 blue. So that is 1, 2, 3, 4, 5. That's too many 2s. Oh, no, it's not too many 2s. Perfect. Okay. So now we have to fit 5 2s above one more in box 5. I hope not. We have to fit 5 2s into these cells that are all above this green line. Oh, there's one more in box 5. How on earth is that going to work? Isn't that too many? Oh, 2 of these have to be the same. I see. So some of these are indexing the same 2. Okay. I see. They can index the same cell. But we're only indexing 2s that live above the green line, remember? And so there are, in fact, only 5 2s that can work. Okay, now, I was about to say, okay, so one of them has to put a 2 here. Because there's only 5 cages, and so one of them has to put a 2 here. But that's very, very problematic for the following reason, which Nicholas is alluding to, which is that that would require making a cage that summed to 44. And I definitely can't make a cage that sums to 44 in 2 digits. In fact, this green line for 2-cell cages is actually a lot higher. the green line for 2-cell cages actually only goes up to here. So in fact, the 2 that these are indexing is always up in these cells. I drew this because a 17, which is the highest, would index something here. But we can actually do a great deal better than that, because this 9 looks at both of these cages. And so neither of these cages has a 9 in it. And so the maximum one of these cages can sum to is 15. But actually we can even do better, because the 2 of these cages together, which must have the same sum because there is only 1 2 in these, well, the maximum these cages can sum to is 8765, which is a hard number to do because it's an even one. So 8765, I've got to take 6.5 and double it. Is that 13? That doesn't sound right. No, I've got to take 6.5 and multiply it by 4, which is 26. I want to say 26. Hey, Starwarigami. So the maximum that these 4 digits sum to is 26, which means the maximum one of these cages separately sums to is 13, which means that actually this line moves all the way over here. So all of these are indexing the same 2, and that 2 is there. It's in one of these 3 cells. Okay, so that's interesting. So these cages all either sum to 11, to 12, or to 13. Okay, so I don't think we know which yet, but let's look, because this cage that now has a 2 in it, it has 3 cells. So where are all of my 3-cell cages? So those are all 3 cells. Let's make that green. Oh, interesting. Okay, can't be 13 because, as Barbie points out, actually, all of these cages are different. These are 4 different ways of making the same total. And there aren't 4 different ways to make 13, right? There is 9, 4, 8, 5, 9, 4, 8, 5, 7, 6. There's only 3. So, right. So this line actually gets budged over to here. And so now, is the same thing true of 12? How many ways are there to make 12? 12 can be made as 9, 3, 8, 4, or 3, 9. That's still only 3 ways. So somehow today, after all of this making fun of me of not being able to add to 11 in the recent video, we actually get to again figure out that actually these 4 cages have to be the 4 ways to make 11. So that all works out. Okay, so in fact, actually, they're all indexing this too. Okay. Now, what's the maximum this green cage could be indexing? This green cage needs to be indexing a 3 that is... Okay, so first of all, let's do all green cages. So all green cages have a total that's at most 284... Sorry. It's most 987, which is 24. So green cages all index a 3 that's above this line, but this one actually always indexes the 3 in the top row, because the most I could make these sum to is 8 plus 9 is 17, so that's 19. So this actually indexes something above this line. But it's possible that this cage indexes the 3 in row 1 and these two index the 3 in row 2 or something of that sort. Okay. Now, as being pointed out by Carl, there's a very easy deduction that I could have made that I just didn't, which is, hey, if you look at the fact that I just said every blue cage adds to 11, well, that's a 9, so that's a 2. So we've got actually tons of digits from not that much work so far. Okay. So I'm just going to try to remember that all of the 2-cell cages sum to 11 to index that cell. Okay. So are there other cage sizes that show up a lot? There are lots of 4-cell cages. Well, lots may be overstating it. There are 3 4-cell cages. Yeah, so to summarize how we got here, we know all of these 2-cell cages index the location of a 2. But the maximum a 2-cell cage can sum to is 17. So the way this works, that means the 2 that was being indexed is definitely in one of these cells. But then, through fancy knowledge that chat noticed, actually, these 4 cages, they all have to be indexing the same 2, because they can only be indexing the 2 in row 1, wherever it is. But actually, they all have to then have the same sum, and the only sum that can be made in 4 different ways that's 2 digits and is not 10 is 11. And so then this has to sum to 11, which then says, okay, the 2 in row 1 is in position 1, 1, which is here. Okay, so can I put a 3 here? Or in this cage at all? If I put a 3 in this cage, yeah, I guess I could put a 3 in this cage, as far as I'm able to immediately determine. Okay, now this is indexing the location of an 8. But an 8 could go very, very, very far down. Well, what's the minimum, I guess, maybe is the question. So the 8-cell cage here sums to at least 36. So this is placing an 8 somewhere from here down to here, because 8 is not the same as 2. But that's not super helpful immediately. Row 6, column 5 must be a 1, since all the cells in column 5... let's see, row 6, column 5. Ah, yes, okay. So that is a beautiful observation. This cell, that is a great point, afraid not. So there's 4 ways to make 11. 2, 9, 3, 8, 4, 7, or 5, 6. This cell sees all of them. And so that is the only digit that does not show up in all of those things I just mentioned, which is a 1. That is gorgeous. Sadly, there are no 1-cell cages to look at. I'm trying to decide if I want to, like, add these cages together or something. let's see. I could ask questions about how big this can be, because these two sum to 22. So these are 24, at least 24. And so this cage sums to, at most, 21. So that's interesting. So this is either putting a 4 here, or it's putting a 4 into row 1. That's interesting. Let's see. I mean, it was very cool, whether it helped or not. The yellow in box 5 has max 19. I did the math wrong. Let's try that again. That's 22. That would be 24 if this were a... Oh, sorry, this can't be a 2. Sorry. 22, 25, which means this is at least 20, but 20 is not a valid sum, so it is 19. So yeah, so this is referring to the 4 in row 1, for sure. Okay. And so this is saying the 4 in row 1, but then what's the minimum that this cage can sum to? That would be if this were 11, and 11 is 22, and 8 is 30. So this is at least 15. So the 4 in this row is over here at least. Can pencil mark that, which is a little weird to do, but we can do it anyway. Let's see, we can make a similar counting argument about how big this could be, because this is this J shape. Its sum is going to be 45 minus 11 is 34 minus whatever this cell is. So it's probably going to be in row 2 or row 3, I suppose. Let's see. Are there multiple 5s? Yeah, there's 2 5s, I suppose, that we are indexing the locations of. Let's see. We can make that red. Row 1, column 6. Can't be a 4. Wait. Row 1, column 6 can't be a 4, because then the big cage in box 2... Ah, okay, yes, sorry. Okay. Got it now. Okay. So if... Okay, so one of these... Okay, so if this is a 4, now these sum to 15, and now this sums to 30, which is not a valid option. Oops. So that's not a 4. Okay, that does mean this digit only has a few options. Because this digit is going to be 11 plus 11 is 22 plus... Okay, and so plus one of these things. So plus 15, 22 plus 15 be 37, which would make this an 8. Sorry, would make that an 8. Or it's there, in which case this is 22 plus 17 is 39, which would make this a 6, or a 5, or a 4. Okay. So that is... so this is only a 4, 5, 6, or 8, if I did that correctly. Okay. Now, this cell... This cell can't be a 5. Sorry, no, this cell can't be a 5. Because if this cell was a 5, then it would make this cage sum to 40. If this is a 4, then we plonk the 4 there. So that doesn't quite do it. Let's see. So I know this cage doesn't have a 9 in it. I know this cage doesn't have a 9 in it. I know this cage and this cage don't have a 9 in it. Is it possible this cage has a 9 in it? Maybe? It would be really helpful if I knew that these two 5s were indexing the same cell. But I think I very much don't know that these are indexing the same cell. Let's see. It's 11 and 11 is 22. 32. So these 3 cells in the column sum to 13. I don't know if that's very helpful. Yeah, high-low coloring seems to maybe make sense once I know a little bit more. Unfortunately, I don't know there's not a 3 in this cage. Do I even know there's not a 1 in this cage? I do at least know there's not a 1 in this cage, I think. Because if there's a 1 in this cage, then this needs to be an 8 or a 9 to get it up high enough. But then that would put a 3 inside a cage that now we've just not put a 3 in. So for whatever it's worth, the 1 is down here. Oh, high-low in the 11 cages. Do we know anything about this? Okay, so this is 3, 8, 4, 7. Do we know anything about high-low in the 11 cages that's useful? Let's see. High-low, high-low, high. I'm very open to coloring it if we can color anything that we don't already have colored. Okay, so this is 11. And so we're going to take oh yeah, the 2 in column 5 is not in blue, so the 2 is there or there. I like the point. I'm not sure even I'm chaotic enough to pencil mark across boxes that don't touch each other. But that's actually interesting because of the fact that we know these 3 cells add to 13. So what that means, actually, is that wherever the 2 goes... Yeah, so this cell, I guess, is the point. The column is a 2, this cell, and this cell. Which makes sense. I want to think about what are all the places this is telling us the 6 goes. So, at minimum, this is... give us that this is 33, which would tell us the 6 is there. But then it could go down to 32, 33, sorry, 33, 32, 31, and then 30, and then so like where's the furthest would be if this is 11 and 9, which is 20, in which case this would be 35, so that would be putting a 6 there. So yeah, the 6 goes all over the place, I guess, is the point. Row 3, column 5 repeats in... Oh, sorry. So row 5, column 6. Yeah, this repeats in one of those two places. So yeah, this is... These two cells are a 2 whatever this cell is pair. This pairing is very interesting. Should I think about what it is if these two are the same? Maybe that's a worthwhile question. So if these two are the same, then I need this digit to be odd. So it has to be a 5. And then these would be... these would have to both be 25. So if the two red 5 cages are the same, they both sum to 25, and they put a 5 there. Is it possible they're not the same? So is it possible to get... What's the largest I can make a 5-cell cage sum to? It's 35. And then the least I could make it sum to is 15. Ah, okay. So I think this is the point. So... No, because I could do like a 20-something, a 20 number and a 30 number, can't I? So the sum of these two cages is between 49 and 53. And so if I want them to be different, I need them to be like a really low... Well, it can't be a really low 20 number and a really low 30 number. That's not possible, because a really low 20 number and a really low 30 number would put 2 5s in box 1. So I think this is actually what I'm supposed to be thinking about. So this can't be a 20 number and a 30 number. That is just not possible, because the numbers have to be adding up to at most 53. Now, they add up to at least 49. So they also can't be a teenage number, as Simon likes to say, and a 20-something number, because those numbers would not add up to 49. Yeah, that's true. Because that would be like a number that's at most 20 and a number that's at most 30. Add up, but less each time. Yeah, so that wouldn't work either. So the other possibility, can this be a teenage number and a 30-something number? If this is a teenage number and a 30-something number, then again I have a number that's at least 15 for the teenage number, because the teenage number would have to be 15, 16, 17, 18, 19. So that would refer to one of these cells. And the 30-something number would be at most 35, so it would refer to one of these cells. Why is that not possible? It seems so very barely possible. And that irks me. So, again, the possibility we're considering is that, say, one of these is 15 and the other is... the other option is the easy option. They're both 25. And if they're both 25, which is I'm pretty sure what we're trying to prove, this is a 5 and this is a 6, and then we get lots of stuff. Oh, if this is a 5, where does it put the 4? That's a good question. If this is a 5, then we would be saying the 4 is in 22, 27... this would be 18. We'd be saying, so if this is the 5, we'd be saying the 4 was there, which unfortunately seems fine, I think. Yeah, there are just enough combinations. This 8 here is really a pain. If this 8 wasn't here, it would be a lot easier to rule something like that out. Okay, let me look at what chat has been saying. So row 1, column 7 cannot be 1 for sure. Okay, I'm just reading Directionary's comment. Can't be 1. It can't be 2 because there's a 2 in the row. And so it also can't be 9 because there's a 2 in the row. It can't be a 5. Sorry, row 1, column 7. Row 1, column 7. The counting is with me. Okay. So it can't be a 1, a 2, a 9. It can't be a 5 because that would make this 40. And let's see, and it can't be an 8. It can't be an 8 because that would put an 8 in the same box. Because if this was an 8, then these would total to 37, which would say, there's an 8 here, there. That's not going to work. Okay. So this is not 1, 2, 5, 8, or 9, which means it is 3, 4, 6, or 7. Those are the only options. So that means that this is an 8 or a 7. Oh, this can't be a 7, because if this was a 7, it would put a 4 here, and we've agreed for some reason there can't be a 4 here. Why have we agreed there can't be a 4 here? Let's see. If there's a 4 here, that would be saying that... the sum here was 16? Oh, because then this sums to 30. That's right. Okay, sorry. It was this case. Yep. Yep, we break this. Yeah, if this is a 4... Yeah, so if this is a 4, then that means that these sum to 15, so these sum to 30, and that breaks. Okay, so because this can't be a 4, this can't be a 7 either. So this cell's also quite limited. It's either an 8, or a 7, or a 5. Okay, so now that actually narrows down what this is pointing at a lot. Because now, if this is an 11 plus 5, that's 16. This would be 29. That would be indexing a 6 into that spot. Or this is a 7, in which case these sum to 18. And this would be a 27, which would be indexing a 6 into that spot. Oh, that already didn't work. The 5 doesn't work, because if this is a 5, then we indexed a 6 into the box where we also put a 6 because of the 11 cage. So let's go over that again. If this is a 5, now these total 16. So this totals 29, and that puts a 6 there. But we also put a 6 here to make the 11 cage work. So this is not a 5, that's not a 6. Okay, so let me get rid of my coloring. So that feels like significant progress. Okay, if this is a 7, then these total 18. And so then this is 27, which would put a 6 there. And if this is an 8, then these would total 19. So these would be 26, and so that would put a 6 there. So these are my 2 places for 6 in row 2. And this is now only a 3 or a 4. And this is never a 6. So this is never a 5. So now I can also pencil mark 8 in row 4. Ah, yes. Okay, excellent. Because now this cage sums to either 42 or 41. So now let's go back to 42 and 41. One of those is an 8. So in particular, that is not an 8. Okay, gorgeous. So now we're maybe supposed to go back to asking about these double red cages. But I'm going to put that off just slightly because it was a disaster last time I thought about it. Let's see. But that was a great point, Calzone, about that. I did not immediately see that like I should have. Okay. That 8 removed from row 4, column 6 means that 4 can be removed from row 1, column 5. Ah, yes, that's right, because we had this whole shenaniganery going on here where these total to 11, and so if this was a 4, these would total to, these total to 22. And so before this was allowed to be an 8, which would have made this 15, but it's not anymore, so that's not a 4. So now the 4 really is restrained up here. Let's see. Odd, even, parity to remove an option from row 3, column 6. Oh, sorry, row 4, column 6. I don't know that these 2 cages have the same total, though, do I? Like, I want to know that these have the same total, which would let me use parity to fix that this is a 5, which is where I assume we're going eventually. But I don't think we're quite there yet. So the possibility, okay, let's think about this again. So the other possibility is that one of these is 30-something, and one of them is 15-something. Sorry, it is a teenage number. The teenage number could only be 18 or 19, because these are the only places I could put a 5 in this row that are at least 15. Wait, no, sorry, I could do it. So it would have to be either. Okay, so here are the possibilities if I want to make these different. I'd need 15, which would put a 5 there, or 18 or 19. And those go with the 5 in row 3. So this would have to be a 30-something number. And so the biggest 30-something number I can get is 35. And so it would have to be 35, 34, 33, 32, or 31. Oops. 5, 34, 33, 32, or 31. No 5 in row 1, column 5. Oh, because of the 6. Oh, great. Okay, so can get rid of 15. Okay, so it would be 18 or 19 only. Good eye. Thank you, chat, for 57 thorns, but welcome, by the way. And Jay and Carl all noting that. Okay, so 18 or 19 only. Plus this. Okay, so if I did... so 31 plus 19 is 50. Okay, so now we can look at this and say, okay, the maximum that the red cages sum to is 51. So I cannot exceed 51, which means that the 18 can't even go with a number higher than 33. So 34 and 35 are out. So it's actually... Oops. So actually, because of that, because the fact that the red cages together total at most 51, we can actually say it's only 31, 32, or 33. So, oops. Now, a fascinating thing that has not even occurred to me here is that this always puts a 5 in one of these cells, because either we're putting the 5 up here and down here, or we're directly putting a 5 here. So one of these cells is always a 5, regardless of anything else going on. So that's interesting. Okay. But it still strikes me that we have a little bit of optionality there, where we could go as low as 31 and 19. Sorry, 31 and 18 would be 49, which would correspond to this being a 4. So yeah, this being 4, 5, or 6 still leaves us a few options as far as these things go. I don't think I intended to write 35 into this box. I think I was trying to type somewhere else, and it did not work. Okay, so we at least got a pencil mark for 5s. It's not the world's best pencil mark for 5s ever. It's particularly interesting, though, when we do prove that these sum to 25, because it'll put a 5 there and a 6 there, which will remove 6 there, which will put a 6 there, and then all kinds of nice things will happen. We don't know what green adds to. Greens are just all cages that index the location of 3s. So I was looking at, okay, where did the 3s go? And they don't necessarily sum to the same thing. So it's possible that one indexes the location of a 3 over here somewhere, and then the others index the location of 3s up here somewhere. See, it is interesting. If this is a 3... that would correspond to a total of 17, which is very doable for many of these cages. Let's see. Of course, if one of these is a 4, then that's a 3. This corresponds to putting an 8 over here. Mysterious. like these all added together is super interesting, and like it's clearly meant to draw the eye, but we just don't quite know enough unless I'm missing something that should be obvious to rule out the useless case. Okay, so Jay says they believe that the two red cages being equal would actually break because of the horizontal row 1 cage. So that being, if this is a 5, then this is a 6. There's a 5 down here somewhere, but that's probably not what matters. It's a 5, that's a 6, so that's a 6. I'm not sure. So you have to like really carefully torment the value of this cage to figure this out. So what can this cage add to? The maximum it adds to is still in this row. So 3 could go here. Okay, so where can 3 go in row 1? If I try and go 2, 3 here, then this is now wanting to add to 12. So I would have to put 2 plus 3 is 5. I'd have to put a 7 here. But I can't do that because then I've used 3 and 7, which has broken this cage. So that's not a 3. What about this? Could this be a 3? Well, if this is a 3, then I need this to be an 8. Okay, so if this is a 3, I need this to be an 8, which makes that an 8. Is that broken? Because that makes that a 4. Dang it, no, it does not, because that's not putting the 8 in a bad place. That actually lines up with where we'd want to put the 8. So I think this can be a 3. Let's see. If this is a 3, then we want these to add to... this is a 3, then we're trying to add to 14, so we'd need a 2 here. And these would need to add to 14, so those would need to add to 12. Let's see, is that a problem? I don't immediately think so. Okay, can't add to 16. Yeah, I don't see, yeah, it is a problem. I'd be very excited if this can't be a 3. So, let's see. So, I think, so if this is, so I think we're saying this is a problem, because now this is a 4, so now this is an 8. And now 3, 4, and 7 are all removed from 12 sum options. Where are we doing 12 sums? This is now a 7. Oh, is the problem this cage now? Let's see, what can this be? Not 2, 9, not 3, 8, not 4, 7. Not 5, 6. It is broken. It is broken because of our work with the 5. The 5 is not... Oh, wait, no. Dang it, no. It would be fine. It could go 5, 6. Never mind. It's fine. Everything is okay. The bad kind of okay. Oh, I said before that the digits not repeating within cages was irrelevant, but it's actually not. There's one cell. That cell can't repeat there. So that cell gets transposed into one of these 5 cells, which is not super useful, but it's technically true. Okay. Can there be a 6 in here? They can all index the same digit. So all of these blue cages, Listash, and this is exactly what my thought was when I first did this and was like, wait a minute, what's going on here? But all of these blue cages, they all index that too. And so every blue cage sums to 11. So let's see. If this was a 2 and a 6 in here. Yes, they're very, very helpful to yeah, and of course they can point to different ones. It's just that for the 11 cages they can't. So yeah, so I'm hoping for the greens we get 2 different ones, but I don't know. Oh, that's a perverse and interesting point. If this is a 3, now this is an 8, but also, what are these cages now? Because remember, the largest I can possibly make these 3-cell cages sum to is 24. But now I've put a 3 in this cage, or sorry, in this box. So the only other place we could possibly index a 3 other than this one would be exactly there. And only if it was 7, 8, 9s. So that's actually very interesting. I don't know that it's broken or problematic or anything. But then we'd have a bunch of these totaling 13, I think. I mean, why couldn't this just still total to 13? I don't think there's any problem with it, but it's just it's an interesting note about what the effect of putting this as a 3 is. Let's see. Oh. Let's see. So yeah, the could a 6 go up here is a question that I do not know is a super good direction to go, but if there's a 6 up here, then now I need to go at least as far as let's see, so 2 plus 6 is 8. And this 3 no longer can go here or here. So I need to go 2 plus 6 plus... Sorry. Yeah, I could not do 2 plus 6. So at least to 4. So I need to go at least to 14. So 2 plus 6. I'd need to go with... a 7, 8, or 9, I think, is the point if I did that. So I need to go with a 6 and a 7, 8, or 9. Hey, Panthera, welcome. Perhaps you can solve the puzzle for us. Now, here's a question. Where does 2 go in this box? Hey, Apple Tree. 2 doesn't go here. 2 certainly doesn't go in here. So 2 in this box can only go in one of these 2 places, or one of these 3 places. So that's at least a little bit restricted. It's something. I mean, I think voluntarily watching someone do Sudoku puzzles is probably a little weird by most definitions, but I am happy for people to do it anyway. Hey, Fuchsia! Let's see. I feel like I should probably be trying to say more about these 11 cages, but I'm feeling very stuck about how I could say anything meaningful about the 11 cages. Let's see. Here we are talking about 4s. So, again, what's the... Yeah, again, this is a little restricted because this is going to put the 4... Yeah, this puts the 4 up here in this box. That's what this does. So if the 4 is in one of these two cells, then it forces this to be 3, 8. Is that a problem? So now what is this going to be? If this is a 3, 8 and that's a 4, this could still be 7, 4 that way around, though. I keep wanting to go back to trying to prove that these can't, that these either can't be the same or have to be the same. Let's see. If this is a 5, this is a 6, and then this is a 6. What about the 6 in box 1? Yeah, I was looking at that before and trying to say, hey, can the 6 in box 1 go up here? But I think the annoying answer is yes, as long as it goes with a high digit, it's fine. Oh, the 6 cage. Ah, the 6 cage. That's a good question. Okay, so we have a question about a 6 cage that I am excited to think about. Okay, so the maximum this sums to is 2 plus 8 plus 9, which is 19. So the minimum this sums to is 45 minus 19. 45 minus 19 is 26. So this sums to at least 26. So we're... Oh, now that's suspicious. This sums to at least 26, which is pointing at something in this row. It's not allowed, actually, to sum to 28 or 29, because we somehow have these 6 pencil marks. I have absolutely no idea how we have these pencil marks. Is there a different 6-cell cage somewhere? Did we get these 2 pencil marks from analyzing exactly this cage? We might have gotten these 6 pencil marks from analyzing exact... Oh, no, it's from this 6-cell cage. Okay, got it. This 6-cell cage. That's right. Okay. So this could be 26 or 27. It cannot be 29. It cannot be 28, 29, or 30. Could it be 31? If this sums to 31, then we're down to this summing to 14, which would be putting a 3 here. How did we feel about putting a 3 here? I think we decided that putting a 3 in either of these places was fine. So that would correspond to making this now, let's see, so sorry. So 31 would correspond to making this 14. 32 would correspond to making this 13. Okay, so it is 26, 27, 31, or 32. Those are the options, I think. Oh, grad school admissions. Oh, that was a fun game to enjoy. Try not to ruin anyone's life, Tall Cat. Let's see. Okay, so 14. So we're either indexing the same 6, or we're indexing a 6 that goes in one of these places. Okay, so if this is 14, then Listesh says this has to be 257. Yeah, let's see. So if this is 14, it means that's a 3. This would be 5, 7. Put a 5 over down here somewhere. Let's see, I can't put a 4 in row 1, column 4. Yeah, there's a 4 pencil marked over here. So I can't put a 4 in row 1, column 4. Let's see, can't have a 3 and therefore can't have a 4. Oh, can't put 3 there. Okay, so that would... Okay, can I put 3 here? Let's check. So if this is a 3, then I need this cage to total to 14. And then this would be 5, 7. But this is 4, 7, and I'm broke. Okay, so that is not a 3. Okay, so we have ruled out 3 from this cell, which means this can't sum to 14, which means that if we're talking about a different 6, then we're talking about the 6 that goes exactly there. And feel free, Starwarigami, I trust you. You can do it. You can give hints or not as you like. So that can't be a 3. Can this be a 3? Couldn't 6 go in row 3, column 3, 4, 5? I'm just talking about the 6 that is indexed by this box dictionary. And so 33, 34, 35 are too high for this total because they make this total too small. Pencil mark all the options for 3 in row 1. Okay, so that could be a 3. This can't be a 3. Can this be a 3? If this is a 3, then that's an 8. That's a 7. That's a 4. Is that at all interesting? Yeah, that makes this total too small. Okay, so... Oh, but the 3 can't go here. Sorry. The 3 definitely can't go here because that makes this total to 15, which makes this total to 30. So that's not a 3. So this can certainly be a 3. If this is a 3, so let's look this up closely. If this is a 3, yeah, this just can't be a 3 because of this box. If this is a 3, then that's saying, okay, the total here is 17, so the total here is 28. And so if this is a 3, then that's a 6? Wait. Oh, this can't actually be a 3. If this is a 3, that's 17, which would put a 6 here, and we already know there can't be a 6 here. Okay. So this is a 4, and that's a 7. And we have something resembling digits again. Okay, what if this is a 3? If this is a 3, then this box would sum to 18. And so these would sum to 27. Put a 6 here. That's fine. And if this were a 3, this would sum to 19. It can't sum to 18 because of the 7, 9. What 9? Oh, got it. Okay. If it sums to 8, so if this were a 3, it would need to sum to 18. But it just, as Tallcat points out, for fancy killer logic reason, just outright can't sum to 17. Because, sorry, 18. It just can't sum to 18, because I'd need these two to sum to 16, and the only way you can make 16 is with a 7, 9. So this can't be a 3. So what about this? Can this be a 3? In which case, this would sum to 19, which would require these two to be an 8, 9. And these being a 19 would mean that the total here was 26? Did I do that right? This is a 19. These are 26, which would put... which would put a 6 here. Ah, yes, we immediately, as Listesh points out, before I go back to trying to do that again, this is an 8 because of this cage. It's a 41 cage. Okay, so we need to do these 3s again. So if this is a 3... Ah! This can't be a 3 anymore. That's the point. Oh, that's not refort. God damn it. Sorry. That's the 8. That is the 8. I wanted the 8 up there, though. That would actually get us somewhere. So this is the 8. It's not going to get us anywhere. So if this is a 3, these total to 13. And so this is 32, which would put a 6 here. So either that's a 6, which is fine. And if this is a 13... Oh, how do I make 13? Maybe I should make sure I can actually make 13. 21 is not equal to 41. I don't think I understand. So if this is 13, I need these to be 32, which puts that there. If this is a 13, then this is 19, and so then, yeah, then I need this to be 19. This is 26. And so then that's a 6. So maybe I should color these in a gray flash since they're different. those can be the black flashed 6s. One of these 2's a 6, one of these 2's a 6. Okay, and so if these are... You put the 8 in the wrong place. Sorry. So, yeah, so one of those is... Okay. So if it's here, these need to turn to 13. These need to add to 11 without using a 2-9 or a 4-7. Or there's a 6 there now, so it can't be a 5-6. So if we've gone through all the options, 2-9... No, it could be a 3-8. 3-8 would be fine. So, yeah, I guess that's the point, is that if this is a 3, this is an 8. Okay, if this is a 3, then that puts the 6 there, and also means I need to make these sum to 17, and so then they're an 8-9 pair. So I think the point is that actually the only things that these can be are 3, 8, and 9. Okay, so what is this cell? It's not a 1. It's not a 2. It's not a 3. It's not a 4. It's not a 5. It's fine if it's a 6, I think. It's not a 7. It's not an 8 anymore, and it could be a 9. No, it can't be a 9. Is it just 6? I think it's just 6. I think this is just a really, really weird naked single. I think that's a 6 and that's a 5. Which means that's the 6 out of orange. Which means this is the 6 out of gray. So I can decolor these. Yeah, that was just a very weird naked single, I think. Okay, so these aren't 5. That's not 6. So now, does that tell me anything? So if this was 13, then this is right. If this is 19, then this is 26, which put a 6 there, and there's not a 6 there. So this can't be 8, 9. So now this is a 3, and this is an 8. Okay. So I think we now have things. So what was the short way, Starwarigami? Was I supposed to do something down here or something? I think we just sort of had to... The way we did it was to sort of agonizingly look at every possible case around here. I bet there was a better way. Yes, we are fast like a cheetah, as Listesh says. Okay, so these are 159. Oh, this 7... Oh, yeah, this 7... Yes, that's the point. Yes, the 7 meant that we could just add these 3 digits and find this location and then not think about this mess at all, not think about the 3s at all. I think thinking about the 3s was a red herring. I don't think thinking about the 3s was actually useful. I think the whole point was to think about this 7. And I think thinking about the 3s just meant we chased this around in a complicated way. Okay. I'd buy that. Let's see. Okay, so now people are saying I should think about this 4, or this one, this cell now, and what this is indexing. So this is indexing a 4 that we said had to be the 4 in row 1. And so it's indexing this 4. So now because this 4 cell cage is indexing this 4... it means it needs to add to 17. So that's 28. That's 39, which means this really is a 6. Which means, in fact, these are indexing different 5s. If I did that math right. 11 plus 11 is 22 plus 17 is 39. Yeah, so these are indexing different 5s. And so this is indexing the 5 in row 1 and the 5 in row 3. Okay, so the 5 in row 1 can't go over here anymore then. This has to be... No, it can't be there. No, can't be there. Oh, it super can't be there. Okay, so these two things add to 51. And so 51 equals 18 or 19 plus what or what? 18 or 19... Sorry, 51 equals 18 or 19 plus... 33 or 32. Yeah, plus 33 or 32. Okay, so 33 or 32. Well, it's not 32. So it is 33. So that's the 5. So that went with an 18, I believe. So that's the 5. 33 plus 18. Yep, so that's not a 5. Okay, so we've got a 1-9 pair. So in light of the previous puzzle, we can make these purple. Okay, so one of these now has to total to 18, and one of them has to total to 33. Okay, people who do killer puzzles, how do you make 33 and 5? That is, I think, the question. Okay. Okay, there is a 6. There's not a 6 here. So 6 is in one of these two cells. Let's see. 33 and 5 needs an 8 and a 9, and the upper one can't have both. Perfect. Okay, so the 8 and 9 are down here. And now this has got to sum to 18 with a 6, so we now need 12 and 4. So 12 and 4 is always with a 1 and a 2. So this is always a 2. And then there's always a 1. And then it's either a 4 and a 5 or a 2 and a 7? No, sorry. 1, 2... or a 3 and a 6, and it can't be a 3 and a 6, so it is 1, 4, 5. Okay. So this is exactly a 1, 4, 5 triple. So this isn't a 4, this isn't a 5. These two cells are known. They are a 3, the 7. And I know the order. So that's a, oops, sorry, that's a 7, that's a 3. Now I know these cells as well. They are 3, 4, 5, 6, 7, 8, 9. These aren't 6. That wasn't as helpful as I'd hoped. So now I was going to look at these cages for 3s and ask where the 3 is getting indexed. Because if the 3 is getting indexed... So this has to be indexing the same 3. This has to be indexing the 3 that is present here. So this cage also adds to 13. But it adds to 13 without a 2. Assuredly, if I want to add to 13 without a 2, I need a 1, right? Let's see. If I try and use 13 without a 2, then I'd go 1, 3, 4. No, I don't think I do actually need a 2. I regret to inform me. So I think this could be like anything, is now my takeaway. doesn't have a 2. Let's see. So what are these cells? These are a 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's not a 7. 3 in box 7. It's down here somewhere. Do I know the 3 can't go here because it has to be summing to 13? So then these two would need to be 10. So if this is a 3, these two need to add to 10. They can't be 2, 8. But I don't see any reason they couldn't be any of the other combinations. Let's see. So yeah, the only way that one of these sums to anything other than 13 is if this one is exactly 7, 8, 9 and sums to 24, which would put a 3 here exactly. But I don't know. I don't think I know anything about that yet. The 7 cage in box 4. Oh, no, we did not investigate the effects of the 7 cage in box 4. So what is this summing to? So a 7 cage always sums to at least 28, but this 7 cage also has an 8 in it. So it sums to at least 29, I want to say. Actually, it has an 8 and a 7 in it, so it needs to sum to 30-something. Or possibly 40-something. But it can't sum to 43. So it's got to sum to 30-something. And so it's going to sum to the location of the 7 in row 3. So the 7 in row 3 goes one of these places. So let's see. Is it possible the 7 goes here? In which case, this would need to sum to 31, which would mean that these two needed to sum to 14, which is just possible. Or the 7 could be any of these places, in which case 37, 38, 39. Oh, because the green is summing to 13. Okay, yeah. So if I try and put the 7 over here in any of these places, then that's 37, 38, or 39, which is going to make this sum to 6, 7, or 8. And so if these sum to 6, wait, what's wrong with these summing to 6 and this being a 7? I don't see what's wrong with these summing to 6 and this being a 7. I certainly agree I can't make it blue cells. In box 4. There aren't blue cells in box 4. But yeah, the green domino sums to 13. Like, this one definitely sums to 13. But I don't think there's anything wrong with these. Was there something wrong with this one? Oh, something wrong with... Oh, okay, I see. Sorry. There's something wrong with this one. Okay, sorry. If this is... So, there we go. Okay, yeah, so... Got it. Okay, sorry. I thought we were ruling out all of these, but we're ruling out this one. This can't be 7, is the deduction here. Because if this was 7, that would be a 31. These would need to sum to 14, which is going to be a problem because this would have to be a -1. So this is not a 7. That is the upshot. One of these is a 7. Okay. So if it's this one, that's 37, would mean these sum to 8, and this was a 5. If this is it, they sum to 38, so these sum to 7. So this is a 6. And if this is a 7, these are 39. Sorry, these are 39, which then means these sum to 6, and this is a 7. Okay, so this is a 5, 6, or 7. And these sum to, because these sum to 13, these sum to 8 or to 13. Okay, so 13 minus 8 is 5. So these sum to 5, 6, or 7. If they want to sum to 5, they would have to be 1, 4 in a certain order. But that's very possible. If they want to sum to 6, that seems fine. Let's see, 8 is impossible. So if this is a 5, then these want to sum to 8 without using a 5 or a 2. So then it would have to be 1, 7. Oh, and they can't use a 7 either. Okay, so this can't be, these can't sum to 8 for the reason that if I try and make this, so basically we're saying this can't be a 5, because if this is a 5, these sum to 8 without using 3, 5, 2, 6, or 7, 1. So without using any of the ways. So this is not a 5, which removes one of these 7s over here, though I can't for the life of me keep track of which. I'm pretty sure it's not that one. It's one of those two. Let's see. If this is a 6, then I want these two to sum to 7 without being 2, 5, or 3, 4. So that would have to be as 1, 6 in that order. If this is a... Wait, no, that doesn't work. If this is a 6, I need these to sum to 7, but there's no way to sum to 7. Because if this is a 6, then I need these two to sum to 7, but I can't use... I can't use 1, 6, 2, 5, or 3, 4. So this can't be a 6 either, right? So I think this just has to be a 7. With these two summing to 6 and being 5 and 1. Let me know if I did something wrong there. That's not a 7. So these are not 4 or 9. So that's a 1. That's a 7. Now, because these are a 6, that puts the 7 there. Yep, I actually remembered to put the 7 in box 3, somehow miraculously. Okay, these two digits we now know. They are 3 and 6. Okay, so far we're summing to 9, and we're pointing at a 4. And we could be pointing at this 4 if the sum is 21, or this 4 if the sum is 17. Let's see, so if I wanted to sum to 17 now, what would I do? I would make these sum to 7, which would have to be as 2, 5, but that seems possible. If I wanted to sum to 21, I would need these to sum to 12 without using 5, 7, or 3, 9. It'd have to be as 4, 8, but that also seems possible. Math wrong? What did I math wrong? You can place 5 in box 5. Check the sum to 17 again. Oh, if I wanted these to sum to 17, I would need these two to sum to 8. Right, okay, so... but that's even better, because if I want to make them sum to 8, it's not possible. It was worse. It's much better, because they can't be 2, 6, 3, 5, or 1, 7. So that means these don't sum to 17. So they're not pointing at this 4. They are pointing at this 4. So these sum to 21, and are 4, 8. in order to make that work out. Let's see. Now, people are saying I could place a 5 somewhere. I think it was in this box. Let's see. The 5 doesn't go there, so the 5 goes there. So that's good. Okay, so this is not 5, 6, so this is 3, 8, or something, something. So this green cage is not 24. Okay, so this green cage is another 13 cage. Good point, Listesh. Because now I would need, again, for this to be 24, I would need this to be 7, 8, 9, and these two cells can be neither 7 nor 8. And in this puzzle, I can't put both 7 and 8 in this cell. Let's see. Let's fill in these candidates. That will probably make my life easier. 3, 4, 5, 6, 7, 8, 9. These aren't 2. These are... Oh, sorry, I already had an 8. These aren't 6. They aren't 4 either. So that's a 9. That's a 2. These aren't 9 or 2. So they're a 4, 6 pair. Oh, the math errors are always on. That is expected. Okay, let's see. These are 1, 3, 4, 5. These are 2 and a 9. Okay, and this being a 2 or a 9 is great because it tells me this is also a 2 or a 9, and it's not a 2, so it's a 9. So that's a 9, and that's a 2. So that's a 9. Okay, and so now this can't be a 5 anymore because I need these to sum to 13. So that's a 1, and that's a 3. That's a 5. Okay, that was a good little bouncing around. So that's a 1, that's a 9. Oh boy. Okay, let's see. These aren't 9. These aren't 6. Oh, they already weren't 6. Disappointing. This 3 sees over here and fixes that's a 6 and that's a 3. Okay, I don't know why this is pencil marked as a 6. Okay, I will mention, or I do notice that someone keeps suggesting that I look at column 5, so let's fill in candidates in column 5. There seem to be a lot of them, but I trust them. Let's see, so I need a 2, a 3, a 4. I don't need a 5 or a 6. I need a 7 or an 8. Okay, well, this is not a 7. That might be all I get. Okay, this is not a 2. Let's see, if this were a 3, it would need an 8. That would be a fine. If this can't be a 4 because it would need a 7 and it can't have one. If this were a 7, that's fine. If this were an 8, this would be a 3, and that's fine. None of these are 3 because of the box. That's not 7 because of up there. It's not 2 because of up there. So this is only 4 or 8. 4 would go with a 7. 8 would go with a 3. But 8 doesn't work because 8 only goes with a 3. So that's a 4. That's a 7. So these aren't 4 or 7. So that's not a 7. That's not a 4. Let's see. So 2, 3, 8 stuff. Oh, this is not an 8, so it is a 2. Let's see. Okay, so what's left in this box? We still need a 1, a 5, and a 6, and an 8. These aren't the 8. That's not the 1 or the 6. That's not the 5. Actually, these aren't the 6 either, so that's the 6. These are from 1, 5, 8. I don't think I know the order yet. So what's left in this column? Have a 4, 7, 8. Let's see, that is a 7. Or sorry, that's not a 7. That's not a 4 or a 7. So that's an 8. A 4, a 3, an 8. That's a 7. Good night, Yavlichka. Thanks for joining. Let's see. These are not 7. Okay. How about this? This is a 3 because they need to add up to 11. And so now I know what this cell is. This cell is a 4, so that's a 6. That's a 4. Let's see. These aren't 3 anymore. Nor are they 8. So that is a 7. That's a 6. These aren't 6 anymore. Sorry, they're not 6 anymore. So that's not a 9. Okay, what about this box? Actually, this box first. We still need a 2 and a 9. And that's fixed, so that's a 2, that's a 9. 2, 3 over here. That's a 3, that's a 2. That 3 looks down, that's an 8. So these 2 digits are a 1 and an 8. Sure. Okay, and so now we've just presumably got to fill in these rows. Did I fill in a cage here that helped me do something? What about this cage? Maybe I should look at this cage. So these sum to 8. If this is a 5, then they would sum to 8 plus 6 is 14, which is bad. So this can't be a 5, because if this is a 5, again, this is a 5, this is a 1, 6, 2 is 14. That would say that cell's supposed to be a 4, and it's not. So this can't be a 5. So it's an 8 and a 1 and a 5. So ergo, these are 3, 4, 6. No, not 4. Try again. 3, though, I agree with. And an 8. 3, 6, 8. This is not 3 or 8, so it's 6. So these are not 6. Try again. They're not 6. They're not 6. There you go. Third time's the charm, as they say. These are 2, 3, 4, 5, 6, 7, 8, 9. 2, 4, 5. That one's not a 4. That one's not a 2. That one's not a 2. So that one's the 2. Let's see. And these are a 1, 2, 3, 4, 5, 6, 7, 9. Okay, and now this should start to collapse everything because we're basically out of stuff to do if it doesn't. That's a 7. This 1 doesn't help. This 4, 5 looks up and sees that's a 4, that's a 5. Okay, so now this is a 4, that's a 1, that's a 5. This is now some sort of deadly pattern that's going to be resolved by something. Oh no, it's not a deadly pattern. It's just a 1 looking at that. 8, 1, 3, 8, 9, 3. Yes, what a puzzle. That was pretty cool. The rule set there is really, really interesting. Alrighty, I am going to be right back. I'm going to numb some calories, but we will be back shortly. Oh, Mark solved this one. Cool. I will see you in a few minutes. Hello again, everyone. I have returned. Thank you again to our patrons. We really appreciate your contributions to help us get things like camera stands so that I shake at least a little bit less. Thank you, by the way, Starwarigami, for recommending my... I just peeked in the Discord to see that you recommended my Schrodinger puzzle, which I quite enjoyed setting after the last stream. All right. So, we get to do some fun with Kropki and arrows, courtesy of Abed Hawila. Okay, so we should say what the rules are. So, in an arrow puzzle, the circle tells you the sum of the digits along the arrow. So, for example, this could be a 7 if this is a 1, a 4, and a 2. All it's saying is that 7 is 1 plus 4 plus 2. Oh, bye, Starwarigami. White dots tell you that the digits in them are consecutive. So this could be a 4 and a 5. That's perfectly fine. And black dots tell you that the digits between them have a ratio of 1 to 2. So this could be a 6 if this is a 3. And that's all the rules that you need to know for this puzzle. In case you're wondering, and this is explicitly stated in the rules, not all of the dots are given. Yeah, I had a similar reaction, Listash. This is probably going to be a puzzle about coloring with respect to parity. So, hey, Alvaro, welcome. So the first thing I know is that if I want to put 3 black dots in a row that all see each other, then I have to put a 2 or a 4 in the middle. And so these digits are always from 1, 2, 4, 8. And so if we're going to just believe that we're going to be coloring with respect to parity anyway, let's just do it. So we'll say, that is even. Okay, so... Oh, Tristan, are you around to give the link? I think he is. If not, I might be able to dig it up. Possibly. Sorry about that. Let's see. Tristan doesn't seem to be around. Let me try and find it. Okay. Oh, there we go. Never mind. He did. Okay. So, people are talking about what happens if there's a 1 on this dot. And what happens if there's a 1 on the dot is that these cells sum to at least 2 plus 3 plus 4 plus 5, which is 14, which seems okay. I'm not... Oh, sorry, no, it's much worse than that. Because if there's a 1, there's also a 2 and a 4. And so if this is 1, 2, 4, then suddenly these cells are at minimum 3, 5, 6, 7. And the total of 3, 5, 6, and 7 is too many. It is 8 plus 6 is 14 plus 7 is 21. I can't make these two circles add to 21. Okay, so in other words, there's no 1 on these. And the fact that there's no 1 here means that the middle is actually known to be a 4. And these are a 2-8 pair, and so everything on here is even. Hey, Hawila, welcome! I have written down that you gave me permission to do your puzzles, although I couldn't quite remember it, but I wrote it down, so hopefully I remembered correct, or hopefully I notated correctly that I had permission to do your puzzles. Also, Digit Dance, because we got that 4, which is very exciting. Is there a way to open it with CTC? I think Tristan can give you a tiny URL that will let you open it with CTC. Yeah, we've got a digit. Thanks to chat. Okay, so So now the question is, okay, what is the minimum I can put on these now? The minimum I can put on them is a 1, 3, 5, 6, 7. No, sorry, 1, 3, 5, 6. What's that total? That totals to 4, 9, 15. So that's not quite enough to tell me anything. Now, if I didn't use a 1, now I would be over. So there definitely is a 1 in one of these cells. What if I didn't use a 3? Then I would be at 18, 19. That's also too many. So there is both a 1 and a 3 on these arrows. And if you look at them, they have to go on different arrows. Because if I put the 1 and the 3 on one arrow, then now suddenly I'm choosing from a minimum of 5, 6 on the other. And that's just definitely not going to work. Okay. So I think I'm supposed to look at this row. I think I was supposed to look at this row to start, and I just didn't. So I know the sum of all of these digits is even, because every arrow has an even sum. And that's because this digit has the same sum as these digits. And so this definitely has an even sum. That's an even sum. So these have in total an odd sum. These then have in total an odd sum. So if we just keep track, this is odd. These are again even. So I'm just going to take away the things that are even. And so that's an odd sum. So these have to have... Wait, did that go not the way I wanted it to? So these have to have an even sum, right? Let me just triple check. Yeah, so these have an even sum. Now, what are they? Well, if I look at the box, this is, by the way, because the whole row sums to 45. So the sum of the whole row is odd. So these are already odd. These are even. And so these have to sum to an even number. Now, 2 digits summing to an even number means they have to be the same even oddity. And in this case, because every pair of numbers on white dots has opposite even oddity, these two things have to have the even oddity of odd, because if they're not, then I'd have 2 evens here, but that would make 5 evens for the box, and there are only 4 evens in a box. So these are odd. That was the punchline of all of that work. Now, that also tells me now I've got all the odds in the box, so this cell is in fact even. So thank you for bearing with me as I explained this, and thank you for those of you who are old hats at this sort of shenaniganery. Now we want to do the same thing with this column, I think. So let's play the same game. So this cell is even, so I'm going to take it out. These cells sum to an even, so I'm going to take them out. These cells sum to an odd number, and so these cells also sum to an even number. So these two are the same parity. Do I immediately know what that parity is? Let's see. If that parity was even, that would be all the evens in the column. And this would be 4 odd numbers in a row. It would be 1, 3, 5, 9. That seems okay. As far as I can tell. Am I supposed to be looking mod 4? I might be supposed to be looking mod 4. Because once I know the circle... Once I know the circle's even, I actually know not just that the sum of these is a multiple of 2. It's actually a multiple of 4. Anyway, let's squint at box 9. So these have an even sum. This arrow has an even sum. These have an odd sum. And ergo, this is even. There we go. Okay, thank you, chat, for pointing that out. I had not quite appreciated that once I showed that these had an even sum, then I could look at this box and actually identify this circle, because those had an odd sum, even, and even. Okay. But now, these can't both be evens, because that would be too many evens in the column, so these are both odd. So now, if I look at this, okay, yeah, so people are pointing out these are arrows of length at least 6. Sorry. These are arrows of length 3, and so their total is at least 6 because the digits all see each other, so these are actually a 6-8 pair. Which means the odd in this column is actually quite small. It is 1, 3, 5, or 7 in order to make that work. It can't possibly be a 1, right? I think it can't possibly be a 1. Okay. Oh, Listesh has an interesting point, which is where's the 9 in column 7? Well, it's not up here, because the 9, as I noted, would go with an 8, and there's already an 8 gone. So there's a 9 down here. Okay. So these 3 cells sum to an even number. But they can't all be even. Because if they were all even, they would be at minimum 2, 4, 6. And spoiler, 2, 4, 6 is too many. So there are 2 odds and 1 even on here, which is interesting. Same goes here, actually, I think. 2 odds and 1 even. Yep, that's true. Not immediately useful, but worth writing down. I suppose it's worth marking where does the 9 go in this box. It goes in one of these 2 cells. Let's see. Where's the 7 in column 7? Ah, the 7 in column 7, for exactly the same reason, also has to go down here. So actually, this is a 7-9 pair, which actually makes this even and makes it a 6 or an 8. Beautiful. Okay, so that is all helpful. Let's see. So I can't put both 5 and 4 on this arrow, which means I can't put... Which means I can't put 5... Or, which means I have to... Wait, no. Sorry. Brain. Yeah, let's look at this the other way. What happens if I remove 2 by putting a 2 here? Well, then I could leave, say, I could make this a 2-3 pair, in which case then these would total at least 1, 4, 5. That's too big. And because this needs an even number, that even number has to be 4. So these are from 3, 4, 5. Okay. Can the 2 go up here? I don't think the 2... Yeah, for the same reason, there can't be a 2 on this arrow. I think this is also from 3, 4, 5. for exactly the same reason, and definitely has a 4 on it. Oh, let's see. Let's look at this box. Do I want to look at this box? Let's see. I know these have an even total. So these all have an odd total. So if this was even, this would be odd. And that's not super exciting. I don't quite want to dive into mod 3 yet, unless I have to. Let's see. Looking at this is suspicious, but not immediately compelling. Let's see. Let's look at chat. Oh, yeah. This can't have a 4 because there's a 4 looking at it. So this is either 1, 2. But let's look at that. If this is 1, 2, then these would be at least 3, 4, 5, 6. And I think I did this one earlier. 3, 4, 5, 6 totals to 4 times 4.5, which is 18. 18 is too many, because then I'd need both of these to be 9. So this cannot be 1, 2. But then there's only one option, which is that this is 3, 6. So these are 3, 6. These are not 3. So they just are a 4, 5 pair, which means that this arrow is 1, 2, 3. Now, fun fact, I know the sum of 1, 2, and 3. It is 6. So that's a 6. That's an 8. So this is 1, 2, 5. These aren't 5. Okay, so now I know this digit's even, because these sum to an even number, these sum to an odd number, so this digit's even. And moreover, it's an even number that's not 4 or 8. Or 6. So it's 2. And so that's interesting, because I'm not allowed to have a 2 in here. So if I minimize these digits, then I'm going to get 1, 4, 5, 7, which sums to 17. So the only way this works is if these are an 8-9 pair. And so these arrows have to be an 8-9 pair. I don't know the order yet. But that does mean that 9's a line around here, so there is a 9. In fact, actually, I can just write these digits in. I don't even have to worry about that sort of fanciness. There's a 1. We got a 2, 3, 4, 5. We need a 6 and a 7. Okay, spoiler, this is not a 1, because the sum of these two digits is bigger than 1. So this is 6 or 7. So interestingly, this arrow can't have a 3 on it. This has to be the arrow that has the 1 on it. Because if this had a 3 on it, and it wanted to sum to 6, it would need another 3. That's not going to work. Uh-oh. People are saying I didn't do that right. Oh, no. And I had such a cool deduction, too. Let's see. Okay, so let's try again. So 179. And that's going to be sad, because now I'm not going to get the cool deduction that there has to be a 1 here. Sad, sad. It's still not a 1, though, for those of you who like that kind of thing. So this is either a 1-6 adding to 7, or it is a 3-6 adding to 9. So actually the weird thing is there's always a 6 on this arrow. It's super strange. By the way, that's odd, as are all of these numbers. Very odd. Someone suggesting I look at the digit that's being looked at by that. Thank you, Alima. So these are a 1, 2, 3. Let's see. So no 1 on this dot. So this dot is either 2, 4, 4, 8, or 3, 6. I guess that's a lot of options. Probably don't want to pencil mark that. Yet. Let's see. What do I have left in this box? Let's see. Well, there has to be a 6 in here somewhere. Might as well note that. Where's the 5 in this box? Well, I know the 5 in this box is not on one of these dots. So the 5 has to go in one of these two cells. Now the 1, 2, actually, if I look at them, the 1, 2 can't go in here. So the 1, 2 actually go on a dot. So one of these dots is 1, 2. Oh, and it's not this one, because that would give me 4 1, 2, 3s. So this is the 1, 2. And so we've got 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6 are taken over. So these are from 7, 8, 9. The 8's definitely on the dot. And these are from 5, 7, 9. So that was a pretty cool chain of events. Which bounces down here and tells me that this is a 3. So these aren't 3. So it's odd. Doesn't quite tell me what's going on with this arrow yet. Let's see. Oh, this... Wait. Oh, I don't know if this is roped yet or not. That is not yet known. Yeah, and this could be a 3, 6 if it goes the other way. The circle in box 1 must be 6, 7, 8, or 9. We know a bunch of odd numbers in box 5. I don't think I see the odd numbers in box 5 yet. Oh, that's right, because there's always a 6 on this. Right, I said that, and then I didn't pay attention. There's always a 6 on this arrow. We just brute forced it. And so that's the last even. So all of these are odd. So this digit is even. It's not a 2. It's not a 4. So this is a 6 or an 8. Oops. Or it's yellow or orange. Take your pick. It's definitely even, though. Oh, and it's not a 6, because we know there's a 6 over there. So this is an 8. And so this is either 1, 7 or 3, 5. We don't know which. Okay. Thank you, chat, for helping me with that one. And that's great, because that's going to come down here and give me that 9 and that 8. The 9 is a 4, 5. It's the only way to make 9 out of these numbers. So the 8 is a 1, 7. Okay, and so we get various parity, coloring, nonsense, goodness of various sorts. Okay, so that sorts out this. That's a 7. That's a 9. That's a 2, and that's a 1. So even, odd. Okay, so now we probably know enough to identify what this is. So this is not... It's not a 1 or a 2. It could be a 4, but it can't be an 8. And it could be a 3. Okay, what about this one? So this could be Oh, that's annoying. This could be a 2 or an 8 or a 6. Okay, that was not as helpful as I had fantasized about it being. But interestingly, it's always even, regardless of what it is. Let's see. This is just a delightful puzzle, by the way. One in box 9 is the wrong color. So it is. Ah, so actually if I pay attention to that, that actually tells me these are both even. Because I've got all my evens in this row. Sorry, I've got all my odds in this row. So these are 2, 6, 8. As a triple. This column has 4 odds already, which is impressive. It's been working out, I suppose, question mark. Let's see. 8 in box 1 can be placed. Let's see. Well, it's definitely along here somewhere. I'm going to guess it's not going on an arrow for some reason. I don't think I see why 8 can't go on an arrow with a 1 and a 9 yet. I presume I will in time. Oh, because I need an 8 in row 3. Right, okay. That is the better way to look at it. Where is 8 in row 3? It's there. And that is a blue number. Let's see. So where else are we going with our lives? We need a 4 over here and a 7 or a 9. Well, that one's not a 9. Yeah, the 9 in box 1. Oh, sorry. The 9 in box 1 is in one of these two places. Listesh points out and is completely right. I can't put 9 on an arrow because I have to add something to it. And unfortunately, we can't use zeros in this puzzle. So the 9 now in this box goes in one of these two cells for the same reason. Let's see. Where is row 7, column 4? That's not at all row 7, column 4. Let's try that again. Where's row 7, column 4 in box 5? It has to go there. So this is a 7 or a 9. So one of these is a 7 or a 9. Oh, I guess I know exactly what these cells are. Why have I not filled them in? They are exactly 3, 4, 5. Yeah. So that one's not a 4. Bye, Nicholas. Thanks for stopping by. Hey, Luis. Five in box 5 is vertical. Oh, right. The 5 never went here. Just because I need this to be 7 or 9 with a 1 or a 3 is not going to work. So the 5 goes in one of these cells. Thank you, Listesh. That's a great observation. So that's not a 5. So this is a 3, 4 pair. So this is a 5. And more importantly is orange. So one of these is a 5. Let's see. Bye, Panthera. Thanks for stopping by. So 3 in box 1 is in row 1. Where did we get to 3 in box 1 from? Yeah, two of the ideas that I had in mind were double arrows and equal sum lines for Schrodinger arrow-like puzzles. I think with an arrow, the problem with an arrow Schrodinger puzzle is, let's just briefly pause and say, imagine this cell is a 3-5. What does that mean? It's not quite clear. But with a double arrow or an equal sum line, you can just say, it's both a 3 and a 5, so you just add them both in. So that's why I sort of went to that. But I think there are reasonable answers to what you could say. And you could even say you just can't put a Schrodinger cell in the circle. I think that's fine too. But whatever you like. Yeah, Bremster, I don't know why I do that. It's a reflex. I think I saw Glum Hippo pointed out first, and you'd think having it pointed out would change it, but it turns out it does not change it at all. Let's see. Could these be 3-4? I think they could. It's interesting because Schrodinger cells have this interesting thing where they either want to be and or they want to be or, depending on the constraint you're talking about. So in the case that Chad is suggesting of, you could have a Schrodinger arrow where you have a Schrodinger cell here and a Schrodinger cell here and say this is a 1. That wasn't a very good 1. And then this is a 2-3 Schrodinger cell, and then this is somehow a 3-4 Schrodinger cell. Obviously, this breaks all kinds of rules. But this is sort of a sensible way, if you're thinking of this as being or, of this makes sense if you take the right pairing, versus you're just literally considering both of those digits to be there for all purposes. And I think there's going to be space for people to explore both of those options as Schrodinger cells replace other Sudoku variants. Yeah, in different boxes, I had imagined. Let's see. I won't tell him, Bremster. Row 2, column 3. If this is a 7, then it can't be 3 plus 4. Yeah, there's always a 6 on this arrow, weirdly. So this arrow is always... Yeah, I could even write that out in a way that is more normal. These are 1, 3, 6. What are the candidates for these? Okay, so this can't be a 3. Let's see. Could this be a 4? I think this could be a 4 if this were 1, 3. I think it could be a 5 or a 6. Or a 7. Can't be an 8 or a 9. It's... Oh, wait, no, sorry. We don't have a triple down here. We do know one of these is 4, though. So it's not 4 because one of those is 4. Those are the only places for 4 in the row. So this is 5, 6, or 7. Likewise, this can't be... Oh, wait, no, this one could be 3. Oh, that's annoying. because this one doesn't eat up a row, so the 1, 2 doesn't even block this. So this feels like it can be anything. Like, I think this can easily be a 3 without breaking anything. Let's see. Oh, yeah, there is the question, where is the other 1, 2 in this row? Because there has to be another 1, 2 in this row, and Luis points out it's not here because of this 1, 2, 3 triple. This is what Simon always calls the New York Times trick. And so that's not a 1 or a 2. Even though this could be a 3, it's not a 1 or a 2. So this is always a 1 or a 2. That is an excellent spot by Luis. Let's see. I unfortunately don't think we get to do anything similar with 1 and 2 here. There does have to be a 1 or 2 in one of these cells, but who knows? Who knows what it could be? So this can't be a 9 anymore. Because if this were a 9, I'd need this to be a 7, but then this all breaks the world. So actually that places the 9 here and the 4 here in the weirdest way I've ever seen. So let me just explain that again. We knew 9 was in one of these two cells. If this is a 9 now, how does that work with this being a 1 or a 2? Well, it can't be a 1 because then I'd need an 8. So it's a 2, which means that's a 7. But now both of these cells are 4. So not a 9. This is a 9. And now we needed a 4. So we go blue and oranje. Okay. So now 7 needs to be in one of the circles. There's no choice for 7 but to be in a circle because all numbers bigger than 7 are gone. So this isn't a 7. We can at least say that much. And the only way 6 gets to play on an arrow now is if 6 is with a 1 on the arrow that sums to 7, which is very, very interesting. Let's see. Okay, what Ranks said about row 2, column 3. Oh, this has to use a 1 or a 2. Oh, yeah, because, well, it can't be 3 or 4. Okay, yeah, so there's a 1 or a 2 one here. So this digit here is at least as big as 3. 3, 5, 6 are the options. Because there's a 1 or a 2 one here. Yeah, so Carl is pointing out maths. This box sums to 45. I can take away the 21, so these sum to 34, which means the sum of these two circles is... I did that wrong because I got 17. Let's try again. The sum of these is 21, which means the sum of these is 24. Now that's twice the sum of these two. So these two have to sum to 12. Which means this can't be a 6, because it would have to be double 6. So that's a 5, 7. And so so math is useful. So one of these is a 5, one of them is a 7. And the one that's a 5 is going to be 2, 3. And then the one that's a 7 is going to be 1, 6. So that's not a 5, and that is a 5. That's at least something. Yeah, that was a very nice that was a nice mapping. I approve of that. So this isn't a 5. For reasons. Okay, so this is either 3 going with 2 and a 5, or 6 going with 1 and a 7. Okay, so does one of these combinations break a row or column or something? That would be cool. Like, if this is a 7, that goes with a 1. Is that a problem? No, it's not a problem. I could have both my 1 2s in this column. That would be fine. There's nothing wrong with. I mean, this can't be a 1. Yeah, it can't be a 1 7 pair. It's never going to be a 1 7 pair. That gives me a 3 6 pair out of nowhere in this column. So I could do something with that. So these are 1 2 3 4 5 6 7. Okay, well, this is not a 1 or a 2. I can at least say that much. Well, this can't be a 7 anymore. It's never been able to be a 4, owing to that over there. This I don't think I know anything at all about. So 4 would have to be 3 and 1. Looks fine to me. 5 would be what? 5 would be 1 and 4, 2 and 3. Both of those look fine. 7's got even more options, I presume. Okay, let's see. Ranks says there's a hidden 3 in row 2. Oh, nice. Gorgeous. Okay, none of these are 3. None of these are 3, so that's 3. I don't know if it did anything, but it is a good point. These aren't 9 anymore. There's another point. 5 is odd. There's another point. Let's see. Row 4, column 1, and row 6, column 1 are a 1 2 pair. Oh, right. They're the only places 1 and 2 can go in the row, because we've got a 4 5 7. Sorry, in the column, because we've got a 4 5 7 triple. Beautiful. Yeah, there's a 4 5 7 triple in this column, so these are not 4 5 or 7. Okay. Does that impact anything? Like whether this can be a 5, for example. I don't think so, because this would just be a 3 or a 4. That seems fine. The 5 7 pair. These are both odd. That is worth marking, because coloring is good. Let's see. So we said the 5 is 2 plus 3. Yeah, the 3's up here somewhere. Yeah, it's not super helpful. Let's see. Barbie has a good point. 5 7 pair in row 3. Makes this an 8 9 pair. And now where is 9 going in row 5? Okay, so 9 is locked out of this box. 9 is locked out of here. And here, actually. That is an excellent point, Barbie. Now I can only put 9 in all of this row. I can only put 9 here. Because if I try and put 9 on this white Kropki dot somewhere, I have to put it with an 8, which is going to immediately break that. So that's a 9. So this isn't a 9 even in the corner. And this is, I believe, a 5 or a 7. Yes, it's a 5 or a 7. Row 7, column 4, also a 9. I'm not sure I see why. Or 7 in box 5. Oh, because 7 in box 5 is now locked into this column. Got it. Because 7's not over here. So 7's here now, which means that's a 9. Which means that this is a 3, 6. Which means that these are a 1 and a 7. Which means that this is a 5. And that's going to do a lot of damage, presumably. That's not a 1. I was hoping for more damage than that, I'll be honest. Let's see. So we've got a 9 up here somewhere. This is not a 9. Sorry, that's not a 9. This is not a 9 either, but it's not even pencil marked to be a 9. This can't be a 3 anymore because it would break this 3, 6. So this is a 4. That's a 3. That's a 2. These are not 2, which lets us do some coloring. Coloring. Okay. This is not a 6. That's a 2, 8 pair. That is not a 2. Let's see. What is left in this column? Not much. We still need a 6 and an 8. And a 9. No, 9 is not right. 3, 5, 7, 9. Oh, actually, we just only need evens left in this column. So this is just a 2, a 6, and an 8. No. A 4, a 6, and an 8. Wow, okay, so that's a 4. I think that is what chat was describing, but I'm not sure chat was quite as elegant about that as I was by repeatedly wrongly marking what was left in the column. But hey, we got there in the end. Let's see, what are these cells? Let's see if we can do better this time. We still need a 6, a 7, and an 8, and a 9. That's too many digits. Oh, no, it's not. That's the right number of digits. Let's see. These aren't 7. So that is 7. That's a 1. That's a 7. That's a 3. That's a 1. That's not a 9, so that is a 9. And so coloring happens. And that's an 8, and that's a 9, so coloring happens. 9 in box 2. We got there eventually. Let's see. Oh, yep, 2, 8 pair. Beautiful. So that's a 6. That's an 8. Let's see. Okay, what is left in this column? Is that where I want to go? What's left in this row? Maybe that's where I want to go. It's going to be 1, 2, 3, and 6, isn't it? That one's not a 2. So that one's not a 3. Ah, this is never a 1, because if this is a 1, it goes with a 7. So this is a 3 or a 6. Ah, that's a 3 or a 6. So we do get a 1-2 pair here, strangely enough. So... Oh, I guess we could have... Wait, no, that's not... Is that obvious? Ah, this 1-2 pair looks down and tells me that that's a 7 and that's a 1. So it did actually tell me something. It was not worthless. Okay. We need a 3 here. 5 and a 6. And a 7? And not an 8 or a 9? Sounds right. It was not as helpful as I had hoped, I'm going to be honest. Let's see. Box 5, we can color. Ah, and I can even put these in. So orange and blue. And that's going to place the 6 down here. Three in box 2. That's not box 2. 3 in box 2. Looks at box 5. Yep, we got that. Let's see, are we running out of options on this somehow? I don't think so. It's got to be this one, doesn't it? 3-1, that would be fine. Okay, what's left in this column? Lots of things. 3 3s, apparently. 4, 5, 6, 7, 8, and a 9. The 9 does not go here. Okay. Are there any things that, because of this arrow combination, don't work even though they look like they work? Not that I can see. Let's see. 1-2 pair in row 6. Ah, yes. Beautiful. This is not a 5 because there's a 5 in the row. This is not a 3, by the way, or a 5. So this actually has fewer options than I may have led you to believe. So that leaves us with 4, 6, or 9. This is not a 6. This is not a 9. Four, 7, 9. Uh-oh, I did it wrong. No. Let's try again. There's already a 6 in the row, I'm being told. Which is disappointing. Let's try again. 4, 5, 6, 7, 8, 9. That's too many digits. Oh, that's right. We're doing this because there wasn't a 6 there last time. So that's not a 6 in particular. So this is not a 9. Let's see. So this white dot can't have a 6 on it. Because if it were a 6, this would want to be a 7 or a 5. Four, 5, 7, triple. Oh, 4, 5, 7, triple. Beautiful. Okay. So 4, 5, 7, triple in the column leaves us with a 6 and a 3 to finish up the column. If this were 6, it would place a 5 or a 7 here, which Tall Cat does not like. Let's see. 7 must be in row 6. Okay, how are people seeing right away that 5, 7? Okay, it can't be a 5 because there's a 5 in the box. Why can't it be a 7? 7 horizontal, 5 on arrow. Let's see, Oh, yes, okay, 7 down here. Okay, got it. There we go. Okay, so that's tricksy, but I agree. This can't be a 6 anymore because if it's a 6, the adjacent numbers are 5, which is over here in the box, and 7, which upon closer inspection is over here in the row. So this is not a 6, it's a 3, and that's a 6. So odd and even. We got there eventually. Okay, so this is either a 4 or a 2. The important thing is that it's blue. 3 goes with 4. Let's see, 1, 2 pair from the top. 1, 2 pair from the top. Beautiful. That's a 4, so this isn't a 4 anymore. So now it's odd. This is not a 3 or a 4. This is not a 6 or a 4. Let's see, there's so much Sudoku happening. Be careful not to miss any of the Sudoku. Okay, that's not a 3. Let's see. Oh no, 6 is not hidden in the row. It can go in those two places. Let's see. This is not a 4 anymore because there's a 4 in the box. So in my efforts to keep track of the Sudoku, I did a good job at eventually finding the 4. Let's see. So these are orange. That's orange. That's blue. That's blue. Da dee 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 da 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 dee dee da da do, or something. Let's see. What is this? 1, 2, 3, 4, 5, 6, 7, 8. That's an 8, and it gets to be blue too. So now we break into the middle box. 2 and 8. Which you'd think would be useful. Okay, so that's a 1. So this has to be a 6 because they have to be opposite parities. So that's a 7. That's a 5. This is a 3. It's a 9. That's a 2. That's a 1. Let's see. So that's a 7. That's a 1. Let's see. These are blue. These are orange. Let's see. This 5 looks over here and sees that that's a 2 and that's a 5. That's an 8. That's a 2. I don't think that did anything. This 4. There we go. That 5 and that 4. That... I thought that would do something. This 6. 3 and 6. That 6 looks up here. So that's a 3 and a 2 and a 1 and a 6 and a 5 and a 7 and a 1 and a 2. And there we go. Very nice puzzle. I quite enjoyed that one. And the parity logic in the beginning was really nice. I really liked how that was telegraphed and everything. I don't know. Yes, very, very good puzzle. Let's see. What do we have up next? Oops. Next up, we have a Renban Skyscraper by Florian Wortmann. I was considering a Renban Skyscraper, but then I was really happy to find that someone had already made a Renban Skyscraper. So I am looking forward to just doing a Renban Skyscraper and then making one. Yeah, that was a lot of fun. Hey, Jason. So I think this is standard rules for everything. So these blue lines are Renban. Oh, awesome, Franco. I'm glad to hear it. Hopefully it was worth the effort. Good night, Listash. Thanks for stopping by. Yes, so, yeah, there is evolution in the colors of Renban lines. Renban are now baby blue for this puzzle. So, Renban lines, actually, I think this is the first puzzle with a Renban line in it we've done today somehow. Renban lines must contain digits that are consecutive, but in any order, which sounds paradoxical at first, but what it means is that I could put a 2, a 3, a 5, a 6, and a 4, and this would be a perfectly valid way to fill the Renban line. Bye, Janesh. See you later. Thanks for stopping by. So that's how Renban work. And then we also have skyscraper clues, which tell us if you imagine that you're standing... Oops, can't put another 3 in the line. Whatever that digit is. If you imagine that you're standing on this side of the world... then this clue tells you how many buildings you could see if you imagine that you can only see numbers that are bigger than the biggest number you've seen so far. So you start looking at this side and you see the 3, and then you see the 8, but now you don't see the 4, the 2, the 1, the 7, or the 5, because those are all smaller than the largest number you've seen so far. And then you see the 9, and then whatever digit this happens to be, I don't know that it's possible to figure it out, but whatever digit this happens to be, you don't see it because it's probably less than 9. Okay. So that's how skyscraper clues work. Oh, bye, Andrew. Okay, so we have to figure out what it is that we're going to do. Hey, Florian, glad you could make it. We have to figure out what we can do to make everything happen. Okay. It could even be a boat, as they say. One thing to note is that, as Tallcat says, 9s are awfully restricted, because you're supposed to see 6 buildings, or 6 numbers, if you look from this side. Oh, sorry, those are supposed to be yellow. Which means I can't possibly have a 9 until I get to here. But now, on the other hand, looking from the other direction, I also have to see 3 buildings, which means I can't possibly get a 9 until I get here. So actually, I'm going to pencil mark this 9 in this row across these boxes. One of these 2 digits is a 9. Okay. Let's see. So something similar happens in this column, where I can't get to 9 until here, and I can't get to 9 until here. So one of these has to be a 9. Now this can't be a 9 because it would break the 3. So one of these two is a 9, which is interesting. Okay, so now 9 is ruled out of all of those cells. Maybe not quite enough to do anything with that. So are we supposed to start thinking about 5-cell Renbans now? So the thing about 5-cell Renbans is that every 5-cell Renban contains on it somewhere a 5, which is kind of the opposite of what you want to think about if you're thinking about skyscrapers, because 5 is a pretty worthless digit all considered. But one thing it means is that definitely one of these cells is a 5. These aren't 5, because the 5 on this Renban is in this box. So yeah, one of these is a 5. Which is not immediately helpful. Let's see. Yeah, even this could be a 5, right? We do know that the 5s in these two boxes are on these Renban, so there are no bonus 5s, so to speak, sneaking around in here. Let's see. There's a 9 trick in column 7 now, because I know the 9 in this box is gone, so the 9 can't be in the first 5 cells, but it can't be here. So the 9 is in one of these cells. Now the 9 can't be here because of the 4. So the question is, does the world break if I put a 9 here? So if I tried to put a 9 here, I would have to put 8, 7, 6 on here, which seems really problematic. Oops. Because this can't be a 7 or an 8, so this would have to be a 6. This would have to be the 7. But this doesn't work, because now this 3 can't possibly see 3 buildings, because it can only see that one in the 9. So that's not a 9, and so we get our first official digit dance. Okay. And so now that actually places a 9 up here on this Renban, because the 9 definitely doesn't go there. Which is interesting because it lets us write down exactly what is on this Renban. This Renban contains 98765, and the 9 we have said is not in any of those places. Sorry, the 9 is not in any of these places. So one of these is the 9. But that's going to put a lot of pressure on this digit coming from this 5. Because if this were an 8, we'd just be impossible to finish, because this needs to see 5 buildings. And so if this is an 8, it could see at most 3. If this were a 7, we'd still not be able to finish, because it could see at most 4. And so this digit has to be a 5 or a 6. If it's a 6, then we're pretty restricted, because then we still have to see 7, 8, 9 down here. At least we know we're going to see the 9. Let's see. The 4 is under similar problems. If this were an 8, the 4 suddenly can't finish. So this is a 5, 6, or a 7. Let's see. Get 8 and 9 in column 1. Well, 9's not there. Yeah, 9's not here, 9's not here, 9's not here. 9's not in one of those places. Likewise, 8 is not in any of these places. So these things are all not 8 or 9. So what's interesting about that, this is Barbie's point, what's interesting about that is it means there is an 8 or a 9 on this this Renban. Because there are not enough places for 8s and 9s to keep them entirely off of this Renban. So that means that on this Renban somewhere are an 8, a 7, and a 6. Now, this cell can't be 7 or 8. It could be 6, maybe. It could be 6 if it went 6, 7, 8, 9 in some order. That would be okay. So that gives us something to look at. Maybe not immediately the most useful, but it gives us a bunch of pencil marks on this Renban at least. Oh, let's see. I'm hearing tell this can't be a 6. Why can't this be a 6? Oh, that comment has been retracted. So maybe it can be a 6. Okay, so this 5 is going to put some amount of pressure on what this digit can be. This digit can only come from 1, 2, 3, 4, 5, I guess. Maybe that's not the most compelling of restrictions. Yeah, it's definitely a 5 or a 6. Those are the only options. I agree, Trumkle. Now, one thing we learned from before is that I can't put a 9 on this Renban anywhere. Because if I put a 9 on this Renban anywhere... Oh, wait, maybe... Sorry, I don't necessarily agree with that. I retract that comment. Oh, yeah, that's a good question. Where does 8 go in box 9? So it can't go in front of any of the 4s. So the 8 in box 9 has to go in one of these two cells. There's just an 8-9 pair, sorry, in this box, in these two cells, because the 4s can't see an 8 or 9 in their own box. I mean, it still works, though. There's still an 8-9 pair, even if this is the wrong box, Trollcat. You have to understand this. Yes, they can. Why can't there be an 8 or a 9 here? Oh, no. Sorry. Those are where 9s can go. It's not where 8s can go. Sorry. They could be 8. Darn it. Okay, but we'll now look at a different box. Sorry. There is a 9 now, though, just by Sudoku. There's a 9 down here, thanks to you all suggesting that I look at box 7. Let's see, people are suggesting I look at another box 7. Which other box 7 do we want to look at? Oh, we want to look at the box 7 over here. Let's see. So where can 8 go? Not in front of the 5. But the 8 could go, yeah, so not this close in front of there. Yeah, not there. I guess. So it goes in this column is the point. So 8 goes in one of these places in this box. Okay, that's good. What if 8 goes on this? Is that equally problematic? So that would make this 8, 7, 6, 5. I just want to see if that breaks. Well, that would get me a tuple in the column. Let's see, but what would this have to be? Well, it couldn't be an 8, but it could be anything else. But this would have to be a 5 for this 5 clue to possibly work. In fact, actually, for this to work, this whole column would have to go 5, 6, 7, 8, 9 exactly in order for this 5 not to break. breaks the 3 clue in row 9? Why does this break this clue? So that could be a 5, with that being an 8. Then it's going to see the right number of things. Yeah, I don't see a problem with that. But anyway, 8 is in one of these 2 cells. That is something I am happy to use. I think it's probably not here. But I don't see how yet. Ransk is in a state of quantum agreement. Maybe I should ask where 8 goes in this row, because 8 in this row can go maybe here, here, or here, but it can't go there. It can't go there. Certainly can't go there. Probably. Oh, yeah, it certainly can't go there. Or there. Wait. Am I highlighting places it can go or can't go? I've confused myself. 8's not there. Maybe it's there. It's not there. It's not there or there. This probably breaks if this is an 8, but maybe not. No, this does break. This can't be an 8. If this is an 8, then all the lower digits than 8 are over here, and it can only see one of the lower digits than 8. So that does not work. So the 8 in this row is actually stuck in one of these 3 cells. Boy, it really feels like we're supposed to be showing that this can't be 8, doesn't it? Let's see. So here's an interesting point. This 5, seeing a 5, 6 right away is really interesting. And it means that this column is going to have to be... its high numbers are going to have to go almost in order, but not quite enough in order that we're going to force the 8 to go here. Or sorry, that we're going to force the 8 not to go there as much as I would like that. Let's see. So maybe I should pencil mark what this cell can actually be. It can't be higher than 4 in front of the 6. And the ones in front of 5s can't be higher than 5. Oh, how about that? No, 8, 7, 6, 5. Darn it, that can be a 5. Okay. Now I know this isn't a 5 because... remember, there's a 5 on each of these Renbans in these 2 boxes. So there are no 5s in these boxes that are not on these Renbans. So I can at least do that elimination. This is a 1, 2, 3, or 4. Let's see. Is this also a 1, 2, 3, or 4? Because I think this has to be a 1, 2, 3, or 4 as well. It can't be a 5. What if this was a 6? Well, then this 6 wouldn't see 6. So this is also a 1, 2, 3, 4. So that's interesting. So we've got a bunch of our low digits down here. This can't be a 6 because of the 6. If this was a 6, this would see at most 1, 6, 7, 8, 9. That's only 5. This whole ordeal over here was very interesting. But I don't see it yet. Oh, always happy to re-go over things. Most of the time it probably means I screwed something up. But I'm always happy to talk through stuff again, Sam. So row 9, column 9 can't be a 4. Ah, right. Because now there's not enough room. Let's see. So let's try that again. Wait, no. Row 1, column 9. Oh, sorry, this one. Oh, yeah, because then... It's okay. I understand getting it backwards, Tallcat. If this was a 4... Had to go 4, 5, 6, 7, 8, 9. Is that a problem? Oh yeah, that's good. If this is a 4, we're gonna break the 3, right? Are we? I don't know. The 6th clue in row 1 is either a thermo or an almost thermo. Maybe that can be reasoned about. Yeah, the same with the 3 clue. Same with the 3 clue. It's also got to be sort of like increasing. Ah, yeah. Okay, so if this is a 4, neither of these are seen, and then I could only see 1, 2, 3, 4. Yeah, so if this can't be a 4, because then I couldn't see enough things. Got it. Okay. So again, just for those of you who are playing the home game, if this is a 4, I now know I can't see these buildings. And so I could maybe see these buildings, and then there's a 9 at worst here. So I'd see at most 5 buildings, and that doesn't work. So this is not a 4. That is not a 4. Okay. Got it. This 3 seeing... Well, no, that doesn't necessarily tell me much. This column... I'm still very interested by the fact that, like, there's a lot of low numbers down here. Again, something like really interesting happens if this is an 8, which kind of makes me suspect this is an 8, but I'm not sure. Okay. I want to go back to where 8 is in this box, which no one asked about, but I still want to think about. So 8 is definitely not there, we have decided. 8 is not here. So 8 in this box is in one of these top pieces. But it could go there, is the problem. Let's see, we also have this whole... Yeah, this is interesting. Okay, what is this digit? This digit is 5, 6, 7, 8, or 9, which is, again, getting really close to pentuple territory. Digit in row 1. I don't think I see the digit in row 1 yet. These are definitely from 5, 6, 7, 8, 9. That's from 5, 6, 7, 8, 9. How many digits can have the two Renbans... Oh, how many digits can these two things have in common? Asks the Cogito. So we know 9's not on this Renban. Oh, you're a different Sam. Oh, sorry. Eight also isn't on this Renban. I sort of see that that seems unlikely to work. Should it be obvious that 8 can't go on this Renban? Apparently the Cogito is a different Sam, and I am bad at Sam sorting. I apologize. Welcome back, Naverio, after ages. Eights point up from box 9. Ah, right. Okay, so these can't be 8s. Why can't that be an 8? Let's see. So I double click the 9, hoping that it will. Oswald, okay. There can't be a 9 on the box 5 Renban, as it would have too many digits with 5, 6, 7, 8, 9 in the row. Ah, good point. Okay. I like this point. So if we put a 9 on this Renban, then in row 4, we now have a 5, 6, 7, 8, 9 sextuple. And that's not enough for a sextuple. So that means the 9 is over down here somewhere in this box. So there's definitely a 4 on here somewhere, for whatever that's worth. Okay. I'm just going to want to note, in general, if something's in front of a 4, that means it needs to be at most 9, 8, 7, 6. It needs to be at most 6. So I can go ahead and recreationally fill 1 through 6 into these cells. Oops, not that kind of 1 through 6. That kind of 1 through 6. And there's a 5 over here that snuck by me filling in 1, 2, 3, 4, 5 earlier. 9 in column 4. Okay, so it is... Ah, okay, so 9 got... Oh, that's very interesting. Okay, so 9 in column 4 just got squeezed an enormous amount, because we have these 9s here saying 9's not there. We have 9s in this box saying 9's not there. We just said there's no 9 in these cells. So now there's definitely a 9 in these cells. Let's see. Does that do anything interesting? And the 9 in this box is ruled out of this 1 business. So the 9 in this box is in one of these 3 cells. Let's see. I would normally assume the goal in a skyscraper puzzle was to get some sort of 1, 2, 3, 4, 5 quintuple or something like that. But we seem not to have quite gotten that yet. Let's see. Yeah, so we've got the 8s over here. So the 8 in this box is only in one of these 3 cells. Which is interesting because the 8 on this Renban is only in one of these 3 cells. The row 7, column 9 can't be 6. Let's see. If it was, it would have to go 6, 7, 8, 9. Is there a reason that doesn't work? One moment, I'll be right back. I have returned. Has chat solved the puzzle in the meantime? Let's see. Carl has a good point. Let's find Carl's good point. Let's see if I can scroll. For whatever reason, YouTube really doesn't like letting me scroll the chat. Let's see. If row 5, column 3 equals 9, what are we doing? Oh, that's right. We're doing a skyscraper puzzle. All right. Let's see. Okay. Row 5, column 3. That's 9. You can't place 9 in column 2. So the 9 in row 5 has to go in box 5. Okay, interesting. Okay, so we know somehow there's no 9 on this Renban. So if I'm looking in if I'm looking in row 5, then I need to look at places like this. Okay, so those can't be 9. If this is a 9, this would have to go... if this is a 9, then this has to be 8, 7, 6. Oh, you said column 2. Let's see. Where can 9 go in column 2? Not any of these places. Not there, not there. Not there, not there. Oh, that's interesting. 9 in column 2 only has 2 places it can go. Sorry, I'm now distracted by that, because that now can't be a 9 because it sees both of these. Okay. And so now the claim is if... Oh, no, it is only one. It is only one. Okay, even better. Yeah, sorry. Okay, this is huge. Okay, so I think this was the correct question to start. Where does 9 go in column 2? Okay, it can't go in these first two, so it could maybe go there, except it can't because of the 4. It could go there, which is where it's going to go. It can't go there. It can't go there. Now, we've done some work to show that it can't go... Oh, no, we just get that it can't go there from the 4. Yeah, this was placed literally from the first of the puzzle. That is a 9, which is great for purposes of getting us lots of digits. Good spot, Carl. Okay, so that being a 9 immediately tells us that these are 7 and 8. It places the 9 over here. Let's see. So this 3 now has to do a good bit of work. Let's see. Oh, and now where's the 9 in row 5? Oh, the 9 in row 5 is now in one of these two cells. Let's see. As usual, the question is it a problem if 9 is on the Renban? And as usual, the answer is Zeta doesn't know. Let's see. Oh, but this column we now need to look at. Because remember, this column was all about the fact that there were only only 3 places 8 and 9 could go. But now one of them is gone. So this is the only place in column 1 that can accommodate a 9, going back to our much, much, much earlier story. Okay. So that's a 9, which means this can't be a 9 for sure, because if this were a 9, it would break this box via requiring an 876, which would break that. So the 9 in this box is up here in one of these two cells. I realize we have pencil marked this row and these two boxes for 9s, but whatever. Oh, these aren't 6 anymore because sixiness already in the column. Okay, now 9 in row 3. Let's see. I think we're saying this can't be 6, 7, 8, 9 because it would break that 7, 8. Beautiful, beautiful. So that's not a 9. And so now if I look at row 3, I have this little X-wing on 9s up here, which rules 9 out of this cell. And so now the only place 9 can go in this whole row is here. So we've got this beautiful 9. 9s are going to be yellow. I don't know why. But they seem to be enjoying their color, and who am I to deny a 9? So I don't think I need this blue anymore. The 4 clue in row 3 exclamation point. Okay, so now this has to go. So now the 7 has to go before the 8 in this row. Which is helpful, I think. Let's see, can this possibly be a 9? I would really like to know that this can't be a 9. But I'm not sure that I can argue that. Let's see. Is there something where it used to be able to be... We know the 6 on the box 3 Renban in row 2. Why isn't this 6? Let's see. Ambrose. I think the column 9 impacts the 8 position in box 9. Okay, so there was this whole story about whether this could be 8. And if this was an 8, then these needed to be 7, 6, 5. Which meant these were a these were a quadruple. Oh, because of the 6 in box 1. Okay, got it. Yeah, sorry. Sudoku, our friend. This is not a 6 anymore. So there's a 6 up here. I will record for posterity. So Naverio says this can't be an 8 because the column 8 4 clue. Okay. So now, right, this needs to increase. And so if this were an 8, these would be 7, 6, 5. And so now this digit can't be higher than this one because all the high digits are gone. Gorgeous. So not 8. So this is an 8. The fact that these 3 increase is interesting. Where is row 2, column 1 on the Renban in box 3? In box 3. Ah, interesting. This digit is this digit. So this digit, not a 5. That is fascinating. So there is a 5 here, for whatever that is worth. That is a very good catch, Barbie. Let's see, unfortunately, I don't see it immediately leaping off. So now orange. No, it's not true. Orange is in one of these 2 cells. Orange could still be on this Renban. In fact, it's like 50-50 to be on this Renban at this point. Orange is in one of these 2 cells. Let's see. Row 9, column 9 can't be 1. Let's figure out why not. So if this is a 1, then this would go, these would be 2, 3, 4. And there wouldn't be a low enough thing to put here. So yeah, that can't be a 1. And if this is a 5, then we do the same thing. We go 6, 7. Wait. If this is a 5, isn't that okay? Isn't it okay if this is a 5? If this is a 5, we could do something like 4, 3, 2. And then we could put a 1 here and a 7 here. Isn't that fine? I mean, ignoring everything else. 5 in row 9, column 9 breaks the column 9 clue. Oh, breaks the column 9 clue. Okay, so 5. So I'd have to go... Oh, I'd have to see all of 5, 6, 7, 8, 9, but one of them is hidden back here behind the 9. That's the point. Okay, so this little building is in the shade. And so this 5 can't see it. And so I can't start at 5 anymore. So this is 2, 3, 4. Let's see. Do we get a similar game over here? I'm not sure that we do. 8 in box 7. Let's see. 8 in box 7. Can't go any of these places. So yeah, the 8 in box 7 And the 8 can't go here anymore because this goes too far. So the 8 goes here in box 7. And then so the 8 can't go here. So this has actually become an 8-9 pair, which is not too surprising given it's a skyscraper puzzle, that we'd get an 8-9 pair locked away from the clues. Good catch. So now I actually know that the digit 5 shows up on this Renban. No, that can't be right. 4. The digit 4 shows up on this Renban. 7, 6, 5, 4. Yeah, there's a 4 on this Renban somewhere, which is not the most exciting deduction ever, but it's true. There's a 4 on the Renban somewhere. These Renbans must both contain 4. Ah, interesting. Okay, that's true. Beautiful. And that's going to give us that this 9 isn't here. Beautiful. Okay. Excellent point by Josh. So neither of these Renban can avoid hitting 4. This one can't be 5, 6, 7, 8 because there's an 8 in the box already, which means the 4s align in these 2 rows, which means there's a 4 here on this Renban. And there being a 4 here on this Renban means there's not a 9 on it because those are too far apart, which places the 9, the 8, and the 9. That's gorgeous. That's just phenomenal setting. So that is super helpful. Okay, so now this 3 needs to make extra sure it doesn't dilly-dally too much in seeing its 3 buildings. Because if it does, it's going to run into problems. Okay. Now, interestingly, the 8 in this box is definitely on a Renban. So the 8 in this box is in... Well, sorry, I don't know which Renban it's on, but it's definitely on a Renban. It's not in this order, and it's not in this row. It's not there. It's not that either. So it could be over here or over here. See, I'm squinting at the fact that this row has both 7 and 8 gone. So if 8 wants to be on this Renban, it has to be exactly a 7-8 pair, which I don't see a problem with, but it's very restricted, and it's the sort of thing that's likely to become a problem if we squint at it long enough. Oh, now this is interesting. Okay, the fact that this 8 is here has put pressure on this 4 now. I guess all it means is this is a thermo. This could still be a 6 if this goes exactly 6, 7, 8, and then a 9 somewhere. Let's see, where is 7 in box 9? Let's see. Can 7 fit on this thermo somewhere? Let's see. Well, 7 can't go here or here. Obviously not there. So if 7 wants to go here, then it would have to be 4, 5, 6, 7. Can this be 4, 5, 6, 7? Let's see. So if this is 4, and these are 5, 6, and 7, does that break this 4? Yes, it does break this 4. Okay, 7 can't go on this Renban because this 4 would need to see something here between these two, and it can't. Okay, so that spot's also not a 7. Not a 7, not a 7, not a 7. So yeah, the only place for 7 in box 9 is here. Which interestingly means that's not a 7, which means this is a 5, 6 pair. So this is a 7 or an 8, which means that cell's gray. I'm going to reward these with a non-gray color for cooperating. Okay. So Naverio is pointing out row 1, column 6 can't be 1, 2, 3, or 4. Because if this was 1, 2, 3, or 4, we'd have 1, 2, 3, 4 gone, and so these digits would have to be bigger. They'd have to be 5, 6. Well, they're not. They wouldn't be 6. Yeah, so this would have to go 5, blue, 9. And I do see that. Oh, it breaks this skyscraper. Let's see. Okay, so if this is 1, 2, 3, 4, okay. If this is 1, 2, 3, 4 quadruple, where did those cells go in this box? They go here. Which means this digit is bigger than 1, 2, 3, 4. And so it would only see 2. So this is not 1, 2, 3, 4. That's beautiful. Okay, that's really cool because of them getting pushed into here just means that this skyscraper is never going to work. Okay. So this is a 5 or a 6. Which is interesting. If it were a 6, we'd need to see the 8 before we got down to this box. So we could go 6, 7, and then we could do the 8 here, or we could do the 8 down along here. 8 in row 1. Okay, so where is the 8 in row 1? It is not there, or 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 there. Okay, so this is an 8, which is going to give us that's a 9, and that's a 9. Because we'd previously marked that 9 was in one of these two places. Okay. Okay, so this row actually only has 1, 2, 3, 4 left. Which is interesting. So this digit is from 1, 2, 3, 4, 5. 7 in row 1. Okay, now where is 7? So 7 can't go there. Can't go there. So yeah, so 7 now goes here. And now 6 in row 1 has to go here because it can't go in a box with itself. Wait, why couldn't 7 go here? 1 second. I want to convince myself again. 7 can't go here because if we did... Oh, yeah, because we need to put 7 and 8, and we have a 7, 8 in the box. Okay, then I believe myself. So these are from 1, 2, 3, 4, 5. Okay. Oh, well, this isn't a 1, owing to this 3 clue needing to see these go up. Yeah, okay, so what's left in this box? 1, 2, 3, 4, 7, or 8. Okay, that was not as helpful as I had hoped. Uh, five in row 1, column 2. Oh yeah, where's the 5 in this row? It's got to be in one of these two places, and it can't be here. So that's a 5. Beautiful. Which means that this cell is blue, because I have to see it in the column. So that's blue. Good spot, whoever spotted that. Sorry. I lost track. Let's see. Row 3, column 3 is not a 1. I agree, it's not a 1. One of these is a 1. Zeta will look at box 5 soon. Interesting. I just saw a debate on Twitter about whether being a fortune cookie is a job or not. So that seems relevant to this conversation. Let's see, those are 1, 2, 3, 4, 5. 7 8s in box 5. Okay, where are 7 and 8 in box 5? Let's just look at 8s in box 5. That's probably, yeah. So the 8 in box 5 is forced over here. Which must be joined by a 7, and then it's ruled off of the rest of this. So this is a 7-8 pair. Okay, that is a good spot. So now this Renban is, well, that's a 1 or a 6, and this Renban is everything else. 4, 5, 6 triple in row 7. Oh yeah, hey, how about that? Should probably look at that kind of thing, huh? They like, what else is on the Renban that you just fixed? I just like to keep you all in suspense. Okay, 1, 2, 3 go over here, which gives us almost a quintuple, but not quite. Painfully close to a quintuple. Let's see. Oh, so there's not a 1 on this Renban anywhere, because if there was a 1 on it, it would break this 2, 3. There's not a 2 on this Renban anywhere, because if there was, it would break this 1, 2, 3. Okay, so that's helpful, actually. So those both get pulled off of this Renban. Now I know this digit is bigger than this digit, so this digit is a 4, 5, 6, or 7. It's not a 5, I know that because of the column. So this is a 6 or a 7. Sorry, a 4, a 6, or a 7. Four, 5, 6 are on the box 7 Renban. Let's see, so see, I can't put 1 or 2 on here, so then I've got to have 4, 5, and 6 on here somewhere. Which means that this cell, I guess it's a 1, 2, 3, or 7? But yeah, just to say that. So someone points out. So I can't put 1 or 2 on this Renban. So it's a length 4 Renban that comes from 3, 4, 5, 6, 7. Which means it always includes the middle ones, which means it includes 4, 5, and 6. Okay, now, of course, that one's not a 6. We've already said that. Which means now that these are from 1, 2, 3, and 7. Sorry, this cell particularly, I should say, is from 1, 2, 3, and 7. This can't be a 7, though, because of the 4 here. Because that wouldn't work. So now there is a 7 on this Renban, and so this Renban is fixed. I think Tallcat got there exactly as I did. So this is a 4, 5, 6, 7 Renban. These are not 7. Now... this is at least a 4. So this can't be a 4. Because then it wouldn't work. This has got to be bigger than that in order to make this 4 work. This is not so clear. Let's see, can this be a 7? I don't think so. If this were a 7, yeah, this can't be a 7, because if this were a 7... Oh, and it's not a 5 either. But if this were a 7, this 4 would break. It would go low digit 7, but now 8 is gone, so we'd only be able to see 9. So this is a 6. Out of nowhere, it feels like to me. So these are a 4, 5 pair, and that's the 7. So 7 goes in one of these 2 cells. Okay, so now this 4 is seeing these digits. Oh, I was going to say, so I can't put anything higher than 8 and less than 9 in here, but it turns out there's not anything higher than 8 and less than 9. Yeah, and I guess the same thing is true here. It's not actually doing anything. Okay, well, these aren't 4 or 5, because there's a 4, 5 pair in the column now. It was never 6, despite my best efforts to add 6. So this is a 1, 2, or 3. So there is a 6 on this Renban. Which tells us exactly what it is. So this Renban is a 6, 5, 4, 3 Renban, because it's got a 6 and it can't have a 7. This isn't a 6 because there's already a 6 in the box, but that means this isn't a 3 and this isn't a 3 or a 4. Sorry. I don't think I'm allowed to rule 3 out from a thing that's literally on the Renban that I'm saying sees it. But that gives us a 1, 2 pair. Let's see. Oh, the box 9 Renban never gets away from 3 and 4. That's true. Well, why does it have to have a 3 on it? Let's convince ourselves that it has a 3 on it. If not, it would go 4, 5, 6. Oh, yeah. It definitely has a 3 on it, because if it doesn't have a 3 on it, it gets too big. In fact, actually, I think this is even more restricted. But for now, we'll note that it definitely contains a 3, so that's not a 3. So that's a 1, 2 pair, so that is a 3. So that's not a 3, and that's not a 3. Let's see. But I don't think we could put a 6 on this either, can we? Oh, we have to put a 6 on this, because we can't put a 6 here. Sorry, because we can't put a 6 here. So yeah, there is a 6 on this. Somehow I convinced myself of something about this Renban. That's not true, but that's okay. It definitely has a 6 on it. So what is this Renban? It is 6, 5, 4, 3. So that's a 1 or a 2. So that is not a 1, 2. Could be 3, 4, 5, 6. Oh, but it's not a 4, 5, or 6 because of the box. So that's a 3. So these aren't 3. Okay, now I've got to be extra careful of what's going on with these Renbans. This better not be a 6, because if this is a 6, then I can't. Then I in fact get to 2. So not a 6. Let's see. Okay, the 4 is fixed no matter what happens. This 4 is fine. But now counting down from up here is actually interesting, because now I get to a 5 or a 6. If I went to 6, I'd be broken. If this was a 6... No, sorry, that's not true, because I'd still see this cell. Oh yeah, I think we did rule 5 out of here a long time ago, for some reason or another. Yeah, because if this is a 5... Yeah, because of the fact that this blue cell's here. That's when the blue cell became gray, and then the gray cell later became blue, so this isn't a 5, so it's a 4. So... Oh, these aren't 6s, because there's a 6 in the row, so that is a 6. So that's a 5, and that's a 6. So this needs to see... No, I guess, sorry, that's not a restriction. Never mind. The 3 in this row is definitely in one of these two cells, for whatever that's worth, so none of these are 3. Which then weirdly means the 3 in this row has to go here? Is that right? That's super weird. Bye, Sam. Enjoy. So these are not 3. So one of these is 3. This isn't a 7, so that's a 7 by our previous Sudokuing. Let's see. These two cells are known. They are a 1 and a 2, like all digits in this puzzle. This 3, 5 looks over and says that that's a 4 and that's a 5. Could the 3 not be in... Did I screw this up? That seems very possible. Oh, that part was right. Okay. It's row 2 is the thing I was looking at. There can't be a 3 anywhere but here. So I think I was right. So these aren't 3. Oh, but then the next step was wrong. Okay, this was my incorrect step. I see. Okay. So that part was right, but then I tried to break the puzzle. Okay, that sounds like me. Okay. Still true, though, that that's not a 7, so that's a 7. Still true that that 3, 5 means that's a 4 and that's a 5. Let's see. This 4 is going to do fine. This 4 is going to do fine. This 4 is going to do fine. This 3 is going to do fine. This one better be fine because there's not really anything I can do about it. Okay, so this 4 has to see the 5. If this 4 doesn't see the 5, then it sees... Oh, but it doesn't have to see the 5 there, does it? Before and then 5 up here, and then the 7, 8, and then the 9. Darn. Okay. I know the order of 7, 8 in column 6. Because of this 4 clue, probably. Yes, because this 4 clue needs to see 4 skyscrapers, and it can't if that's an 8. So that goes 7 and 8. Good point. Oh, okay. So sorry. Tall Cat points out correctly. I was saying, 4, 5 would be fine, because then we'll see 4, 5. Sorry. Could see 4, 5. No, that's fine, right? It doesn't need to see the 6. Or it could see the 6. It's fine. Oh, wait, your complaint is actually it sees too many if it goes the other way. If this actually is a 5, then it would go 4, 5. It would see the 6 in one of these two cells because one of these cells is a 6. Okay, so this actually is a 3. That's the point, right? That's a 3 and that's a 5. So it doesn't see this cell, and then it needs to see the 6 before the 5? No? Oh, it's because this isn't a 4. This is a 5. Haha. I somehow saw one of the many 4s around here and convinced myself that this clue was a 4. And was then trying to make it. Okay, so the exact opposite of what I was just saying. We need to make sure it is a 5 instead of a 4. So if this was a 3, then it's not going to work, because then it would go 6, 5, and it would see the 4, the 6, the 7, the 8, and the 9, and that's only 4, not 5. Okay. So that's 5, that's 3. That's not a 5. These two digits are a 1-2 pair, which I knew before. There's not a 1 on this vertical Renban, because then it would break this 1-2. Let's see. 8 can't be on the Renban in box 6 anymore. Let's see. So 5 in box 6 is fixed. Because none of these are 5. So that's the 5. I see. Okay. Yeah, so there's no place for an 8 anymore on this Renban, as chat is pointing out, because 8 rules itself off of this Renban entirely. And so 8 is in, it's only 2 places? 3 places? Where is 8 in this box then? So 8 in this box is not in one of those places or one of these places. So orange is 8. That's the point. Orange is 8. I think orange is 8. Yeah, that's just the only place that I don't think this is even a Renban thing. I think just that's the only place in the box that can be an 8. By Sudoku. Yeah, okay. So orange is 8. Blue is 7. Yeah, so where is 8 in row 5? It can only go here. Let's see. What's left in this column? 1, 2, and 4, I believe. Row 4, column 8. Why couldn't 8 be in row 4, column 8? Because row 4, column 8 saw a 7, 8 pair in the row. that's why. Let's see. So these cells are from 1, 2, 3, 6. Let's see. Okay, are any of our other skyscraper clues at risk of being too big or too small? I need to make sure I put an 8 somewhere in here, but probably I'm going to put an 8 somewhere in there no matter how hard I try not to. The 8's going to have to go... Actually, the 8's just placed. The 8 is there. Let's see. The 3 skyscraper clue. Row 5, column 9. Yes, if this is lower than 5, it then sees too many things. So that's got to be a 6. Good catch, Tall Cat. Let's see. This is not a 5 or a 6 anymore. That's not a 6. So now there's not a 1 on this Renban anywhere. So now the 1 in this box is in one of these places. That's not super useful, is it? Yeah, I don't think that is interesting. Let's see. That 3 is automatic. What about this 5? This 5 might still require some finesse. Let's see. Tallcat says 1 is forced in column 7. Why isn't 1 here? Let's see. This is a 5. See, so it's going to see 1, 2, 3, 4. It needs to see exactly 1 more. Or it's going to see the 7. So I have to make sure... Do 7 in box 6 first. 7 in box 6 is here, just by Sudoku. So these are from 1, 2, 3, 4. Okay, so now I agree. These can't be 1 because of previous work. So that is 1. So these aren't 1. That's not 1. It's not 1 in the corner either. So, yeah, one of these two is 1, and I don't know which one yet. This 3 looks up and sees that that's not a 3. So the 1, 2, or 4. 2, 3 pair in row 1. So that is a 4. Good catch, Barbie. So that's not a 4. Okay, 4 in row 1. Yes, we got the 4 in row 1. We in the most general, or in the most generous sense of we, meaning Barbie. Let's see. One of these two is 3. Let's see. We've got the 6, 7, 8, 9. That's all good. Let's see. Is the 6 supposed to get seen or not? Yeah, this row is suspicious a bit. Row 3, column 5. What about row 3, column 5? It's not a 5 because I don't think I see it yet. Row 3, column 3. Oh, row 3, column 3. This is not a 5 because there's a 5 in the box, which gives us a 3, 4 pair, which is beautiful because those are not 3, 4 anymore. So now they're 5, 6 pair. Let's see. Yep. Okay. So Yep, one of those is 5, but we already know that. Okay, so yeah, that's not super helpful, I don't think. I guess I do know the 3 in this box is up here somewhere, which means this isn't a 3. I mean, it's a pencil mark. I'll take it. This 6 looks down and sees that that's not a 6. Yeah, I mean, this is really just a length 6 Renban. So the Renban is effectively not there anymore. Row 6, column 1. Can't be 1 because of the 5 clue. Okay, so what happens? If this is a 1, then this goes up, 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 and we end up seeing 6 things. Yeah, so if this is a 1, we're actually forced to see 6, so that can't be a 1. That is a good catch. So that's a 1, because of the now 2-3 pair in the column. That was an excellent catch, Carl. There's probably something else going on. Row 6, column 2 can't be 4. Let's see. If this is a 4, what happens? So then we go up, up, up. And those are definitely seen. Does that somehow force this to be a 6 if this is a 4? Oh, well, the 6 is... okay. There has been a retraction. 2, 3, 4. There's a 4 in this box, so that's not a 4. Should I start coloring 2 3s? It sort of feels like the time where we're supposed to start coloring things. Let's see. Can I do any more than that? Maybe not. Oh, yeah, this is blue. Let's see. Where is blue in this box? I guess I don't know. Oh, well, I do know blue is on one of these. Clean 1s and 2s in row 6. Let's see. I don't think this can be a... I don't think I know anything about this. Columns 2 and 9. There's probably a skyscraper somewhere. I don't see what's going on with the 1s and 2s. Oh, because there's a 1 in the box. Lord. Okay. Never mind. I now see it. So that's not going to be a 1. Column 9 can't be a 2. I wish so that is one thing I really wish you could do that you can do in the CTC apps is like just turn off these clues or like pen mark them with X's or whatever to say, hey, I'm done all of the skyscraper clues. Because of where 2 is in box 4. Ah, right, 2 is in one of these two cells, so that's not a 2. Okay, got it. Okay, so yeah, 2 is in one of these two. Okay, so 4, 6, 8, 9. Okay, so this one's good. So people are suggesting that perhaps instead of coloring these, we just go skyscraper clue by skyscraper clue. 1, 2, 3, done. 1, 2, 3, 4, done. 1, 8, 9, done. This is the one that can still get screwed up somehow. So that one I should pay attention to. 4, 6, 8, 9, done. 5, 7, 8, 9, done. 1, 2, 6, 8, 9, done. 3, 7, 9, done. 1, 2, 3, 7, 9, done. 4, 5, 6, 8, 9, done. Oh, wait, I should check this one too. 4, 6, 9, that one's also done. 1, 7, 8, 9, done. 6, 7, 9, done. 2, 4, 6, 7, 8, 9. Done. 4, 6, 8, 9, done. 1, 5, 7, 8, 9, done. 6, 7, 8, 9, done. 5, 7, 9, done. Okay, so the only relevant skyscraper is this one. Let's see, I probably should just give up and pencil mark this. So this cell is a 1, a 2. It's not a 2 by previous work on the fact that 2s are there. But it could be a 3, 4, 5. It's not a 3 because there's a 3 in the column. It could be a 4 or 5 or a 6, but not a 7, 8, or 9. So let's see. If this is a 6, does that break the skyscraper clue? Probably. If this is a 6, then we go 6, 5. We got an 8 and a 9. But that's fine. We can just put the 2 behind the 3. So I think 6 is fine. If this is a 6, then what happens? Then that's lower. Yeah, if this is a 6, then we see the 5, we see the 8, we see the 9. But then again, we need to just hide the 2 back here. Let's see, it does break. Okay, so if this is a 6, then that's a 5, that's a 1, that's a 3. Ah, because of that over there. Okay, got it. That's really tricky. Yeah, you've got to go through this cell. But yes, it does break if that's a 6. So if this is a 1, no, that's fine, I think. I also thought it could be 3, 2, but it got broken by this 1, 3 sort of rogue hanging out over here. So if this is a 1, that's a 6. 8, 9. And that being a 1 means that's a 3, so that's a 2 and a 4. And that's a 5. So yeah, this can't be a 1, because if this is a 1, then we force the following. Where we see 2, 4, 5, 6, 8, 9, which is too many. So this is not a 1. Oops, I highlighted too many cells. Sorry, that's not a 1. Oh, still not a 6, though. We did not lose the fact that it's not a 6. Now row 6, column 3 has to be a 5 retracted. Let's see. If this was a 6... Okay, so what if this is a 6? Does this work? If this is a 6, then we go 1, 3, 2, 4, 5, and let's see those 3 and those 2. Nope, that's fine. Let's see. Now, I guess it is interesting now to fill in the rest of this Renban, because it's now a 2, 3, 4, 5, 6 Renban, so that's not a 6. In fact, these aren't 3. Let's see. Oh. Sorry, I tried to break the puzzle. Thank you. Still true to say that these are 2, 3, 4, 5, 6. These aren't 3. Oh, no, sorry. That was based on me putting a 6 here for no reason. Okay. Never mind. Yep, sorry. But you think this must be a 6. If it's a 5, what happens? Then that's a 4. This is a 5. You only get 4 skyscrapers. So yeah, if this is a 5, that's a 4, that's a 2, that's a 3. That's a 6, that's an 8, and that's a 9. I think, no, I think you do. I think you still get the right number of skyscrapers if that's a 5. Is. These aren't 3. This is not 6 or 5. This is only 2 or 4. Let's see. Is there some mysterious... Maybe this Renban. We've never really looked at this Renban. I wonder if this Renban is meant to be useful somehow. Yes, this is not 6 again. Let's see. I don't see any huge restriction on this. Let me know if someone sees 2, 4, 6 quad in column 4. Oh, 2, 4, 5, 6. Okay, so this is a 2, 4, 5, 6, right? So this is the only place 1 can go in this column. Is that because I screwed up something? That's just because I screwed up pencil mark somehow. There's a 1 in here, pencil marked. That's not a 1. Yeah, I just somehow forgot to include 1 in here somehow. I don't think we actually get anything nice. Let's see. But this we proved couldn't be a 1, right? Because if this was a 1, I think that... Yeah, if this was a 1, it didn't work out. If I recall correctly. Row 2, column 5 is not a 2. Let's see, if this is a 2, then that's a 3, that's a 1, that's a 6, that's a 5, that's a 4, and we see 3, 5, 6, 8, 9. Looks to me like it's that being a 2 works. Oh, that's row 6, column 2. Row 5, column 2. No, row 2, column 5. Okay, if this is a 2, what happens? Oh, if it's a 2, it just doesn't have any friends, because that can't be 1 or 3. So this is actually not a bifurcate and win observation. Let's see. But I think a lot of skyscraper puzzles sort of end with this kind of like chaining, in my experience. Let's see. So I agree, that's not a 2. So yeah, the coloring the 1 2s or the 2 3s is what I was trying. So I think we're going to try coloring 1 2 3s, and see what happens. Okay, so let's see. So let's start, if we can, with 1 2s. Row 2, column 6 is not a 1. I'm not sure I see why. Let's see. Okay, so blue, yellow, blue, yellow, blue. Let's see. Pointing ones from box 1. Yes, pointing ones from box 1. So yeah, this is not a 1. Good point. Yeah, if you see any bent triples, by all means, shout them out. Pencil marks in box. Oh yeah, that was how we knew about that. Okay. Let's see. Is there like an XYZ wing or something that is useful? Well, that's a blue. That might be useful. Every Florian puzzle ends in Y wings. Okay, good to know. Good to know. Let's see. Where is blue in box 2? Well, it's definitely down here somewhere. Well, that's good enough to tell us that blue's 1, doesn't it? Yeah, blue in box 2 is down here. So blue in box 1 is up here, but it's not there or there. So blue is there. So blue is 1. I think you were right about blue in box 2. I think blue is 1. And yellow is 2. Very nice. Now, assuredly, that did something, right? Right? Tell me that did something. Finish column 6 now. So these aren't 1. So that's the 1 in the box. So that's a 2. That's a 1. This 2 bounces up here and says that's not a 2, and that's not a 2. Row 6, column 9 is a 3. That's a 2, that's a 3, that's a 2, that's a 4, that's a 3, that's a 4, that's a 2, that's a 5 and a 4. Let's see. So this is not a 2 or a 4, so it's a 3. This is a 1-2 pair, so it goes like that. Okay, so this is not a whole bunch of things. It's not a 2 or a 3. It's not a 6. So it is a 4 or a 5. This is not a 5 or a 4. It's a 3 or a 6. But this is a 6, so that's a 3. That's not a 6. So we've got a 4 or 5 pair here, telling us that that's a 2. That's a 4 and a 2 and a 3. Let's see. So, that's a 5. That's a 6. Hopefully this worked out. What do I see? I see a 2, a 4, a 6, an 8, and a 9. Yep. It turned out that worked out, and we didn't have to think about it at all. I think that's the moral of the story. That we did too much thinking, and we should have just done Sudoku instead. Let's see. 2, 4, 5, and a 6. Boop, 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 boop. Nice puzzle. Yeah, this is a really good one. Certainly more challenging for me than the 3 stars that I think it's rated on Logic Masters Germany, but well, very nice. Yeah, that very end bit was very clever, but let's see. Let's do actually, there was a Y-wing. Yes, please don't forget to like the stream and subscribe if you have not yet subscribed. See, Logic Masters Germany always rates puzzles that I think are very difficult a 3, like that one. And then any puzzle I make gets rated as a 5. I'm very happy that Arsha, my most recent puzzle, somehow managed to creep down to 4 after a great deal of fighting between the people. We'll see if it stays there. Maybe Tall Cat has been threatening to push it back up, but we will see. Oh, it's 4 of 5. Okay. I don't remember seeing Simon do this puzzle, but it's possible. But next up, we have a fuchsia puzzle called Paddock. So we have normal Sudoku rules. We have normal killer cage rules, so the digits sum to the total printed in the cage, and digits can't repeat, so that is useful for exactly those 2 cells, and no others, I believe, but those 2 are not the same. These are anti-night lines. And so digits on these lines, A, are not repeats, so I cannot put a 2 there and a 2 there. I will leave it to the reader to understand how I know that that's not a 2 to begin with. But also, this digit, or any digit on one of these anti-night lines, by a trumpical, cannot repeat within a knight's move. So if this is a 2, because it's on the anti-night line, it can't put a 2 there. So we have our lovely Knight Elvira. So we have anti-night lines, we have killer cages. Knight Florian, thanks for stopping by. Okay, so let's start with the fact that a 15 cage is either a 6-9 or a 7-8. So those are high. What else do we do? I'm sure we do something else. There's definitely a 1 inside this cage. I know that much. Because if you want to make if you want to make 3 digits sum to 8, you need a 1. Unless you're repeating some of the digits. Let's see. Oh, there's always a 9 in a 22 cage? I'll take that. I'll believe it. I'm trying to think, like, do I know where this is? It's not there or any of these places, so this digit actually only has the small handful of places that it can appear in the box. Let's see, what about this digit in this box? Not quite. Let's see. Both 22s. There's another 22? Oh, there is another 22. Ah, okay. So that's interesting because now that does not have a 9 in it. So that's not, or sorry, that's not a 9. So that's not an 8. Okay, so the 9 in this box is now forced into one of these 4 cells, which is, I think, going to be interesting. Somehow I did not spot the symmetrically disposed 22 cages. Okay, so is there one of these spots for a 9 that would be problematic with the anti-knight line? I missed a cell. Removal from row 4, column 9, home and box 3. Nine removes 6 in the 15 cage. Oh, yes, thank you. Not 8. Oops. I think that is what was being stated. So okay, so maybe we're supposed to play this old game of, are these 22 cages the same or different? Because I realize actually there's 2 flavors of 22 cage. There's the 985 flavor, and there is the 976 flavor. What if these were both the same? So let's imagine that these were both green. Would that work? So these 3 digits would end up here somewhere. And so one of them would end up on the anti-knight line. And so this digit would have to be here. That doesn't seem to be a problem to me. Where does row 6, column 9 go in box 9? Yeah, I was playing this kind of game before. Oh, but it's in a 22 cage. Okay, so that's interesting. Okay, so this digit... Oh, no, sorry. Barbie's right. This is the key. This cell could not be in those places or this place. So they can't be the same. Yeah, so this can't repeat on the line, and it can't repeat in the knight's move. Okay, so the 22 cages are legitimately different. One of them can be green, and one of them can be yellow. And that means that this digit is not one of the 22 cage digits. So this digit... Yes, Fuchsia, your puzzle! So this is a 1, 2, 3, or a 4. Just by the fact that it sees all of these 22 cages. Let's see. Also in a 9 cage. Okay, so now let's ask, now that these are different, let's ask where this cell goes, because it still can't go any of these places. So this digit does appear in the 9 cage, if I have understood the way this works. This digit, whatever it is, it shows up here in this 9 cage. which puts some pretty heavy restrictions on what it is, because I've already forgotten what the two forms of 23 cage are. 589 and 679. So this digit has to appear in the 9 cage. So I'll go ahead and give this a blue splash and then put a blue up here like that. So it's not a 9. Oops. It's not a 9. It is a 5 or a 6. Those are the only cells that can appear in a 9 cage that can also appear in one of these 22 cages. So we have that. I think you're a ways behind, Josh, but I could be wrong. So this digit now, so this might involve more coloring than I was expecting. This digit now is not in any of those places. It's not in these places. Oh, I guess this isn't super interesting. Never mind. I revert my claim about that. Okay. So these contain a 5 or a 6. So this is a 1, 2, or a 3. And there's... No, sorry. This is just a 1, 2, or a 3. That holds. Okay. Okay, so 9 cannot go in the 11 cage. So where does this cell go down here? It doesn't go there. It doesn't go in any of these places. And I can't put a 9 in the 11 cage, so that's not a 9 either. So this actually is a 9. And so this 9 goes with a 5 or a 6. If the 9 goes with a 5, then this digit's an 8. If the 9 goes with a 6, then this digit's a 7. So this 7, 8 does go into the 11 cage in one of these two places. So I'll give that a gray flash and make this a gray cell. So there is a 7 or an 8 here. And so, again, this cell's also 1, 2, 3. Okay, so now we get to play the same game the other way with this 8 cage, because now this digit is a 1, 2, 3, 4, 5. And this digit now gets pushed into this 22 cage. But the only digit from a 1, 2, 3, 4, 5 that can possibly go in a 22 cage is this 5. And so that is a 5. And I guess technically that's our second digit, but we will digit dance for that one. And for its brethren over here. So that means that's a 6 and that's a 7. And these are... Sorry, no. And these are... Sorry, I was about to say, and so that's an 8 and that's a 9, which would not have been good. And so this 22 cage, it is a 5, 8, 9 cage. That's not the 5 for multiple reasons. Okay. Yeah, the 8 verse 22 would probably have been a better start than immediately thinking about can these be the same. But by watching Simon videos, I've been programmed that whenever there's two ways to make something that shows up twice in the puzzle, I'm supposed to ask a difficult question about whether they could be the same or not, which, as it happened, got us to the same place. So these are a 1 or a 2. Okay. So now this digit's going to have to be a 2 because it's going to get pushed into... Yeah, this is just beautiful. Because now this digit's pushed into the 19 cage. But you can't have a 1 in a 19 cage. So this is a 2. That's a 1. And there's a 2 over here. And so this is a 2, 8, 9 cage. And that's not the 2. Okay. So now we have an 8, 9 pair in the column. And so now... this 18 cage is a 5, 6, 7 because that's the only way to make 18 without an 8 or a 9. That's, of course, not the 7. Yeah, this is gorgeous. Let's see. Yeah, one of these is a 2. One of these is a 2. So ergo, that's not a 2. So this is a 1 or a 3, which I guess doesn't immediately tell us anything. See, the 5 sees 5, 8, 9, cell, and box 7. Yes, so it does. That's not a 5. How did this even become a 5, 8, 9? Oh, sorry. These are not real pencil marks. These are just me reminding myself... these are just me reminding myself what the 2 ways of making a 22 cage are, which are no longer relevant. Basically me just trying to break Fuchsia's lovely puzzle. This can't be a 9 because it sees a 9 by Knight's move. So that makes this a 7, 8 cage. Looking at this here. Now that can't be the 7, so that's the 8, and that's the 7. That is a Knight's move from that. That's why it couldn't be a 7. Let's see. So... there's a 7 down... there's a 7 here, exactly, by Sudoku. 7 can't go here by Knight's move, can't go here because it can't repeat on the line, so that's a 7. So I'll write an 8 in the cell, as is our custom. So that means this is a 1, 3 to finish out this 11 cage, so it doesn't really need a color anymore, I don't think. You don't need your gray flash anymore. And now the 6 does go in the 9 cage, so we know the 9 cage is a 1, 2, 6 cage. That's not the 6, it's a 1 or a 2. So this is not 1 or 2, it is 3 or 4. So where do 1 and 2 go in this box? I guess they go in here somewhere. Let's see. Okay, do I now have to actually start doing, like, real work on this? I might have to start doing real work on this. Let's see. I'm still determined to see if I can avoid it. Let's see. If this is a 9, unfortunately, I can still just make this work. If I make that a 3 and that a 1 and make this a 2, 4... the row 1, 9 cage must have the 6. Yep, we got that. Let's see, what are these digits? 3, 4, 7. Interesting to see. Oh, this 8 or 9. Oh, maybe this is not as good. This 8 or 9 just rules itself out of this, so that's not immediately exciting. This 10 cage can't have a 2 in it, for whatever that's worth. Let's see. This 1 or 3 is in one of these 2 cells, for whatever that's worth. Let's see. Yeah, there's an 8 or 9 over here. And this 1 or 2's over here. Okay, what cage am I supposed to look at next? Oh, this column is quite congested. Let's probably fill those in. These are a 1, 2, 3, 4 is all that's left in the column. That is sadly not as good as I was hoping for. I will be honest. Okay, of course, these can't be 5, 8, or 9. Hmm, 7 in box 2. That's not box 2. What? Oh, I went to 7 in box 7. 7 in box 2. 7 in box 2. Okay, so 7 is not in any of those cells, nor is it in any of those cells. Ergo, 7 is in one of these cells. So now let's come down and look at 7s down here, maybe? Maybe that's not useful. But hey, one of these is a 7. If this is a 7, then this is a 1-2 pair. But that seems okay. That would just mean this digit and this digit were the same. Let's see. This is not a 7. I can tell you because there's a 7 in the row. So 7 now can't go in any of these places in box 1. So the 7 in box 1 has actually sort of moved its way over to one of these 3 cells. Let's see. The 9 cage in box 5. Oh, there's a 9 cage. Hey, how about that? That's a good point. Who here knew there was a 9 cage? Don't be afraid. Raise your hand. So the 9 cage either has a 1 in it, in which case the 1 goes exactly here. Yeah, this 9 cage is getting looked at by both of these. And by the 2 and the 1. All kinds of interesting things are happening with this 9 cage. Let's see. So, is it possible neither of these is a 1? If neither of these is a 1, then this is a 2 and this is a 3. And so that's a 1. And so that goes 6, 1. I don't see a problem with it. Can't have a 1 in a 9 cafe. Let's see. So where am I seeing that this cell isn't 1? It would block 1 off of this. Who's a what's it? But I mean, it would just, I guess it would just place 1 there if this was a 1. There's already 2 1s in columns 6, 7, and 8. I'm still only seeing how that would make 3 1s. Oh, because of box 6. Box 6 needs a 1. Or at least it would really like to have one. Okay, so that can't be a 1. Okay, yes. Or alternatively, as Fuchsia says, where is 1 in column 9? It's in one of these places, which means it's not. That is a really clever setup. I don't think I've quite seen that before. Okay, so this doesn't have a 1 in it for the above stated reason. So this is a 2, 3, 4 cage. That, I can tell you, is not a 2. So that is interesting. So one of these is a 2. Yeah, that was a good spot, for sure. So that gives us a 1, 2, 3, 4 triple in the column. So these are 5, 6, 7, 8, 9, with lots of things to be omitted. So, for example, none of those are 7 because of that 7. So one of these 2 is 7. I do not know which one because I have to remind myself this is not an anti-knight kind of 7. This is just a regular old 7. Let's see. Okay, so what happens with this 15 cage? So the minimum here is that this is a 5 and a 6, which would make this a 4. So this is 1, 2, 3, 4 at the biggest. Now, I can tell you it's not a 1 or a 2 because it sees the entirety of this 1, 2, 6 cage. So this is a 3 or a 4. Now, if I'm going to make a 3 or a 4, I can't do nearly as big a number as a 9 here. If I try and put a 9 in here with a 3, that wouldn't work. Let's see. So if I minimize these, I would go 3 and 5 would be 8. And then this could still be at most 7. So these can't be 8 either. Wait, did this really work out that these are now a 5, 6 pair? Did I do that right? Okay, so 3 or 4. So the minimum of these 2 is 8. So the maximum of this is 7. So yeah, these can't be 8 or 9. So that's a 5, 6 pair, which means this is a 4. So that's not a 4. Which is cool. Let's see. That's not a 4. In fact, 4 is just placed in this box by Knight's Move magic there. That 5, 6 pair pulls 5 and 6 out of these cells. Let's see. That's going to place the 4 up here. So now we've got a 7 in one of these 2 cells, so that cell's not a 7. So that cell is a 7. Oops. That cell is a 7. And so that's a 3. Life is good again. Let's see. 9 in column 6. Yes, because that 8 is looking at that and saying that's a 9. So not 9. I probably don't need the 7 pencil mark anymore. This 7, 8 means that's a 9. Means these aren't 9. So those are a 2, 8 pair. This 9 looks up and says that's an 8. So these aren't 8. Okay. Regular Sudoku is good stuff. 4 in this box is got to be in one of these 2 cells. I don't know which one yet. But that does tell me that the 4s in these 2 boxes align, which tells me there's a 4 up in one of these 2 cells, which no, I can't use anti-knight there. Because that is thingy. Let's see. 7 in the 18 cage. Tell me more about the 7 in the 18 cage. I do not see it yet. Okay, so this cell can't be that many things. What can it be? Can't be a 1, a 2, 3, 4. Could be a 5 or a 6. Can't be a 7 or an 8. And could be a 9. And this is probably almost exactly the same. This can't be a 1, 2, or a 3, or a 4. It could be a 5 or a 6. No, it can't be a 6. Sorry, this one couldn't be a 6 either. Can't be a 6 because of these cells. Let's see. This one, though, I think could be an 8 or a 9. So, unfortunately, I think 8 sneaks into this one to ruin the custard or whatever random fake British expression we want to use today. Let's see. Let's see. The 7... the 7 in this box has to be here. That's the bit about 7s that was discussed before that I did not see at the time. The 7 went there. So the 7 joins its friend, the 4, up here and makes a 4-7 pair up there. This apparently was never a 4. Oh, there's a 4 right there. So probably was not going to be a 4. Let's see. So what's left in the row? 1, 2, 3, it looks like. All looks fine. Let's see. What is left in this box that we could use? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5. Let's see, row 9. Now, how about row 9? Why not? That's not a 4. I'm going to mark while I remember. Let's see, we still need a 4, a 5, and a 6. That's not a 4 or a 5, so it is a 6. So these are not 6. So they are 4 or 5. So what about this column now? This column is 3, 7, 8, 9. I already know this cell's not a 7. I know neither of these cells is a 9. Let's see. So one of these two cells is a 9. Don't know which one yet. Let's see. So what are these two digits? We have left a 1, 2, 3, 4, 5, 6, 7, 8, and a 9. Well, that's definitely not the 9. Okay, so the 9 can only go here. I wonder how long that's been sitting there. Probably approximately forever. So that's not a 9. Not a 9. So that is a 9. Row 7, column 8 is close to being naked. Let's see. It can't be a 1 or a 3. It maybe can be a 2. It can't be a 4. It could be a 5. It looks to me like it can be a 6, but can't be a 7, 8, or 9. I'm guessing I'm missing an elimination from row 7, column 8, based on that response. Oh, 2 is too low. Oh, yeah. If I look at the cage, that would be a very wise thing to do. It cannot be 2, because 2 will not add to 12. So this is a 5 or a 6. Let's see, which gives us a 5, 6 pair in the row. Let's see. So row 2, column 3 is a 6. Okay, so these are from 1, 2, 3. So this needs to be uh, 7, 6, or a 5, and it's not a 5. And it can't be a 7 either, so it's a 6. These are a 1, 3 pair. It couldn't be a 7 because then it would see this 7, and that's not allowed. So that's not a 3. So this is a 2. So that means the 1 in this column by previous work is over in one of these two cells. So that's a 3 and that's a 1. Let's see. So if this is a 6, then these would have to be 1, 5. If this is a 5, then these would have to be, I don't know, like 1, 6 or something. Who knows? Okay, the 2 in column 6 looks downwardly. So it does. So that is a 2. Is a 2. So none of this nonsense is 2, including that nonsense. So let's tackle that again. So if this is a 6, this has to be a 1, 5 pair. Seems fine. If this is a 5, what is this going to be? It can't be 3, 4. It can't be 2, 5. So it would have to be a 1, 6 pair. Yeah, so 5, 1, 6 seems to work. Oh, but this digit has to go in this box. Where does this digit go in this box? Actually, this digit only goes up here in this box. So this is a 6. Just by asking that question, which is the correct question to ask. Where does this digit go? It goes up there. So this is a 6, which means this is a 1, 5 pair, which means that is a 4, and that's a 3. And that's a 6, and that's a 5. And that's a 3, and that's a 4. Let's see. Dictionary said something. If row 7, was saying the thing about where does this go in this box, woobly woo stuff. Okay. Let's see. What are these 3 cells? They are 5, 6, 8. These aren't 5, so that is 5. So these are a 6, 8 pair. What about these 2 cells? Actually, what about these 3 cells? Let's do them en masse. 1, 2, 3, 4, 5, 6, 7. Oh, not 5, sorry. 6, 7, 8, 9. They are 3, 8, and 9. These aren't 8. So that is 8. Let's see. So this is a 1 or a 7. That looks right. Okay. This 6 looks down. So that's an 8. That's a 6. Let's see. What can this digit be? It sees lots of things. Okay, so it can't be a 1. It looks to me like it can be a 2 or a 3, but not a 4, 5, 6. Looks to me like it could be a 7, but not an 8 or a 9. Oh, it's not a 7 because there's a 7 across the row. So this is a 2 or a 3. I don't think I know which yet. What about this digit? What can it be? Okay, so not a 1, not a 2. Looks like it could be a 3 or a 4, not a 5 or a 6. Looks like it could be a 7, although I said that last time and turned out not to be correct. But not an 8 or a 9. So 3, 4, 7. This is not a 4. Not a 4. Did you just call me Qodec? I will color anything that can be colored. That is the basic gist of all of this. Let's see. Where's 5 in column 7? Sure, why not? Where is 5 in column 7? It's there or there, but it's not there, and it's maybe there. Oh, retracted. Okay. You can clean up a couple of 8 pencil marks in box 7. That sounds like the kind of thing that I might be into. Let's see. Yes, there is a 2-8 pair there. So those are not 8. These are 3, 7, or 9. Let's see. What about this cell? We had fun playing this game with all the others. What can it be? It can't be a 1, a 2, a 3, a 4. Looks to me like it could be a 5. Can't be a 6 or a 7. Could maybe be an 8 or a 9? Yeah, I think that sounds right. The 2-8 is resolved. Oh, the 2-8 is resolved. That is very helpful. That's a 2. That's an 8. At least I thought it was going to be helpful. Maybe I spoke too soon. Oh, this cell. I never did this cell. What is this cell going to be? Could be a 1. Can't be a 2. Can't be a 3. Looks to me like it could be a 4. I think it can be a 5. Can't be a 6. I think it could be a 7 even. Can't be an 8 and can't be a 9. Okay, that one was not as exciting as some of the previous ones. 1, 6 in row 1 is resolved. So it is. Thank you, Andrew. We should fill in what these cells are, because they're lonely. Let's see. 2, 4... No, not 4. 5, 6, 7, 8, 9. Okay, 2, 5, 8. Let's see. Do I know anything about 2, 5, 8? Seemingly no. Row 8, column 8 is a 2. Oh yeah, this 1 looks down and sees that that's a 1 and a 5. That's a 2. It's just the only thing left in the column. So that is not a 2. Among other things. So now this is a 2 and a 1 and a 3 and a 1 and a 3. So that's not a 3. Let's see. So the 3 is up here. The 3 is not there. So the 3 is here by Sudoku. So that's an 8. That's a 7. That's a 9. The 3 now... Sorry, I retract. I do think this is 1, 4, 5, or 7, but I don't know that that's worth pencil marking at the moment. Let's see. Where is 5 in column 7? It can't be on the line. If it was on the line, yeah, because that would remove 5 completely from the row by knight's move. So that's not a 5. Not a 5. Okay, so that's not a 5, that's not a 5, so that's a 5. It's a 6 and a 5. So left in this row is a 2 and an 8. So that's a 2, and that's an 8, and that's a 2. That's a 3. This is a 1, it looks like. So that's a 7 and a 3 and a 9. Someone said way earlier this 10 cage was forced. I'm very curious if they saw something way earlier that made that. Or maybe they were talking about this 10 cage and I didn't even think about it. That's also possible. Life is nothing but possibilities, as they say. 1, 4, 7, so that's a 5. So that's a 4, and that's a 5. That's got to be a 1. That's got to be a 1. So 2 in this row goes here. 4, 5, 6, 7, 8. That's the 9. That's an 8. This had better be known. That's a 6. Let's see. 1, 2, 3. That's a 4. That 5 looks up. That's a 9. That's a 5. Very nice puzzle, Fuchsia. I enjoyed that one a lot. I really like anti-night, but it's such a pain as a setter. I think this sort of like local anti-night region is a really good idea. And I think the idea of an anti-night line where it also doesn't repeat on the line lets you do a lot of the coolest anti-night stuff without having to make it so that your puzzle has no solutions immediately. Yeah, that was a lot of fun. Okay. Next up, I'm going to do one more puzzle, hopefully, and that is the puzzle Up and Down, or Up/Down, by the Cogito, the other Sam. Yeah, I think something like an anti-night line would be a really great thing to include in a solver so that you could make sure that you weren't breaking things. Like, we haven't had any solvers or whatever that have sort of like a local anti-night thing, but I would really like a local anti-night constraint. Okay, so we have in this puzzle Renban, which means these things contain a string of consecutive digits. In any order. And then we have these whisper lines, and the thing about a whisper line is you have to make sure you always change by at least a difference of 5 along the line. I mostly just say things like that in case Ranksk is listening in hopes that it will magically make it into F puzzles without me having to do anything. Or into Sudoku Lab? Is that the name of the thing? I'm not sure. Okay, so this Renban, to start with, this is length 6. So it needs to have a 4, a 5, and a 6 on it. Yeah, Schrodinger definitely has to make it into the solver. I don't think there's any doubt about that. After all, Schrodinger is the new 159. Hey, Sam! Let's see. I don't think Sudoku Lab is the thing I meant to say. Let's see. Okay, so let's try coloring this. So I don't know the difference between high and low yet. So I'm going to just color one of high and low yellow and one of them green. And that's immediately interesting. Because it means that this digit has to be a 5. Which is great, because it's going to place a 5 on the Renban. Okay, so how do I know this digit's a 5? Well, all the yellow parity digits, that is, all of the things that have the same high-lowity, they're all gone. And I can't skip from a yellow digit to a green digit without this. Okay. And so just to be clear, yellow is 1, 2, 3, 4, and green is 6, 7, 8, 9, or possibly the other way around. Okay, so these are either... Sorry, let me just immediately say that places a 5 here before I forget, and then get mocked for saying it out loud and then not doing it. So this is a 5, and then these two are the same high-lowity. So they're either a 6, 7, or they're a 3, 4. Well, there's a 7 in the row, so they're a 3, 4. And so these are a 1, 2 pair. And so now we can get rid of green and let green inherit its true color of orange, and yellow inherit its true color of blue. Because no matter what Simon tells you, Low is blue and orange is high, not the other way around. So these are orange. This is gray because, boy, he hasn't been around so long. I've forgotten his name. What's the name of the person who likes me to put 5s in a color that's not gray? I've forgotten. Well, the 5 down here is there, and these are blue. I feel bad. I should remember his name, but I don't. Let's see. Okay, so one of these two is a 9. Casey! There we go. One of these is a 9, and one of them's an 8, so these are an 8-9 pair. Because I need a 9 to go with a 4, and then once the 9 is gone, I've got a 3 that has to go with an 8. So this is a 6. So this is a 7, 8, or 9. I don't know which. Let's see. Where is 5 over here? Nowhere useful, is it? 5 in this box, nowhere useful. I'm guessing 5's not going to be able... I'm guessing 5's going to get ruled off of this Renban. That's my prediction as to where this is going. But who knows? Let's see. Yeah, so these are 7, 8, 9. So therefore these are all blue, because these are all the same color. Well, sorry. This pair is the same color, so they must be blue. This pair is the same color, so they must be blue. So these are red. Sorry, orange, not red. There's no such thing as red. Don't worry, Bender. So these are 1, 2, 3, 4. No 3 over here. So these are 1, 2, and 4. One of these is definitely a 3. Because one of these is a 3, that tells me this has to be an 8 or a 9 in order to be far enough away. Let's see. 6 looks up. 6 does look up. Always look on the bright side. So one of these is a 6. So one of these is a 6, and it's not one of the ones that's not a 6. So it's the one that is a 6. So that's a 6. So that is cool. Let's see. These can't... This is cute. These can't both be blue. Wait, no, sorry. Never mind. I retract. These could both be blue. Never mind. Don't listen to me. Where's 5 in row 6? Perfect. I was right. Haha. I knew it. For once. My prediction came true. This 5 can't have a 1 on it. And so it's all one color. And so it's blue. So that's orange. I really enjoy that deduction. So I was hoping that it would turn out that way, and it did indeed turn out that way, that all of this is blue. So this is a 1, 2, 3, 4. And so now these are all... Oh, sorry, no, that's not true. Don't listen to me. There's a 5 in here and a whole bunch of oranges. That's the story. Sorry, I promised Tristan I wouldn't do my southern accent on stream. Box 8 can't both be blur. I'd believe that. Let's see. 2, 3. Okay. How many blues have to be on here? Well, I need a 4. But then this could be 4, 5, 6, 7, 8, 9. I think. If this was a 4, 9 or something like that. I'm not sure. Okay. This sees 6 different blue cells that might be the same. Okay, so if these were both blue, it would force 4 blue digits into... yes, that's right. It If these were both blue, it would cause a very big problem up here in box 2, because now I would have to put all 4 blue digits here. And since this is not a Schrodinger Renban, I cannot do that. So ergo, these are orange. As I tried to prove before unsuccessfully, but Tallcat got me there. Okay, where's 1 in column 5? Let's see. Is there a 1 on this Renban? If there's a 1, there would have to be a 2. And so this would have to be 1, 2. But then there'd have to be a 3. Okay, so there's not a 1 on this Renban. So follow me on this journey. If there was a 1 on this Renban, it would have to go up here because of the 1, 2, 3 triple looking over here. But then I'd also need a 2. And that would also have to go up here. So far, so good. But I'd also need a 3, and that would also have to go up here. And at this point, my friends, our journey ends. So thank you for coming on this journey with me. The 1 is down here. Good catch, Barbie. So this is a 2, 3, 4 triple. And spoiler, this is not a 4, because if this was a 4, this would have to be double 9. So that is a 9, because one of these is a 4. So one of these is a 4. So now, Schrodinger Renban is great fun, and I am happy to tell you that if you would like to do a Schrodinger Renban puzzle, there is one right now on Logic Masters Germany that I said after the last stream that I highly recommend, as long as you promise not to change its rating from 100% on Logic Masters Germany. Tallcat gets to do that. Why can't row 9, column 7 be a 1? Oh, sorry, it could totally be a 1. Don't listen to me. Oh, no, that part still is good, but the 1 is in one of these places. Got it, okay. Yes, Tallcat's only goal is to get it rated as being too difficult. Let's see. So these aren't... So the 4... No, sorry. The 4 is almost certainly up here. Let's see. We've got the little itty-bitty whisper line. I feel like this should do more for me than it has done. Let's see. But it has so far been intransigent with me as far as giving me something, despite the fact that I predicted that this would turn out to all be blue, and then it turned out that way. Let's see. Okay. Reconnoiter. So the 3 is over here somewhere. So this is an 8 or a 9. Blue in column 5. Let's see. Let's see. Tristan, if he's listening, can post a link to Arsha on CTC in the chat. Let's see. I have aligned blues in boxes 5 and 8. So there's one... okay. Got it. So this was Tallcat's point before, but I did not fully appreciate it. There can be at most 1 blue up here. There can be at most 1 blue up here, because there's already 3 blues here and 3 blues here. And so, therefore, there must be 2 blues up here, because I need to get 4 blues in this box somehow. Yeah. And now, that means these are... Oops. No! That means these are a 3-4 pair. Which means that all of these are orange. Beautiful, beautiful setting. And so I know what they are. they're 6, 7, 8. And so that's a 9, and that's a 4, and that's a 3, and that's an 8. All over the place. Okay, good things are happening. Let's see, just like on next door. These are blue. So this is gray. So these are a blue-orange pair, I suppose, for whatever that's worth. Not much, I dare say. Let's see. So this is a 3-4 pair just by Sudoku. So that's a 9, because only 9's allowed to be adjacent to 4. This is a 1-2 pair, which means that this cell is a 1 or a 2, because it is that cell. Let's see. This is a 1 or a 2. So these are not 4. So one of these is a 4. So this is an 8 or a 9. It's not, sorry. This C's 6, 7, and 9. So this just is an 8. No ifs, ends, or buts. It just is an 8. I feel Tallcat has let people peer pressure him into doing this puzzle that he originally promised he would not do. Let's see. What is this? Large pot of coffee might help. I'll stand by. I think of it as a romp. That'll be my my saying. Okay, let's see. 4, 9 up there. Let's see. Let's see. I don't know. I think the moment when you walked into Discord and there were like 3 different people doing it at once, I think that was more responsible than me, but I'm not sure. There's 1 high in this column, so there's so this Renban. Why didn't I look at this Renban? This Renban is also monochromatic. This Renban has to either be all orange or all blue. Which is it? Is it all orange or all blue? Let's see. If it was all orange, this would be a 9. And this would be an 8-7 pair, and it would break that cell. Wow, that's amazing. Okay, let me go over that, because that's so gorgeous. I want to talk about it. Okay. So this 5 sees the entirety of this line. And so this line cannot have 2 parities on it. So it's only 1 parity. Is that parity high? Well, if that parity is high, then it has to be this cell has to be a 9, which then by Renban-y goodness means that that's a 7 and an 8. But now we've broken this cell. So, in other words, all of this is low. And then I'm going to look at SPQ asks why column 5, row 1 and 2. Sorry, column 5, row 1 and 2. Why did they have to be 3 and 4? Here's why they had to be 3 and 4. So I had this 1, 2, 3 triple looking at this part. And so if I want to have... Oh, did I cheat? I might have cheated. Because I could have had a 4 over here, couldn't I? Could I have had a 4 over here? It's now far enough ago, I'm not 100% sure if I accidentally assumed that these could not have a 4 in them. Because I don't remember what order I found all of this in and that kind of thing. Did I cheat? Does anyone remember? I feel like I was peer pressured into it by Tallcat, so I mostly blame Tallcat. But if I have to back up, I'm going to have to back up a good ways to get back to where I did this. But yeah, if there was a 4 here, this could have been 3-2 or something like that. Let's see. Okay, let's go back. Okay, so we do know both of these have to be blue. That's for sure. So because both of them have to be blue, we now know that there is a 4 and a 3 on the Renban. Okay, so really the correct thing to note is that there has to be a 3 here on the Renban. Because the 3 can't go down here. And if I'm going to get 2 blue cells, I'm going to have to go at least 2 below the 5. So so we now know there's no 9 on the Renban, so there's a 9 over here. Oops. So now that means this is an 8 and a 4 and a 3 and a 9. Just to finish that off. So now these digits, well, there's a 5 over here. I probably could have placed that a long time ago. Let's see. So these are from 2, 3, 4. Oops. These are from 2, 3, 4. Wrong order of... Thank you. Good catch. I just put the 3 and 4 in the wrong order. I guess I have been doing this for 7 hours and 45 minutes, so I suppose I will forgive myself this time, but... let's see. Okay. So... So yeah, there is a 6 over here, for sure. We need a 7, which is going to have to go over here as well, although that's nothing profound. Let's see, I have a 1-2 pair in box 4. I do have a 1-2 pair in box 4 because of this. And that's going to get us back to where we were. Okay, so... sorry, I've lost track of who said this, but you completely... I lucked into it. I was going to be right, but you completely were correct. I did not justify why there had to be a 4 here. But now there's a 1-2 here, and so now these can't be blue. So they're all orange, and so these can't be 2 anymore. And so these are a 6, 7, 8 exactly. These are a 3, 4 exactly. These are a 1, 2 exactly. The 3, 4 means that has to be a 9. Let's see. So this is an 8. And so now we get to redo the thing that I should have done almost immediately before. In fact, probably as soon as I got this 5, I could have done this, which is to note the beautiful thing that these are all blue, because they cannot be anything but blue, owing to this 5 seeing the entire thing. So those are blue, again, because the only digit this can be is a 9, and these can't be 8, 7 because it breaks that cell to go back in time to where we were. Okay, we're supposed to finish coloring column 2. There's 2 oranges at the bottom. So these are blue. So I want to go back and look at this. So this is a 1 or a 2. Let's see. So this is a 1, 2 pair with a 3 there. So that's a 4, which makes that a 9, which makes these not 9s. Yeah, you were completely right. My brain just glossed over it because we just proved something similar didn't work, but it was not the same thing. Okay, so now I've got all the blues in row 3, so those are orange. So yeah, this is just great. This is fun time solving. So this digit is this digit is this digit, I think. But at least those two are the same. But anyway, this is a 1, 2. Let's see. So what is this? I guess I don't quite know yet. This is a 4, 9 pair. Let's see. What is this? I guess this is only 6, 7, or 8. So that means the 4 is actually not on one of these because there's a 9 in the box. So one of these is a 4. So one of these is a 4. Let's see. The box 9 whisper is fixed, I hear. Because I can't put 2 blues down here, you mean? Because there's only 1 blue left in the row? That sounds good. So orange and blue. Okay, so now we're done with our coloring. And we've placed a 4, owing to that tall cat point about whatever it was he said. So that's blue. Yes, as Ranks says, 4 isn't orange. So that it was very helpful. So this is a 1, 2 pair. Okay, great. Because that now tells us that this digit is a 3, because otherwise the Renban doesn't work. And if there's one thing that's important to me about Renban, it's that they work. Now this digit is that digit, is this digit. I don't know if this is worth doing, but I'm going to put a yellow flash in those just so that I can pay close attention to where the yellow flash one goes. So this digit I just know is a 4 because I could just write it in, so I don't know why I didn't. These are a 1, 2, 3, but not the yellow 1, 2. Let's see. So this is a 1 or a 2. Sorry, that's not true. Don't listen to me. What is this cell? Well, it's either 4 or it's orange. But I guess I don't see why it can't be 4 immediately. So where is the yellow 1, 2? Well, the yellow 1, 2 certainly isn't here. So the yellow 1, 2 is up here in one of these. But there's a 1, 2 pair in this column. So as Tallcat alludes to, I am famous for putting these flashes and things. So the yellow 1, 2 is up here. So that's the yellow 1, 2. So this is probably a good time to introduce purple 1, 2. I don't know how this became an orange. We're just not going to talk about it. Let's see. Do we have all our 1, 2s? No, we don't have. Oh, there we go. Okay, so that's purple. That's yellow. That's purple. Let's see. And so I know that this cell's not a 1 or a 2. I know that this cell's not a 1 or a 2. That's exciting. Okay. Row 1, column 6. Someone's talking about. Should I start coloring the 3s and 4s? Is that what's being suggested? Because it's possible that would be helpful. Let's see. So there is a... Oh, no. There's a 5 in one of these 2 cells. That's annoying. Let's see. Orange at the top of column 6. Excellent. Excellent. That is super helpful. Thank you. So that's a blue. So that's a 4. And that's a 9. Beautiful. Okay, so that's going to be huge. So that's a 3. That's a 4. So this is the purple. That's a 3. Coloring time. Okay. So where is purple in this row? It's exactly there. So now this is a 3. And completely by accident, I think the coloring accidentally helped. This is not a 9. This is an orange. Oops. It was not intended to have a flash in it. Let's see. So this is the last orange for the column. Let's see. So these are from 6, 7, 8. This is 6, 7, or 8. But this, yeah, this could be it. Sorry, this could be a 6. Although it'd be a little disappointing if I resolve the coloring too soon. Let's see. So this might have a 5 on it, but it definitely has... Let's see, what is definitely on here? Oh, well, this can't be a 9. Can it? 8, 7? Maybe this can be a 9, actually. Never mind, I retract that. There's no way, though, this line doesn't have a 7 on it, because 5, 6, 7 is hanging around here. So there is a 7 on this line no matter what. And that's not the 7. Let's see. This 4 looks down and sees that that's a 9 and that's a 4. So that's an orange and a blue. Gorgeous. Okay, so this is a 6 or a 7. That is interesting. Good night, Alima. Thanks for staying up with us. One of these is a 9. Oops. Did too much highlighting. Let's see, that's probably not blue. Yeah, this isn't blue. Because there's all the blues in the orange. And it's not gray, so that's orange. For what it's worth. So one of these is a 3, and it's not that one. So this is a 3, and is blue. I wonder if chat mentioned that. Let's see. This is an orange. This is a 6 or a 7. So that's a 6, 7 pair for the box with an 8. So that's a 9. So this 9 shoots up here and tells me that the 9 up here is there exactly. So when I said this obviously wasn't 9, that clearly was not well predicted, because now we've got this whole whoosly-woo. So this is a 7, 8 pair. This is not a 6, so this is a 9. Let's see. We're doing well. We're doing well. I feel good about the progress here. Okay, so there's a 4 up here somewhere. No, there's not a 4 up here somewhere. There's just 2 oranges up here. Don't mind me. So these are from 6, 7, 8. Yeah, that's a little disconcerting. Let's see. Yeah, one of these is a 5, and one of them is a 6, 7, 8, but I don't think I know anything about that. This 8 looks up there and sees that that's a 7. Thank you, Barbie. So that's an 8. That 7 looks down and sees that that's a 6. So now the yellow is a 1. 1, 1, 1, 1, 1, 1, 1. And the purple is a 2, 2, 2, 2, 2, 2. Let's see. And so that's presumably going to be the kind of thing that is helpful. So that's a 7. By similar logic, these two digits are a 5 and a 2. Don't know anything about that yet, though. Yeah, I feel like this is one of those times where, despite my best efforts, the coloring proved useful. Let's let's see, this is a 1 or a 2. So one of these is a 3. So this can only be an 8 now, because it's gotta see a 3, and it's not a 9. So that's not an 8. It is a 6 or a 7. But there's a 7-8 pair in the column, so that is a 6. So that's a 1. So one moment, that means it's a yellow, which means yellow is over here. We've not yet solved the mystery of purple, though. Let's see. So this is an orange digit. That is not 6. So it's 7 or 8, I see. And so now the 6s here push a 6 up here, which is delightful. And so now this is a 9 just by Sudoku, and I broke the puzzle. What did I do? Oh, no. Oh, because this could have been a 9. I don't know why I said the... Okay. So this is still a 6. That part I agree with. But this is a 9. How about that? That's better. Because, well, this is not a 9. So this is a 7 or an 8. That's a 7 or an 8, but it's not an 8, so it's a 7. So that's an 8. So that's a 7. That's an 8. That's a 7. That's an 8. Things going in all over the place. Let's see. No 7s up here, meaning the last thing I'm trying to fit in this box is a 7, which I don't know anything about. Let's see. Yeah, one of these is purple. One of these is purple, and one of these is purple. So Andrew points out there's an X-wing on purples. There's a purple here and a purple here. So that means the purple in this box is not in any place except this one. So this is the purple, which means it's not 3, because we know at least that 3 isn't purple. We'll find out what purple is eventually. So that is a 4 and a 3. Let's see. And so this 4 bounces back and says that's not a 4. So that is a 4. So now, let's see. We need a 6 and a 5 in this box. Oh, yeah. The 6 has to go up here because there's a 6 there. So that's a 6 and is orange. That's a 5 and is gray. So that 5 tells me that 5, oops, that's a gray 5 up here. Let's see. It's always hard to tell with me. That's a 7. Now this 6 looks up and sees that that's an 8, and that's a 6. That's a 7. That's a 6. That's an 8. Let's see. And then this 5 over here becomes a 2 and a 5. So that's purple. So purple is 2. Let's see. It's a self-defense mechanism. Let's see. So this is purple-blue. Let's see. And so this is a 5. Let's see. Okay, so let's fill this in. So 2 goes there, 1 goes there, and 5 goes there, and then we're done. Yeah, that was a great puzzle. I really liked that one. Very snappy. I was expecting it to be a little harder than that, but just perfectly smooth. Let's see. I hear chat complaining that this is not a 5. Let's try again. So if it's not a 5, what else could we make it? There we go. Now it's happy. So There we go. I'm about to go eat some pizza. But for now, so thank you all for coming by. Remember, we have the Patreon as usual. So if you want to contribute to the Patreon, it's patreon.com/zetamath. But no pressure. I enjoy hanging out with all you. I appreciate that people come by to watch me to watch me solve Sudoku. I have a lot of fun. So I'll be back on Saturday. So that should be streamed. So there'll be additional stuff. What my favorite puzzles or some of my puzzles or whatever video will be up. So you can see a link to a whole bunch of puzzles come soon. But I will see you all Saturday. And if you've not yet tried my latest Logic Masters Germany puzzle, and you have any interest in finding ways to put zeros in more puzzles, I highly recommend it. Have a great morning, afternoon, evening, whatever time it is where you are, and I will see you all very soon. Ta-ta for now.